wafer level micro optics is.
You know what I love about these meetings is that I can make my friends get to know each other. So my friend Samuel, the CEO of Imagine Optic, just joined the channel. Samuel, we are talking about micro optics, the micro optics revolution in Europe, in general, the high-end optics revolution in Europe. And I know that Imagine Optic can help us inspect these optics. Can you tell us in short what Imagine Optic can supply to the optics manufacturers in Europe? Let me, yes.
Okay, is that good? You can hear me? Okay. So thank you, Jose. Yes, so Imagine Optic is manufacturing Shack-Hartmann wavefront sensor based on micro optics. We already have some relation with SUS micro optics, of course. And so thanks to this micro optics, you can measure the wavefront with a very high accuracy and a very robust method. The robust method, I name it, it's Shack-Hartmann. And you can do any kind of optical metrology and beam, laser beam metrology. Oops, is it cutting? No, you can hear me? Let's say. And so you can do, so optical metrology means measuring the wavefront with this instrument, and the accuracy you can reach thanks to good micro optics, like micro optics is making. You can reach lambda over 100 accuracy on the wavefront measurement in a quite standard and easy way.
One thing that Reinhard and I discuss a lot, we think that when it comes to metrology, people are not really in line and there is not really standards to do metrology of high-end optics. How does Imagine Optic can help solve this? How can we align all the optics manufacturers in comparing tomatoes with tomatoes and apples with apples?
Well, I think that the wavefront is a physical, parameter. So once you have the methodology, at the end of the day, the metrology is something which is critical in the manufacturing process. So we are linked to some standards. It's quite easy to measure a wavefront independently of the setup of the system. We have all the methods of calibration of the wavefront sensor. And of course, when we sell a wavefront sensor, we are able to go to the customer site and install it, define the process of using it, and so on. And so that means a wavefront that you are measuring on the femtosecond laser, the wavefront you are measuring at the output of a semiconductor stepper optics or a classical optical components is really the same. It's a physical parameter that you can detect at the level of the camera, at the level of the wavefront sensor itself.
So do you think this is the parameter that we can use to compare everything? Let me ask this to Reinhard. Reinhard, do you think this is the parameter that we can use?
Yeah, for the optical quality, definitely. This is the parameter. The good parameter is the wavefront.
Yeah, we also do a lot for Shack-Hartmann. I don't know where you get the micro lenses, but the thing for all the Shack-Hartmann people always told us when we were asking what is the beam pointing accuracy, they said they cannot measure any difference from lens to lens. So it means our lenses are better than Shack-Hartmann can test. On the other hand, you can use a Shack-Hartmann to test the lenses. So that's a big win-win in the Jose 2 direction now.
Yes, and I'm going to go 3 directions now, because one thing that we are targeting with the micro optics is to help assemble new optoelectronic devices. And I'm thinking about LiDAR, because what we saw earlier this morning with the dense light presentation is that the LiDAR for optoelectronics is booming. And LiDAR devices need micro optics, even micro lens arrays. I would like to ask our friend Rolf from PI, Physik Instrumente in the beautiful city of Karlsruhe. PI has been helping EPIC in many different projects in alignment of the micro optics. Do you see a big boom on alignment of micro optics for different markets?
Yeah, that's right. And I really can't say what Reinhard told. Automotive in this case is active because they see advantages there. And so in a lot of fields for micro optic assembly, we see the need of higher precision. Yeah. And that's what people are asking us, and where we can support them with our positioning technology, or also for qualification processes. Yeah.
When it comes to LiDAR solutions, this is one of the big challenges they can see. So first of all, LiDAR for automotive requires low price, requires certain volumes, but not very high volumes, but low price. And when it comes to the assembly of optoelectronics, very often we go to active alignment, especially for the micro optics. Do you see the fact that people are going for active alignment a problem to address this kind of low cost in low volume markets?
Yeah, we see this problem there. So, but we discuss very often during EPIC meetings that if you go for active alignment, you have to spend a lot of money for the positioning tasks that needs to be solved. But then you can work with, let's call it less precise parts. So the parts are less pre-processed in the interfacing situation. If you want to go for passive alignment, then you have to have more precise parts. And I'm not talking about the optics itself, but the chassis of the optics or whatever. And so precision is needed at one or the other side, and there we can help on both sides. Yeah, active alignment is a very important part. If you go for passive alignment, then you have to have higher precision in the pre-processing of your components.
Reinhard, what do you stand on the LiDAR? Is that LiDAR, do you think it's a huge market for micro-optics? Do you think there is some hype there? Where do you stand?
Yeah, we were both at Ontario in November, and the resume was that there's 1 million systems with 200 companies that try to get the technology in. So for sure, LiDAR, I think LiDAR will work with lasers, and there will be collimation, and they will need some micro optics. But for now, it's too big, too bulky, too expensive, but there's no doubt some company will have the great LiDAR solution, which is small, lightweight, powerful, and there's no doubt there will be micro optics inside. But still, it's not mature. So whoever needs micro optics, we do it for 180 customers. So we will also do it for LiDAR.
Thank you very much, Reinhard, for leading this micro-optics revolution. I think we are going to conquer the world. And again, it's the biggest thing that I've seen in photonics in the last 20 years. Let's exploit it to the end. And I think there is no end. There is no end because we always need high-end manufacturing, high precision, easily manufactured. Yeah. Remember, nano imp lithography, low cost, replication, high-end multi-level optics. This is where we're going. Sus, you are the star. Reinhard, thank you so much for this Easter egg. Everybody is amazed to have you this morning. We continue with the program until the next time, Reinhard.
I will follow you until the end.
Are you sure? 20,
yeah, sure,
I still have 18 hours to go. And we continue and we go to Lithuania. I'm getting old. That's why I'm losing hair. I'm getting old. I met BROLIS Semiconductor already, something like 15 years ago. Actually, I met Markus Amang, professor at TU München, 15 years ago, and he told me I am setting up something really big in Lithuania. I don't think he even knew how big this was going to become, because right now we are talking about one of the success stories of laser and detector manufacturing, all the way to solving different problems in different market segments, not only Lithuania, but also in Belgium, multinational company, a success story of Europe. It is so great to have BROLIS Semiconductor with us. It is so great to have Augustinas with us. Augustinas, a show for being with us this morning. The floor and the attention of everyone in the world goes to you. It is 8:40 in the morning in Northvik. What time is it now in Vilnius?
Hi, Jose. Good morning. It's 9:40 actually, so it's okay. It's not too early. So thank you for inviting me here, and let me try to share my screen so that I do not run out of time. So let me see if the view is okay. So again, I'm Augustinas Vizbaras. I'm one of the founders of BROLIS. Now BROLIS is more than just one company. We have 4 business entities within the groups. And BROLIS actually in Lithuanian means brother, because we are 3 brothers that founded this company. So it's myself and my 2 other brothers. And then, yeah, so today I'll just tell a little bit about our story and a little bit about the businesses that we do. And I think it's pretty diverse. It's all related to semiconductors and optics and photonics, but it's also at the same time quite diverse. So just a little bit on the corporate structure. So here you see a block diagram of who we are. It's a bit confusing, but this is just, as I call, basically a result of our really winding road of how we evolved, so managed to survive a difficult path of setting and starting up a real hard company. So we changed a lot of, many times our business model, many times we did change, the goals, the strategy, but eventually we succeeded, and this evolved into a successful, profitable business that today is being run in 3 different European locations, and we focus on 2 different business lines. So one is now governed under the BROLIS Defense Group, so it contains 2 entities: BROLIS Photonics Solutions in UK, Northern Ireland, and the BROLIS Semiconductors, our historical mothership company in Vilnius, Lithuania. So this company group of these 2 entities focuses on development and manufacturing of semiconductor electronic devices for defense and security applications. And devices in this case means that we start really from not component level devices, but we go all the way to final end user systems. That means we really make complete electro-optic systems for end users. And the other company group is focuses on everything that's non-defense related, and we focus on development of really, I do believe, a cutting-edge technology, which we call as a next generation of ultra-compact laser-based photonic integrated sensor technology for various sensing applications. And this evolves our basically a combination of our gallium antimonide technology and the integration it with a silicon photonic integrated circuit. So we kind of develop a full system on chip solutions at wavelengths that are beyond telecom. So it's quite exotic field, but we believe and we are confident that there's quite a lot of really interesting market opportunities there. And this company group is governed under BROLIS Group, so we kind of separate everything that's defense and non-defense. And there we also have 2 entities, so BROLIS Sensor Technology now in Vilnius, and BROLIS Sensor Technology in Belgium, in Ghent, which is our most recent entity. We set it up in 2017. So just a little bit on the history, as Jose mentioned. So myself and my twin brother Kristijonas, we were PhD students in Baltic Shotki Institute. And at the end of our PhD, we decided that we were kind of thinking of what to do in the future and trying to choose the usual one between postdoc, industry, and something else. And then we decided that we are young enough so we can try the something else path, which was setting up our own company and trying to commercialize the gallium antimonide photonic or laser-based technology. So we landed a venture capital investment here in Lithuania, which allowed us to come back and build a new facility. So the first investment was mainly spent on really industrial MBE infrastructure. So we have a multi-wafer MBE infrastructure. So we're able to really supply high volumes of this type of material. Then we had several other rounds of investments until 2015 to extend our, let's say, back-end capability. So investing a lot into hardware. And in 2017, we bought out our shares from the venture capital, and this kind of became really a family business with a long-term horizon. So we are no longer, let's say, exit-oriented company or quick exit-oriented company, and rather we focus on really developing of what we like to develop, what we believe we can develop, and we don't really care that much about the term that it can take a long time to develop some exciting solutions. And in 2017 was our first profitable year, and in 2018 our sales exceeded 10 million, and since then we are kind of moving successfully onwards. Also last year we separated the entities as I showed before, so this is kind of our revenue shares, the revenue figures here. Kind of the oscillations is not really related that much into some activities on the market, but rather it's just a specificity of the long turnaround times of the governmental tenders and so on. So it's kind of, I think we have a very nice situation here. And we are a licensed military system developer and manufacturer, and we supply to almost, to the majority of the NATO companies within the world. So what we focus on is really, let's say, warrior-based systems, as we call. So it's all kind of handheld or surveillance-based systems. So starting from really multi-laser containing rifle pointers, illuminators, to vision systems such as weapon sights, night vision systems, thermal, shortwave infrared, extended shortwave infrared, surveillance system for border surveillance, for some other type of surveillance based on uncooled thermal, and then of course quite a bit of different types of OEM systems where we really develop some very custom solutions for bigger integrators. And one of probably a highlight is really the first 2.1 micron all semiconductor laser diode based like ultra compact DIRCM laser. So in this case, we are really gaining probably a factor of more than 100 in terms of footprint and weight, replacing very bulky fiber systems for modern DIRCM systems and offering really nice performance at this 2.1 micron atmospheric window. So we have quite a lot of products here, and probably the key attraction factors or success factors to us being a small company, but at the same time, when we have so much hardware in-house and so much of the engineering talent in-house, and being outside of the US, so we can really have very fast R&D cycle times, and we're small, effective professionals. So this allowed us to reach very high operational efficiency. So this is kind of about €500,000 per employee in the period of 2017 to 2019. So this basically was our success factor, that we kind of invested a lot into hardware automation. So with less than 20 people, we were really able to manufacture and sell over 5,000 systems in 2 years. This is kind of, I believe, quite a large number. And how we target in this market, I mean, you could say it's maybe a crowded space of very large defense companies, but all of them are pretty slow, and we offer like a subcontract and second sourcing option, and this kind of works quite well so far. And we are very agile in innovating some new systems where other big guys are much slower at. So this is kind of our offering for the defense market. And now if I move to the other story, which is, let's say, so that was a running business, profitable business, and that kind of, I think, since 2017 never stopped growing. The other part of our company group is the sensor technology, and this is a little bit different. This is kind of still some way to go. It's a longer horizon a little bit, but I believe the technology in there is very deep and it's very exciting. So there we combine our 3.5 device competence, so mainly long wavelength lasers, detectors, and other type of light emitters. So in Vilnius, we have very strong base for epitaxy, for packaging, for integration, also a team of data scientists and application validation. And we combine that with the competence of silicon photonics that is based in Ghent. It's a very nice location for that because we have IMEC nearby and the historical, very good, excellent talent pool within the Ghent University in KU Leuven. So this is a very nice location to be, and we try to combine the silicon photonics with gallium antimonide to develop a generic gallium antimonide and silicon photonic sensor technology for really large volume markets. So we're talking about really consumer markets or anywhere where we need to have high volumes. It's like an all semiconductor type of technology. And our proposition is not just being like a chip component manufacturer, but we provide a complete solution. So that means we add data to the hardware. So this is kind of gives us a little bit of the edge. And actually, for some of the markets, we are developing a complete also and final solution. So in total, we have about, and it's a little bit outdated numbers, but about 30 people for the sensor technology across 2 locations. And most of them are engineering involved in really development. So this is yet not a revenue generating company yet. So we expect to enter the market with first sales in probably 2 years from now. And this is just, this slide highlights what I already probably described, that, I mean, BROLIS, we are a small company, but at the same time, we're quite different. We have all the hardware in-house. So this gives us a lot of flexibility into really designing our own solutions to the problems of the market or problems of the world, of how we want to solve it. So we combine, start with a wafer level, epitaxy synthesis, go all the way to the 3.5 component, and then design our own circuits on silicon and try to combine the 2 worlds to provide a full system on chip solutions. And there's a lot of things we can do here with our laser-based system on chips. So biomedical sensing, industrial, multi-gas sensing, agricultural, inline sensing for different things such as grain sorting or in situ, inline beverage process monitoring or LiDAR applications. For the last 3 years, we mainly focused on biomedical sensing, but just let's say to say in general, what we developed for the biomedical arena is still a very generic technology. So it actually is really, the engine itself is compatible and we can directly apply it for other markets as well. And this is kind of the goal of that whatever we develop, that it does not make us really market specific, and we prefer to have a generic technology that we can afterwards target to all the different market verticals. And what's so special about our approach here is that, well, first of all, just from the physics point of view, with our gallium antimonide technology in combination with silicon, we can make very compact solutions, and we can utilize the spectral region, which is not covered by conventional indium phosphide or gallium arsenide components. So we reach this 1.9 to 2.5 micron spectral region, and this gives us access to the so-called first overlap combination absorption bands. So much higher molecular specificity, at the same time higher molar absorbability. So we have stronger absorption, and in-house we can still make room temperature components, so we don't need any cooling or any cryogenic cooling to develop very compact solutions. So let's say when it comes to sensing, we have still sufficient skin penetration and just really the molecular absorption features for this band that gives us an edge over the just the first overtone band that you can see in the 1.5. So this is so we've been developing all kinds of laser solutions since the very beginning, and probably from 2017 to 2019 we developed some very nice, very fast MEMS-based tabletop laser solutions with extremely broad tuning, so over 300 nanometers of tuning and very high output power. So this was our kind of in-house development tool to develop the full sensor architecture of how to use those widely tunable lasers for different sensing applications. And at the same time, at about 2016, together with Ghent University, we demonstrated first hybrid gallium antimonide and silicon lasers. So that one at that time had about 60 nanometers of tuning per chip. So it was, maybe not as much as we have on the tabletop, but it was large enough, let's say convincing enough to understand the potential of this technology. So this kind of was the flipping point when we decided to invest into silicon photonics technology and have actually physical presence in Ghent. So this was the start of our office. Now we have a growing team there. And just to highlight a little bit what's our current status of this hybrid gallium antimonide and silicon laser sensor technology. So here you see a superimposed spectrum of our generic spectroscopic sensors. So we have 4 gain chips which are embedded, they're embedded into silicon here. So the total footprint is basically less than 6 square millimeters. And 4 of these gain chips are directly embedded into silicon photonic integrated circuit, with forming 4 separate widely tunable lasers. And there's of course other circuitry in there that allows us quick control, tuning control, wavelength reference, and wavelength tuning. So we have full coverage from 1.9 to almost 2.4 microns within this still microchip, and we can do the tuning very fast. So here just see the answer here. So the sinusoidal curve below this is just the performance of our thermal tuning. So this is, I mean, I'm not talking about the data communication kind of segment. So for just basic thermal tuning for this spectroscopic applications, we can reach without any detrimental effect on our performance up to 2 kilohertz. So we can really have a spectroscopic laser chip that can tune the entire bandwidth at a 2 kilohertz rate. So this is pretty fast and I think pretty exciting, and it can offer, I mean, and it's, to my mind, has a lot of interesting potential in applications, both in just sensing, biosensing, gas sensing, but as well as LiDAR. And our architecture is based on widely swept lasers. So instead of using detector arrays and like AWG type of architecture, we use a tunable laser source or a combination of those and perform detection with a single pixel photodiode. This is, so I believe, so yeah, this is kind of our current performance that we have in-house and that we are using for all our sensing applications. And of course, to enable any sensing application, having a laser is not enough. We also need a component to detect. And this appeared to be a bit tricky in the beginning because we were always thinking that we can source in that component. We were aiming at that time at extended InGaAs and indium phosphide photodiode technology, but this appeared to be a little bit tricky because of the very, let's say, stringent market requirements in terms of low cost per chip, and the yield was not sufficient. So it was, then we came to a decision that we need to develop a component in-house. And currently now also the detector part is developed by BROLIS. So we built it on our gallium lattice mesh technology, and we have really state-of-the-art performance within the 1.9 to 3 microns range. So it's a standard interband type of photodiode with a very nice responsivity, low D star and low net value. So it's kind of a very nice component that I believe today is standalone interesting for the market, just as a component for different systems that are already existing in the market. So in our case, of course, we integrated it together with our lasers. So the sensor itself contains 3 main building blocks. It's a gain chip, which together with silicon forms this very fast, widely tunable laser, a photodiode, and the silicon itself.
So you have all the building blocks to have an integrated optical active manufacture system.
Yes.
So I'm really, really happy. For me, this is the success story of people who really love photonics, who really master the manufacturing of gallium antimonide material, really master it, really fully understand. They get the reactors, they make it production, and then they realize, and now we want to solve problems. So they go at the value chain, they find collaborations with IMEC, then they start integrating it on silicon, and now they are manufacturing LiDAR, biosensors, and big mid-infrared technologies where they had never been before, because they managed to, having the material and having the partners, going into solving real problems. And for that, you are an inspiration to the photonics community. You're gonna get the epic question. What can the epic members do for you, and what can you do for them?
Well, probably, I think some of the epic members we are already involved in terms of supplier customer relationships, and whenever we do, let's say, build electro-optic systems, we don't make the lenses ourselves. I mean, we do make all the designs that are necessary, but then we don't make the lenses and other components, so we buy them, source them in. Other than that, I think we're always interested in understanding, let's say, different types of potential application opportunities, let's say, where such a system could be applied, right? I mentioned a number of potential applications, but I think the field is very vast and very broad, and sometimes we ourselves do not fully understand well enough what could be other applications where our systems or system solutions could be applied. And I think this is always interesting for us to talk to people to understand what are the needs, what are the challenges, where we could offer our hand, and could our technology offer some edge.
For me, it is clear that we need to come with you with problems that the wavelength range between 1.9 and 3 micrometer, well, 1.9 to 2.7, 2.8 micrometer really can solve, because you, with the right partner, especially with the collaboration with IMEC, can make something CMOS manufacture with the active material on top, detectors and sources, and solve any problem. It is so great to have BROLIS Semiconductor with us today. Thank you for joining me in this epic journey. It is totally crazy, but you know very well, I'm totally crazy. Thank you very much, Augustinas. Acho.
Thank you.
And we continue with this beautiful trip. It's such a beautiful trip today. We go back to Singapore, because I told you already this morning, for those who were awake, I love Singapore, and I love the next speaker. Charles Wang is the CTO of WAVELENGTH Electronics, and he's going to talk WAVELENGTH Optoelectronic, and he's going to tell us about something that we really want to hear about, which is automatic optics in scratch dig inspection. We really are looking forward for this presentation. Thank you very much, Charles Wang, for being with us this beautiful morning. It is 9 o'clock in the Netherlands. What time is it in Singapore? I have you muted right now. Could you unmute yourself?
Okay. Oh, okay. Yes. Now 3 p.m. Singapore. Yeah.
Is this past lunchtime, almost siesta time for the Spanish people?
No, afternoon, yeah.
See you. Thank you very much for being with us. The floor and the attention of everyone goes to you.
Can I start now?
Yes, please.
Okay.
You go to the bottom, share
Hello.
screen.
Okay. Hello, everybody. This is Charles Wang from Edinburgh Technology, a subsidiary of Wavelength Optical Electronics.
Sorry,
Well,
Charles, will you share some slides with us?
yeah, I actually, should I need to share my screen?
Yes, please. At the bottom of the Zoom window, you have the arrow up.
Oh, okay,
which is
yeah.
green.
I need to, okay, share.
Yes.
Can you see now?
Perfectly, crystal clear. If you go to, yes, there. Fantastic, the floor is yours.
Okay. Okay, yeah. So, hello everybody. This is Charles Wang from Edinburgh Technology, a subsidiary of Wavelength Optoelectronics. Well, my topic today is towards objective quality inspection of optical surface with intelligent machine vision. Okay. So my presentation have 5 parts. The first part is about the status of optical surface inspection techniques. Okay, for the optical manufacturing industry, we could not forget a time that is Renaissance, and a critical person is Leonardo da Vinci. During 1513 to 1517, he invented a grinding and polishing machine, which made it possible to manufacture optical devices in volume. So optical industry was funded only after the invention of the grinding and the polishing machine. That was 500 years ago. This is what Leonardo's grinding machine and the polishing machine looks like. Please do not miss out the opportunity to take a look if you go to Florence, Italy. Since then, numberless optical devices were manufactured, as you can see. So, nevertheless, during the manufacturing process, there are defects generated as shown in the photos. Until now, the prevailing surface inspection still rely on naked human eye and human judgment. It is a real surprise over the last 500 years. Not much progress was made in this area. There was a saying, what exists is reasonable. Well, let's find out what are the pros and the cons. The advantages of using human inspectors to set up a quality checking line is that it is really easy, fast, and economic. Yet, you can only get the subjective judgment by the inspectors. It is not objective, inconsistent, and controversial result. The cost of the customer supply communication about the service quality will be high. Indeed, this is a choice of no choice. There's no other reliable measurement methodology that can be available in QC process. As the time going, the possibility of reliably measuring the optical surface quality is gradually emerging. In 2002, the customer was surprised to see a Nokia mobile phone model 7650 having a built-in camera. This mobile phone symbolized an era when digital image sensor and the camera would be produced in incredibly huge quantity. Following the Moore's law in semiconductor industry, much larger scale image sensor would be available in market at a reasonable price. Machine vision era is coming. So this is a new possibility. What can wavelength optics electronics do? In this following slides, I will introduce what we have tried in wavelength optoelectronics. In optics, what was used to check the imperfection of optical surfaces It is light. Actually, we use the light as a prop to detect the defects. When the light beam was shined on the optical surface, we can see the defects by checking the scattering light or reflecting light. Use the light wavelength lambda as a reference. The imperfection on the optical surface may be generally categorized into 3 categories. That is category 1. Category 1 is the size of imperfection is smaller or much smaller than the wavelength. Category 2, size of imperfection is about the same size of the wavelength. And the category 3 is size of imperfection is larger or much larger than the wavelength. In terms of the optical defects on optical surface, we focus our attention to category 3. This is much more meaningful and practical. Suppose you are a photon. You will see every defect is different, and every part of the defect is different. That is, every defect has its microstructure, which may determine the direction of scattering or reflecting light. Then how to grade the defect? There are 2 standard systems, that is US military standard or European ISO standard. Both standards have no discrepancy about the degrading, that is to directly measure the dimension. However, when touched on the scratch, the 2 standards went to different direction and took different view angle. European ISO standard is straightforward, continue to measure the dimension of the scratch, while US military care about the light scattering intensity from the surface defects. In other words, the visibility of the scratch. This caused the big problem to industry, as only the US military army has the master of the visibility standard. Nobody else can have this master. Yet, some companies has the privilege to make the artifacts of the visibility master kept by the US Army. Savvy has ever got chance to measure the scattering light intensity from all those artifacts from different companies, as shown in this figure. You might have found that no one was same with the others, so the standard itself already controversial. Interesting enough, if you pay attention to D667, which was made according to Levin H. That is, the scratch number is exactly the width of the scratch in unit of micron. The scattering light in the intensity from scratch number 10, 20, 40 are more or less amongst the data of the other artifacts. Only scratch number goes to 60 and 80. The scattering light intensity looks apparently higher than the other artifacts. In other words, for those most used quality grade of today, that is scratch grade 10, 20, 40, we may just safely use the Levin H for the scratching grading, with no big deviation from the US military standard master. In a way, we are able to roughly convert the US military standard master into Levin H with no big error, at least for scratch number 10, 20, 40. Compare with the visibility measurement, we prefer to measure the defect dimension. Nevertheless, as we mentioned before in this presentation, because the defects all have its own microstructures. So, in order to bring every microfeature of the defect into photo, still, good attention should be paid to the uniform or ideal lighting from every direction, as uniform as you can do when possible. Based on the above findings, we designed and developed a series of auto inspection machines for QA and QC use, some for flat surface and others for land surface, which is under development now. Thanks to the less complexity of flat optical surface, we have developed a series of machines for flat surface inspection, covering the product size from 0.5 mm, 5 mm, all the way to 1 inch in diameter, or even larger size. This slide shows the dimensions of several tabletop inspection systems for optical communication devices. It is the all-in-one machine. The GUI of the inspection software based on what you see and what you get strategy. Indeed, you can see the digs and the scratches on the surface. And 3D analysis of we do the 3D analysis of the defects as shown in the photos. After inspection, you will get all the defects data where only the results of the biggest 5 or 10 digs and scratch will be displayed. The software can generate the test report following your instruction. You may refer to military standard or European IO standard. In order to match with the customer's metrology tools, for example, in this slide, it is light scattering meters. We choose 100 defects and measure with our AMF 104 machine and the customer's laser scattering meter. Generally, these data follow a linear fitting line as shown in this figure. And most data fell in the range of a zoom, of the data zoom. Taking into account that the laser scattering meters still measure the data manually, that caused the relatively big uncertainty. Our machine actually matched the laser scattering meter quite well. This slide shows another calibration, how to match the data with another calibration tools, which is compared with microscope. Same with the last slide, we choose 100 defects and measure with our AMF 104 machine and the customer's microscope. Again, generally speaking, these data follow a linear fitting line as shown in this figure. And the most data fell in the range of plus minus 4.5 zoom. Taking into account that the laser the microscope measurement is still done by the manually by the inspector. That caused relatively big uncertainty again. Yet our machine actually matched the microscope data as well. So let me finish my presentation with a summary. Actually, our machine makes the optical surface quality objectively measurable. The process is fully automatic, no human intervention needed. Auto inspection batch by batch, and the potential to fully automated quality inspection line if pick and place station is used. So in the case I still have 1 minute or more, I would like to play a video demo showing how our machine is working. Thank
Please
you
go
very
ahead.
much.
Go ahead, it's okay.
Okay.
So we can see your technician inputting the sample. We can see that
Yes.
this is Windows driven, so it is very easy to start.
Yes.
We can see how the samples have a holder. Yes.
Yeah. This is a demo tree actually.
What is the typical size of the?
This
Of the
actually its size is 1 inch in diameter.
And what is the standard time for the measurement? How long does it take?
Every piece about 2 to 3 seconds.
Okay.
Yeah.
And you can here, you get the map, and of course you can load in the standards that you are comparing with, and it can
Yeah.
give you first the measurement, and then I guess a red or a green light saying the optics are okay or are not okay.
Yeah.
I really want to play with this. I know I am a geek on this kind of thing, so I'm gonna go to Singapore. I want to play with this as well.
Welcome. Yeah.
Yes. As soon as I have a chance, I really want to go there. As you have heard today quite a lot, I'm a huge fan of Singapore. We have done so much business with many companies there, and we are so happy to have you today with us. The most important thing from this meeting is to start collaborations. That's why I made a living of. I'm not a chairman of presentations. I just love connecting people. I have 572 companies here. Some of them manufacture optics. Some of them, like Savic, they make fantastic material for optics in any kind of harsh environment, all the way to consumer and telecom. What can you do, Wavelength Optoelectronics? What can you do for them, and what can they do for you?
Okay. Yeah. So our focus is to try to provide the, as just like I mentioned in the slide, in the presentation, because the quality check, most of the manufacturer, the quality check is done by the inspector, human inspectors. So the result actually is very subjective. What we want to do is to provide the machine to automatically measure the quality of the surface, and provide the very objective data. Yeah, according to the so-called standards. We actually, our machines follow the US military standard and the ISO standard. Yeah. What we can do is we can provide the so-called QA or QC machine to the manufacturer of optical manufacturers.
Thank you very much. And I think it's been great that we managed to have you here. We are going to continue with the program, but stay tuned because there's many companies who want to collaborate with you. And I told you today, this morning, I said, don't look at the program too much. There is a lot of Easter eggs. Here comes the second Easter egg of the day. We go to ZHEJIANG Crystal OPTECH. Vincent Leong is with us this beautiful morning. It is 9:20 sharp in time, 9:20 here in the Netherlands. What time is it in your location? What time is it at ZHEJIANG Crystal OPTECH?
I'm residing in Singapore, so my time zone is same as China. So now it's about 3:20 p.m.
So it is a beautiful afternoon with nice weather, and we want to hear from you. How can we help you get even better? 570 companies want to help you. The floor and the attention of the whole world, which I'm going around in one day, is yours.
Yes, thank you so much, Jose. Right, so hello everybody watching this. A very good day to you. Let me share my slide. So, okay, I have this on the screen, right? So, just for a start, I want to say I'm thankful to be given this golden opportunity by Mr. Carlos and Mr. Jose from his team from EPIC to put up this novel and very wonderful experience for all of us. It is very exciting to be part of this historical moment. So a brief introduction on myself. So my name is Vincent. I am a Singaporean. I reside in Singapore, although my employer is in China, ZHEJIANG Crystal OPTECH. In short, we call it COT. So for my own brief introduction, I am from a precision optics industry for almost 18 years now. The earlier part of my 10 years, I was a technical optical thin film engineer. And later on, I got my master's in optical science from University of Arizona. So prior to my master's, my basic degree or basic bachelor of science is focused in the physics and photonics in a Singapore university. So I hope that with my theoretical background and this experience I have and expertise and the network that I have, I hope that I can explore novel optical solutions, ideas, contribute to them, and especially involving in thin film optics, medical optical assemblies, and etc. While knowing people, wonderful people like you guys through EPIC and which I already have some fantastic experience from Mr. Carlos when he was in here, Singapore last year. So today I will go through quite briefly over the products, which you will see on the next slides, that the products and capabilities that my OEM employer can offer as a starting idea for the range of products that you might already have or you might think to improve or develop with. So I'll skim through the following slides and be brief and to save you the trouble of listening to my my words. So okay, so now this is the company in Taizhou. It was established in actually. Hope you can see the slides. The words are a bit on the top. It was established in 2002, public listed in Shenzhen in 2008. The second biggest site, manufacturing site in Jiangxi in roughly August 2011. So the third site is actually the R&D site, which is the Hangzhou office. That is roughly about 300 people of R&D over there. So these are their basic locations in China, only in China. The rest is like Singapore and Japan, Korea. All these are offices and some R&D design with customers, especially some OEM customers and proprietary customers. So in a nutshell, the manufacturing capability hinged a lot on their optical coating machines. They have over 250. So in the precision optics line, roughly, you know that some of the game players are like this Optoron, Synchron, Layboy. These are some of the coating machine manufacturers. So COT, besides coding, of course, you have all the downstream and upstream processes from cutting, dicing, photolithography, and as such. This is just a nutshell of what kind of machines they have as a manufacturing facility. So they basically have three main big products. I would say two is component and one is actual product. The first one is more to component, the thin film optics. It is quite standard to a lot of people. It's like filters, glass, optics, but essentially because of the coating, it can be customized and be many different products used in camera, vehicle, automation, or a lot of areas. So these are some of the products they do. Filters, you can see almost all of them are all the wafer filters or flat optics. And then of course, the typical bandpass filter, narrow bandpass filter, if you are interested, let me know. Then what we call the prism work, or rather the different shape, the odd shape works, so-called the prisms and many classes of names. So not to bore you, it's just different shapes and sizes that they can work with. And below you can see some of the thickness capability, which is how thin they can get. Because in the industries that in the filter industries, in the LED industries, our customers really want them to be as thin as possible, right? So go into a product group. These are all their OEM products. They don't sell it under their name, but just to showcase they have this research capability, they have this developed capability, and they work with their end customers to put in their brand name and so forth and so forth. Some could be an extension of a development, some could be their own new development from their own team. So AR/VR glasses was pretty hot past few years in certain countries. The car HUD is a standalone device that was on cars for drivers without having a so-called HUD system inbuilt. So this is a standalone device, right? So maybe the third big so-called product level is a projection module used in the short-range projectors. It's pretty consumer product that we see for presentations and office, right? So the third group is what we call the nano imprinting. It is more to components again. It is a processing technology. Actually, COT started in 2002 by growing their own sapphire crystal. So from growing their own sapphire crystal from an ingot to everything, they have fine-tuned also their processing. Unfortunately, I think sapphire crystal goes through a very tough environment in China, even as well, on environmental safety and as such. They did not pursue this on their own. But of course, being a public listed and also with a leverage in China with other suppliers, they have very good partners doing the raw material, the sapphire glass for them. So then with this raw material on hand, they use it to make into components for customers. Initially, mainly the LED chip makers, where they want COT to do some coding on the sapphire and sell them on the wafer level, with cut and without cut. And then there's something they call the pattern wafers, that they end of it, they can pattern some arrays. It's arrays of design on it. This is done by photolithography. And then, of course, you do coating first, then photolithography, etching, and stuff like that. It's a little big mix of semiconductor processes with the optics that we know of. So the nano imprinting in fine tune is basically giving you different shapes like this. It can be so-called we call it the trenches and the troughs, and also the square boxes. So yeah, these are just some of the basic performance that you have when you do a nano imprinting, because it will give you a morph-eye structure. It can be designed into a morph-eye structure, and then it will give you good AR and anti-smudge and fungi proofing. So yes, I think that's about for me, because I just really want to show you guys a snapshot of the technologies that COT has. The product level is limitless because it's from the technology, then they branch out into the product that customers need. Right, so I hope I'm not going too fast. Yeah.
You did a fantastic job. You didn't go too fast. You finished on time. Everything went fantastic. I really liked it. But what I liked the most is that you talk about nano imprinted sapphire.
Right.
So on the technology side, there is, I'm sure, a lot of challenges. On the application side, what's the golden fruit behind? What is the key application for this?
Right. So think of the way that nano imprinting started off is like, you know, where in the older days it's just thicker threads, thicker silicon threads and stuff for the electrons to flow. So when nano comes in, just things are getting smaller and smaller, and so that you can on a smaller footprint. So one of the few optical products, maybe I can give an example, like some of the luxury cars, you know, like BMW. When you open the door and you can see the logo on the floor, yep, you need something like that to give you that like a mold to give you the light beam on the floor, something like that. So that is really like because of nano imprinting.
Okay, so let's first answer now the epic question. We have 570 companies here. What can they do for you? What can you do for them?
Right. So I wouldn't say I know what I can do for them, because I may be very limited. I can see all of them are very, very diverse in the whole photonics field. So what I hope is that with what I have and what knowledge I have, I wish to share and have a dialogue, to a connection, a door to be open, to see what is your needs. And maybe even if so-called COT can't do it, maybe there are other resources that I know of, we can share and see how do we move and improve our current way of life, our current way of optics into the medical, into automation.
That's great. I love that answer, because that's the perfect answer. Having a discussion is what it's all about. So I'm going to introduce you to a very good friend of mine. Patrick Hessler is from Delo. Delo joined EPIC to be very connected to the high-end optic manufacturers in the world to promote their optical adhesives, solving their problems. Patrick, you have seen what CO2 can do, and you have actually seen how they can actually make their instruments. What can you do for them? What can they do for you?
Right.
First, thank you, Jose, for the introduction. And you're still as powerful as always, even after 6.5 hours.
No problem at all. It's the beginning.
Yeah, Vincent, great talk, great technology you have in place there. So you were talking about this nano imprinting and pattern sapphire. So you're only working on sacrificial nano imprinting, or also on like nano imprint applications where the imprint resin stays on as a functional layer on the substrate?
Okay, at the moment, because of the company standpoint, we are only kind of target to do just the processing, the fabrication, and we stop at that because the applications is boundless. You know, it depends on how you design and how you incorporate into your products. So we are more like focused just the processing part, the manufacturing of the item, how it was designed is usually customer give it to us on a kind of a proprietary level that we have this contract or business to go on. Yeah.
Okay, so furthermore, one thing that for me is very, very interesting is to bring Sapphire to harsh environments. So Sapphire is not, it is not the most transparent material that we can have. It is not, but it is the more robust. It is very robust for optics. Many companies are looking at Sapphire for very, very high power laser optics, and other like defense companies are looking at the defense sector. Do you see a push for Sapphire optics coming your way?
Yes, Sapphire optics is definitely on the rise because the cost is relatively lower, or people tend to be able to pay more for a better performance. So Sapphire being non-glass is a crystal. So on the crystal methodology is definitely a better performance than glass if we know how to use it. Because at the end of the day, it really depends on the design. You know, if you don't know how the crystal works, you're not able to harness the energy of it's a hexagonal or whatever shapes it is in order to enhance your design. Yeah. So it's a chicken and egg in a sense that if the demand for such Sapphire goes up, of course, these things will move very fast.
I'm going to ask you a difficult question, but it is because one of our EPIC members is GAVISH and they make Sapphire material. And they want me to ask these questions, so I'm going to ask it. The quality of the raw material, to what extent affects the quality of the final instrument?
Oh, this is such a good question. Maybe I use in the sense of the quality system to describe this. Six Sigma, right? It is like, what's the difference between 6 Sigma, 7 Sigma, 8 Sigma? It's like, okay, 0.1% or we call it 10 log. It's a difference of a 10 log. So the purity of a material works the same way. You can go into like 7 OD, 6 OD, but it's an exponential thing. It's a logarithm thing. So as your purity goes finer, it definitely gives you the new breakthrough in your design or in your products. So again, it's also a different price point.
Yes,
so
that's the key, because the difference in price between some Sapphire material and other can also be 10 log.
Right. So I can make a very good component, but sometimes when it goes to the product, it degrades, it degenerates because the rest of the components could not catch up. But it's just like if you are still using resistors or the old resistors and not the digital resistor, your entire product will just lag behind, even if you have the best components on hand. Yeah. So it has to move in a tandem with the entire spectrum. Yeah.
When it comes to Sapphire optics, another thing they have seen as well is a push from the space market. The space industry is very interested about Sapphire optics. And are you space qualified? Are you looking at the space market? Do you have a supply chain to address that? Because I can help you.
Space is really critical and special. We do not have customers really in the space because I think a lot got to do with their geographical location, right? They'll take more on the Europe side and the US side. But of course, it's a good challenge. If you connect me, of course, we can go back to my R&D team and see if we are on par or can we meet your expectations, right?
I'm going to explore into that, sorry, because you just said something very interesting. So when it comes to China, space is not an interesting market?
Let me put it this way. There are also different market segment and industry. So space is in between what we call the defense and not really the commercial, right? So it has two different market, let me call it. So sensitive markets to say, and they have their own technologies per se.
Thank you very much. You made my day. It was a really, really great presentation. Lots of potential collaborations. I would like to remind right now, everyone in the YouTube universe, everyone in the Zoom channel, if you want to connect with any of the participants in the meeting today, or any of the companies that I mentioned, I just, for example, drop GAVISH there, just send me an email. I love connecting people. It's not work for me. I actually have everything automated. Send me an email and I will connect you so you can do business. This is what it's all about, making business. Once again, thank you very much.
Thank you, Jose.
And
Thank
until
you
the
so much.
next time, we're going to see each other very soon. I'm going to go to Singapore to visit you.
Yes,
I want
please.
to play with the machine, by the way. And we continue with the beautiful, beautiful program we had today. We go to China and we go to a company, BWT. We want to talk to Chen, the CEO of BWT, so he can tell us how the rest of the EPIC members can help BWT be even better than they already are. Jack, thank you very much for being with us this beautiful morning. It is 9:37 here in the Netherlands, in Noordwijk, at Station Control in Noordwijk. What time is it over there in China? I think we have you muted at the moment. Jack, can you hear me? Yes, Jack is here.
Yes, I can hear you.
Jack, what time is it?
Yeah. Hello. Hello, everyone.
Hello.
I'm Jack. Hello.
Hello, Jack. Good morning. The floor is yours.
Okay. Yes, you could talk. Yes. Hello, everyone. I'm Jack. From BWT Beijing of China. I'm CEO of BWT Beijing company. It's my pleasure to participate in these activities. Because of coronavirus, we cannot communication with face-to-face like before. I appreciate EPIC organize these events so that we can discuss online. BWT founded in 2003. Now we have more than 800 employees and more than 100 R&D engineers, more than 10 doctors. Now we have 5 sites in China, 1 site in Germany. We have rich experience in diode laser and product portfolio. Our product director Bob will introduce for you. Okay.
Right now we have your picture frozen here, so we're still seeing the cover slide. Is that correct?
Yes. Okay. So can you say that now?
Yes, we still have a frozen picture. So I think you stop the video and you start it again, it will work.
Okay. Okay. So now if we talk and for the presentation, could you see that?
Yes. Yes.
Okay.
Yes. Yeah, but we can see the slide. We can see the front page. We don't see it in slide mode yet. So maybe you can try to go to slide mode.
Slide mode. Yeah. So you cite this one?
Yes.
Okay.
Let's go to slide mode and fingers crossed.
So maybe I could continue, right?
We still see the first slide only.
You could slide only. So okay, maybe let me press again.
Of course. Let's try again. It always works. This is
okay.
The beauty of informatics. On and off, and normally problems is solved. The screen is being shared now, but it's not here yet. Let's just.
So could you see the presentation changes?
We don't see the slides yet. I think we have some bandwidth related issues. Let's try for the next time. Let's try once again.
Okay. So maybe we could go next one. Thank you.
Okay, you want to try once again to share the slide?
Okay. Let me try again. Yeah.
Yes. Because we really want to know what BWT can do for the members. So yes.
Thank you.
Could
you see that?
No, we cannot see the slides yet. I don't know if you have you. I'm gonna ask my team. Does my team have the slides so I can share them from my laptop? I'm getting internally have a lot of people in the back office, so they told me yes. So your slides will magically happen because I'm going to share them for you.
Okay, thank you.
And then you will talk while I share them from my computer. If you hang on with me for a second, it is great to have to go around the world in 24 hours. You cannot imagine what this kind of thing means for me. I'm really having, I said already a couple of times, this could be the happiest day of my life. So many companies telling me what they can do for each other and making those connections. I hope that after this meeting, a lot of business is done. And most important, I hope that you guys start visiting each other because this is what I love. And when you go to visit each other, send me a picture because I keep those pictures next to my heart. Okay, so in the meantime, while I get the slides from my team, let's ask you something before. BWT, as a company in this sector, you know that we have okay, I think we are seeing some of the slides now.
Could you
okay,
see that now?
I think it's working now. I think it's working. Go to slide mode. Yes, yes, we are in business. The floor and the attention of everyone is yours.
Okay, okay. So maybe we could start again.
Yes, please.
Okay, thank you, thank you. Okay, and this is Jack, our CEO and founder, and he will introduce for the roughly introduction for BWT. Okay.
Okay. Could you hear me?
Loud and clear.
Oh, yeah. Great. Okay. Okay. Hello, everyone. I'm Jack from BWT Beijing of China. I'm CEO of BWT Beijing company. It's my pleasure to participate in these activities. Because of coronavirus, we cannot communication face-to-face like before. I appreciate EPIC organize these events so that we can discuss online. BWT founded in 2003. Now we have more than 800 employees and more than 100 R&D engineers, more than 10 doctors. Now we have 5 sites in China, 1 site in Germany. We have rich experience in diode laser and product portfolio. Our product Director Bob will continue to introduce our product for you.
Okay, thank you. Okay, I can continue for that. And BWT is a high-tech laser company in China, and the company vision is to be the leader in China market and the international well-respected product and a reliable partner for laser source and applications. And the company vision is to create a bright future with light, and actually is to use the new advantage for all of us by the laser light. And for our company value, and we want supporting our customers successful with our innovative and trustful solutions, actually based on our 17 years of experience in this vibrant technology field. And this presentation has 2 parts. One is to introduce who we are, and the second is where we come from. And the second is for more and more challenge, what we provide. And the first part, and now you already see Jack, our founder and CEO, and he is graduated from the Tsinghua University, one of the best university in China. And we have 5 top leaders, and every one of them have more than 20 years experience in laser technology and measurement. And also, all of them worked in well-known international companies before. And now for BWT, we already know we established in 2003.
Actually, we are one of the long history laser company in China. And now we have more than 800 employees. And inside, just like Jack said, we have a very good R&D team. And actually, I could say is a world-class R&D team. We have more than 100 R&D engineers and more than 10 people is doctor for the laser technology. And until now, we have more than 50 the core patents for lasers. And also, we have 5 sites in China, from Beijing to Shenzhen, all the important city in China. And also, we have a new R&D center. We have a new R&D center, and actually is a new company of us at Germany. And this is a very important thing for BWT. And also, we have a 20,000 square meters facility will be complete in next year. By that, it could be increase our capacity of production and to meet more and more the customers' requirements. And this is to show the company roadmap. Actually, after 2 years we established, we provide 1,000 pieces stealth lasers to American medical market. And also, at 2008, we participate in Beijing Olympic Games, the laser display project. From 2011 until now, every 2 or 3 years, we will launch a series of high power, high brightness pump lasers. And for this year, the most important thing is we established the BWT Laser Europe GmbH. We invited Dr. Michel and Dr. Jens join our company and to lead this new company. And this will be the Europe R&D Center, and also will be a service and sales hub for Europe customers. And for the second part, everyone knows the laser market grew very quickly, especially for the delta laser and the fiber laser. And the customers want higher power, higher brightness, but lower price. Actually, there are more and more challenges for the manufacturers, just like us, just like for BWT. And how could we meet the customers' requirements? And now we are using more and more the automatic process using the highest precision machines, just like the micro-optical assembly. There is 2 videos to show our lens automatic machine and the check-on-sound mount, the boundary. Except those kind of automatic machine, we have an effective mass production capability. This is a classic Chinese trend. Also, BWT is using the synergies from both worlds. And also we have wide automatic quality control, just like the data tracing, the testing, the burn-in, the temperature cycling, and lab test. This company is certified by ISO 9001:2015. The last, but also the most important, is we have a strong engineering and design team. We put more than 10% of revenue for R&D investment every year. It's a very, very big count. And for our mass production capability, we have a trained and experienced production teams, and many of them is since 17 years in this company. And for the software for the equipment, we have automatic chip bonder, the automatic phase and mirror alignment system, and also have the module COS sphere bonder, the bar scribe system, the NA test system, and also design by ourselves the reliability test platform. Except those, for BWT, now we have 3 business units. The most important thing is the delta laser. And from the 405, the UV light, to 1470 nanometer. And the power could be from the milliwatt to 3 kilowatt system. and the 3 kilowatt with very good brightness, it could be used for the metal welding. And also we have fiber laser and ultra-fast lasers business units, but currently they only provide the product for Chinese customers. And depend on our very strong R&D team, we could provide customers with flexible solutions in the laser pumping, the material processing, the CTP printing, medical, cosmetics, and other applications. We could design and produce the fiber-coupled modules and the turnkey diode lasers, the high-power sticks, and also the multi-feature medical device for customers. And the most important thing is we have rich experience and skills to meet the customers' special requirements. We could do the customized design for customers. And for example, this is to show the blue diode laser. And at first, some customers ask us to design for them. Until now, we already have 100 watts from 105 micrometer fiber, 200 watts from 200 micrometer, and also 500 watts from 400 micrometer fiber. And our customer already using for the copper welding. And this is we design and we provide for customers by their own requirement, and then we have more and more product for that. And this is for the fiber laser, and for the ultra fast laser, the picosecond, femtosecond. I don't want to show too much about that because they only provide for Chinese customers now. At last, the most important actually is this page. For BWT, we have branches in China and Germany, and just like EPIC, we have Europe part and we have Chinese part. And also we have a strong manufacturing capability and a very strong R&D team. We have rich product portfolios, so we could meet a wide applications for the customers. So BWT will be a reliable strategic partner for you. Okay, thank you for your time.
Thank you very much for being with us this beautiful day. As you can see, the sun is shining all the way here in the Netherlands, and we are learning a lot of how we can help each other. How can the members of EPIC help BWT? What can you do for them? What can they do for you?
Okay, thank you. Actually, EPIC have a lot of very famous companies together. This is an excellent group for laser technology for optics. Actually, for BWT, we could find partners in this group, just like the chip and the bars and optics supplier from that. And also for BWT, we have our own advantage, just like we have very rich experience for diode laser. If some customers, some companies in EPIC have some idea for some product, we could help them to make it true, make it true. And this is, I think, this is what we could do for EPIC. Except that, also BWT have a lot of customers, or actually over 70 countries over the world. We could ask more and more companies join us, join EPIC. This is a very excellent group. Yeah.
Thank you so much. BWT is a company that in EPIC has been very appreciated because not only you can help the companies with your products, but you also can help them scaling up their dreams, scaling up their production. One key segment is, of course, the laser diodes. And when it comes to laser diodes, we are always worried about temperature stability and direct diode cooling. Are you seeing this as a challenge, as an opportunity? Do you wish to collaborate a bit on that particular respect?
Yes, actually, for the power is here and here, and the heat is more and more important to ensure the reliability for the product. Actually, now we cooperate with some companies together, just like from Europe and others from China, and we together to find some way to make the cooling efficiency here and here. So the LED power could be here and here.
For direct diode cooling in EPIC, we have AMS Technologies. They are really, really strong in this. So anybody who wants to contact them, I'm happy to make an introduction on this. Laser,
Okay, thank you.
laser optics. For many, many applications, we are now going to IBS. We're going to harden coatings to make them more resistive. There's many, many laser optics manufacturers in China. There's many in Europe. Is it difficult for you to judge quality versus price of your suppliers?
Okay, this is a very good question. Actually, now the price is more and more important, but the reliability is the base. Only the reliability is good enough. We could talk about the corporate and we could talk about the price later. So Europe companies and Chinese companies, and for the lens and for the bars, for the chips, we already try a lot of companies' product, and we have our own know-how to how to judge the quality is good enough or not. And only the quality is good enough, so we could cooperate together. They could be our vendor. And by this way, we could ensure our product quality is good enough. Okay, thank you.
We had a presentation earlier this morning, and they told me the only way to compare optics is trial and error. And I was shocked, right? Because trial and error is very expensive process. Is there any alternative to this? Because maybe there is something we can help you with here.
Okay, thank you.
There is a company in Lithuania. It's called Lidaris, and they compare different optics. So whenever you are doubting which optic supplier to go to, these guys are really strong. As I always say, any company today that you want me to introduce you, either the ones in the channel, the ones in YouTube, or just the ones I name drop, I'll be more than happy to do so. Jack, CSE, thank you very much for being with us this beautiful morning. Everybody is happy to have you in the room. Until the next time, thank you for being in this amazing journey, this epic journey that we are doing today.
Yeah,
Okay, thank you.
Thank you, EPIC.
Thank you. And now we go to one of my favorite companies in the EPIC network, FOCUSLIGHT. FOCUSLIGHT is a company very active in the laser business, but then they said, we also want to be a player in the micro-optics business. So they acquired Limo, and now they have the power of two really strong names to solve everybody's needs. Thank you very much, Vincent, for being with us this beautiful morning. It is 10 a.m. in the Netherlands. We are fully exactly on time. What time is it for you? Victor, what time is it?
Yeah. Thank you very much, EPIC, for your introduction, and I appreciate this opportunity. This is a great opportunity. Thank you all for all the participants worldwide. We are glad to discuss. I would rather this to be a more discussion than presentation. So I will talk about how to drive the diode laser, high power diode laser application growth. Then how to synchronization the diode laser light source and beam shaping optics. So I will discuss a few topics. First, what is the pro and con of diode laser? What is my understanding of the application? Then I will talk about the magic of micro-optics, what micro-optics can do. And then I will talk about the beauty of shaping diode laser light source using micro-optics, and then give a few examples of applications. So then we end up with discussions. So first, I will talk about the diode lasers. So if you look at the majority of the applications, the dominant laser source is the solid state laser or fiber laser. However, diode laser is a building block. If you look at all the applications, the building block is diode laser. Then the diode laser has a small footprint, high reliability, efficiency, and the best cost compared with solid state laser and fiber laser, because fiber laser, solid laser is made up from solid diode laser. However, why diode laser is not the popular one, not fully used. Why? Because diode laser has its limitations, very poor beam quality. That's the problem. That's the problem of diode lasers. So if you look at the beam quality of the diode lasers, for solid state laser, fiber laser, we're all talking about you know, the M square equals, you know, single digits, 1, 2, 3, 4, you know, low numbers. However, if you look at the diode lasers, you are always talking about, you know, the tens, hundreds, or even thousands BPP. You know, M square is very, very high. And also, it's not symmetric. The fast axis, slow axis is not symmetric. And of course, VCSEL, it's symmetric, but it's very big. It's very big, M square or BPP. So, however, in my opinion, in order to use a light source for a real application, you need 3 factors. 1, beam shape. You need a certain beam shape. It's rectangular shape, line shape, you know, square, round, you know, whatever shape you need. Or if it's a field of view, you observe something, illumination, you know, you need dots, you know, scale, you know, all different field of view. The second criteria is energy density. You need to have a certain energy density to achieve the application you need. Then the third one is intensity profile. You know, top hat, you know, Gaussian shape, whatever shape you need. So in my personal opinion, I would argue, you know, debate, you know, but of course it's personal opinion. You don't have to have a best beam quality to achieve the application. That's my statement, opinion, you know, it's debatable, I know that. So in the traditional way, typical way is for application, you have a spot beam. Then you can, of course, spot beam, you can do cutting, you know, welding, all kinds of things. Even for the field of view, if you have a spot beam, you can scan, you know, 2D scan, 3D scan, you know, 1D scan, whatever do. However, if you have a shaped beam that is rectangular shape or line beam, you know, whatever, in my view, it can be much faster, high efficient, and, you know, add value to the application. So that's my argument. But how to achieve that? How to do that? That's the magic of micro-optics. So micro-optics, you can use a micro-optics to turn a light source into a, I call dot. You know, you can turn the light source into a light beam or square shape or a kind of field of view, you know, to do the processing or application. So micro-optics can not only be diode lasers, but also can be solid state laser, fiber laser. For example, can be edge emitter lasers, single emitter, you know, laser bars, can be VCSEL, you know, VCSEL arrays, can be solid state laser, and the multiple beams as well. Then you go through the beam shaping optics. You can make all kinds of different beams, like a round shape, donut shape, square shape, rectangular shape, light beam, and all, and so on. So in the information technology or 3D sensing field, it can be, for example, VCSEL. It has a symmetric beam shape, but it's very divergent angle. You can you can use a top diffuser to form a certain field of view, flat top, for example. No matter it's a DPSS or fiber laser, you can do that as well. And also for edge emitters, you know, the fast axis, slow axis, there, divergence angle, sorry, it's reversed. Fast axis, slow axis should be reversed. It's not symmetric. You can form the field of view as well. So all kinds of applications. That's the magic of micro-optics. So no matter what light source, you can turn it into the beam shape you need for the application. How to do that? You know, we use wafers. We make wafers. Then we can make big wafers as large as 12-inch. Then you can cut them into small pieces for fast axis collimation, slow axis collimation, you know, coupling, you know, FACSAC, transfer beam transformation, you know, diffuser, homogenizer, and so on. So you can do all these kind of different things. You can be different wavelengths for UV, IR, visible, and so on. And you can make micro-optics in really different shapes, very complicated shapes. and you can combine a lot of the micro-optics into one piece, multi-function into one piece to achieve that. So that's the beauty of micro-optics. So now I'm going to talk about how to beam shaping diode lasers using micro-optics. So the first thing, the principle is, you know, a beam mixing. So you can cut the laser beams into small pieces, and then you overlap them. So this way, you basically increase the beam parameter of the beam in the X and Y direction to generate a shape and make it more uniform. So this is one principle. The second principle is beam transformation. So which basically is change the ratio of BPP of X direction and Y direction. So you can also think the other ways. We divide the beam, rearrange them. For example, a Gaussian shaped beam, you know, then you can cut them into pieces, rotate them, and rearrange them into a line. And also you can combine the beam mixing and beam transformation. That really opens a lot of freedom in designing lasers, beam shapes. So essentially what it does is cut the beam, rearrange the beam, and overlap the beam. So you can have different options. So you can, for example, a laser that is M square is 25. You can change the Y direction into smaller than 2 and the X direction bigger than 300. You can rearrange them. And also use the same principle, beam division, beam rearrange, and overlapping. You can make a low line beam to achieve that. So, and also if you say, oh, the beam density is not enough, you can combine multiple light source or beam laser source into one beam to achieve the high density, power density you need. And if you say, oh, I need much longer line, then you can stitch in large scale, scaling the line length by stitching multiple units together to make a long line up to a few meters long. For example, this one we made is 192 kilowatts, and the line length is greater than 3 meters. 3 meters, and the width is 400 microns. So you can achieve this by beam shaping. So, and also in the 3D sensing field, you can use beam shapers to generate a solid area or a dotted area. You can generate an array of solid line or array of dotted line to achieve different applications. So that's basically my talk about how to shape what you can do. Use micro-optics and diode lasers together to achieve the application you need. Now I give some application examples. For example, in the flexible display field, you know, after you do the process, you need to lift off the flexible display from the glass substrate. So you can use, typically we can make 750 millimeter long line that is a 40 micro width line that has very high intensity. So you can scan the flexible display and make the lift off. So this is very widely used in the display industry now, and we are one of the pioneers. And we won the Prism Award. This product, this technology innovation, and also you can use a light beam. So here I hope that my video works. Is you know, you can use a light beam to do annealing. You know, to do annealing of the coatings on glass substrate or glass panels. You can do that as well. So, for example, this one, you can use a light beam, you know, to conduct coatings on large glass panels to do that. So that's another application. So another application is you can form different beam shapes. For plastic welding, you know, square shape, rectangular shape, different shapes, much faster, you know, much, you know, efficient way. So the other is you can use a square-shaped beam or rectangular-shaped beam to do annealing, sintering, and the recrystallization of semiconductors and conductors. So this is also widely used in the industry. So we actually can combine the diode laser, even stacks. diode laser stacks, use beam shapers, then make a long line to do recrystallization and annealing sittery, this kind of process. So, and also we can use a light laser to do glass annealing. For example, you know, the length can be very long, you know, the ratio can be very uniform and at a very high power. So these are the applications we are developing. Another application is light beam for a railway or high-speed train inspection. When the high-speed train is moving very fast at 300 kilometers per hour, you know, how to do the inspection in situ situation. You know, you have a very strong light beam, very uniform to detect and, you know, as an illumination source to do the imaging inspection. And for LiDAR, for automotive LiDAR, you know, the traditional way is you have those dots, then you scan it around, you know, scan around, use you know, mechanical way or maps, you know, all that. Then what we develop is a light beam, a line so that you can scan one direction, you know, instead of two directional and the not efficient way. So we can develop a light beam to do that. And then another thing is we use a diffuser to do flash LiDAR, you know, just one shot, you know, one shot, you illuminate everything. And that's really nice because it's made of glass, you know, have no zero order and so on. So big field of view, we can make as large as 150 or 160 degree, you know, big field of view, and no zero order because this is not a DOE. This is we call ROE, refractive optical elements. It can be used for edge emitter laser, VCSEL, DPSSL, and so on. So in summary, my really point is high power diode laser is a preferred light source because it has a lot of advantages. Everyone knows that. However, it's not widely used. Why? Because it's poor beam quality. But, you know, beam shaping using micro optics cannot improve the overall beam quality of lasers. However, it can make the photo usable by achieving the power density, the energy distribution, and the energy, the beam shape you need. And my point is then matching and design cohesively of the high power diode laser and micro optics can really open up more application and drive growth. And I will look forward to, you know, work with the whole industry to drive the growth, drive more applications. Thank you very much. That's my presentation. And if you have any questions, please contact me personally or our company. This is a contact email address. Thank you very much.
Victor, oh my God, that was fantastic. Out of this world. I really always wanted to have the answer of why FOCUSLIGHT acquired LIMO. And you gave it so clearly because we have great laser diodes and we need to have the best possible optics for beam shaping and bring these laser diodes to places where they couldn't be before. And now they can be in LiDAR, even for flash LiDAR solution with 160-degree field of view. I honestly amazed. And it is difficult for me to get this reaction. So thank you so much for this. You're going to get now, Victor, you're going to get the epic question. So I have 570 members here. What can they do for you and what can you do for them?
They can do a lot for us. We can do a lot for them as well, for EPIC as well. So we are a Chinese company. We know the Asian market. We know the Chinese market better, but of course we have a global presence as well. You know, we look forward to work with our partners, your EPIC members globally to develop, you know, any market. Especially, we can share a lot of market information. For example, the Photonic West. I also shared this panel discussion. You know, what is emerging in the Chinese market, or maybe a little bit Asian market as well. You know, what can we do and how to collaborate? I think you know, every company has its own strengths and weakness, and you know, we are looking forward to work with all your members, all the partners to develop. The key is how can we drive the photonics industry to make the life, you know, human civilization better, you know, to make people's job easier. And that's the key. That's the driver. You know, we need to work together. You know, everyone has its strengths and weakness, and we work together to make the whole industry better.
One of the most Beautiful. I've been a fan of FOCUSLIGHT for many years. So one of the key technologies that stands out is your ability for very, very efficiently assembly your laser diodes. And now you bring micro optics to them. Was it a difficult process to add these micro optics to the high power laser diodes in terms of cooling, in terms of assembly, in terms of the right materials? How did you address that?
Very good question. So now after we presented, the logic why we require LIMO. It's really 1 + 1 = 5 or maybe 10. But now your question, very good question, is we are focused on diode laser bars. We still, I'm personally still a fan of diode laser bar. And we think the bar, of course, the problem is beam quality. The problem is beam quality. And then how to work with micro optics to make the light usable. And of course, it's a strong light. But the micro optics, it's pure glass. It's for example, we make really high quality micro optics. It's you got to have the right design to fully utilize the photons generated by the diode lasers. The process itself, of course, very precise alignment and so on. But it's not rocket science. It is a science, but it's not that difficult. We have developed a lot of process to optimize, to try to match the light source and the optics together, try to make the tolerance bigger so that you can use automatic machines to develop. And we ourselves internally develop all these automatic machines as well to be part of that, to align the micro optics and the light source together.
One thing that for me is key when it comes to laser diodes is the medical market, especially when you can address very good beam shape. Is an idea to push even more the medical market for FOCUSLIGHT now that there is so many demands on laser diodes for aesthetics?
Yeah, sure. Actually, probably FOCUSLIGHT have a good presence in the medical market, aesthetic market, and we are continue driving that. For example, hair removal, fat reduction, skin rejuvenation, how to make, we are old men now, how to make we look younger, healthier. That's all nice, right? So we think there are a lot of potentials there, and we are keep driving that by technology innovation, by manufacturing excellence, and so on to make it affordable. I think the key thing, the market is the potential is huge. It's just need to make it affordable so that all the ordinary people can afford it to use a laser to make themselves healthier, younger, look more beautiful, right?
Victor has the story of why I make a living. 2 + 2 can equal 10. He has the best lasers, he had the best optics, and now he has amazing roadmap to fulfill. Victor, thank you so much. A very inspiring presentation, full of room for cooperation. That's why I like it so much. Until the next time.
Welcome to FOCUSLIGHT. I invite you come and have a tour.
As soon as I can, I invite also all my 570 friends. We come to visit you in China. Thank you very much.
Sure.
And now all of us take our rucksack. We take a rucksack and we walk to the pyramids. We go to Egypt. We go to my very good friend Amir, and we go to ONGINEERING to understand a bit what all the members can do to help you be even better than you already are. Thank you very much for being with us. It is 10:20 in the Netherlands, in Noordwijk, at control station here. What time is it in Egypt? Let me unmute you first. I think we still have you muted.
Thank you.
What is 10:20 here? What time is it in Egypt?
It is exactly 10:20 as well. So we have the same here at the same time. Yeah,
excellent.
I wish you a great day and a good morning for all of the people
It's
who are
it's my sixth coffee already, so I don't know how I'm going to survive today. The floor is yours.
My first one. Cheers. So thank you so much, Epic, for the kind invitation. And I'm going today to talk a little bit about the ONGINEERINGCO. It's our company here in Egypt. I am Amir Roushdy. I'm the CEO and the co-founder for it. And basically, I'm so happy for the kind invitation because we are the only company they are going to talk today in such a big event from Egypt. And I think I'm going to have like a good plan to open the market for the peoples who are sharing with us all the collaboration work and all their beautiful and wonderful information. So and I have a really good news, because like I just here to FOCUSLIGHT right now, and I think we are in a good shape to start collaborating with them, because at the end of this presentation I'm going to show you something. It could be much more interesting maybe for both of us. So let us start to introduce it, my talk about. So basically, my talk today is going to be like about our platform for the optoelectronic solutions for automation and the medical technologies. So basically, in the ONGINEERINGCO, we are working with industrial automation and robotic solutions, and our strength point, I think, we are working with custom-made solutions and custom-made machinery for each client. And my talk today, I'm going to start with the intro about the company, what we are doing, which fields we are working with, and the examples for the industrial machinery that we designed and manufacturing with our partners, the robotics applications that we did, the medical application as well. And I'm going to show you at the end the products that we developed with our own technology, which is the controller for the optoelectronics and the controlling the laser. And at the end, I have like a simple project about the optoelectronics stand or the optoelectronics platform. And this is what we may be able to collaborate with the FOCUSLIGHT. So let me start first with what we are doing. So brief about us. So ONGINEERINGCO basically is an Egyptian company. However, most of our members coming from all around the world. So we have like partnerships, and we have like board members from China, from India, from the United States and Germany as well. So basically what we are doing, or our main vision, which is about manufacturing and doing a custom-made packing machinery for your needs, for the company's needs. And that would be happened with our electronics controllers and measurement and instruments based on the optical sensors technology. All our products, by the way, based on our technology, and we did that, like we have like so far, we have like almost 10 patents since we established in 2013. And our strength point, I think it's our people. As I mentioned before, like our board, it's consisting from professors, PhD holders, engineers. They are coming from different backgrounds, from different countries like Egypt, Germany, China, United States, and India as well. So also, I would like to say that we have like some parts of our machinery and the design projects. We are offering the lifetime warranty for some parts of our products, and that's give us like an intro, or give you a brief about how such a technology could be merging with the needs of the clients within their budgets. And now let me show you what we are doing. So basically we are working with 6 segments here in the ONGINEERINGCO. The first one, which is the mechatronics and robotics embedded solutions. So we are starting by creating controllers. These controllers could be able to be really familiar with the optoelectronics, like the controlling the temperature of the laser and controlling the currents of the laser and any optoelectronics fabrication system, as I'm going to show you later. And we have like industrial automation sector working with manufacturing and designing and starting scratch from the design view till we end up with the final product in our facilities here in Egypt or with our partners all over the globe. The biomedical application instrumentations as well. We are doing a custom-made solution for the e-health care systems, from the wearable devices that you could be able to wear and be able to measure your chronic diseases like diabetes or whatever problem that the person or the client or the company that could be able to have. Our custom-made optical sensors technology based on several approaches. However, we need some sort of collaboration from the companies who are working with the packaging, with the packing of the optical sensors technology, because we have such a simple lack about this part. We don't care a lot about the final packing, so we are not doing that with ourselves. We are relying on the outsourcing another companies working with that. Also, for the STEM applications or the STEM education, and the STEM, it's words consisting from the science, technology, engineering, and the mathematics. This is kind of STEM education offered for the new young generations in the high school. We are offering them a robot kits, affordable, with affordable prices, to be able for them to join the new era of technology, like optics, one of these technologies that we are pushing them to go through it since they are in the undergraduate studies or they are in the high school studies. And finally, we are having like outsourcing R&D departments for any other companies all over the globe. So these are basically the 6 majors or the 6 departments that we have at the ONGINEERINGCO, and all of these working simultaneously all together. And the big theme for that, it's SEMICONDUCTORS embedded in optoelectronics engineering. So these, like, I'm going to show you and share with you some of the final products that we designed from scratch and manufacturing them with our partners in China and in India as well. And here's the industrial automation products in the market right now. Our custom tailored machinery, it's fully about the automatic filling machine, the automatic shrinking grab machines, cartooning machine, pillow packing machine, and production lines. All these final products could be customized. So no one of these machines could be similar to the others, even if it looks like that from the outside part. However, based on the needs and based on the budget that the clients they offered, we can start from the project management and put everything on top from the designing perspective point of view till the delivery time. Also, the robotics and mechatronic solutions that we shared in the design, and it is in the market somehow right now. We started with the virus killing robots, and these robots is really familiar right now in the hospital, and a lot of people, they are working with that to kill the coronavirus or the RNA of the coronavirus for the UV disinfecting robots. So these kind of robots could be able for protecting some lives from spreading viruses or bacteria, something like that. And we have that in the market and in the local market right now in Egypt, and we are planning to globalize in this part, by the way. So also some robots in the shopping malls for entertainment. We have like collaboration with another partners in the United States to offer such a final product like this in the mall, in the shopping mall, and it could be collaborative with the UV disinfecting robot. And at the end of the day, it will be beneficial solutions for the mall shopping, for the organization that has a big company or so. And I would like to be like, I served the epic events like such several weeks ago. You had a conference about the UV and how it could be collaborating to kill the RNA of the coronaviruses and detecting something like that. So that's one of the projects that we could be collaborating with any companies who are working with manufacturing the UV lights as well. That would be really win-win situation for both of us. The delivery robots also, we are designing that from scratch, and we fabricated here with several companies in Egypt. And these kind of robots could be using is autonomous, fully autonomous delivery robots for the food delivery, for something like the pandemic situation that we have here in the all over the world. Once we have something like that with the clean and the safe, like say device or robots that would help us to save some sort of lives. Also, we have solutions in the robotics for pharmaceutical and biotechnology for doing like we can say like it's something like the warehouse that robots could be able to be in collaboration to make the sorting, to make all this kind of collaboration for put each item in a specific parts of the shop or in the pharmacy as exactly something like the warehouse robotics that we already made with our partners as well. Also, we did such a project with the robots in the office to avoid any problematic issues when the coronavirus started to spread it since the beginning of this year. We figured out a solution for any people to attend such a meeting as we are doing right now through Zoom or Skype or any other platform through this kind of robot, and that would be really good for saving also a lot of lives. From the educational point of view, as I mentioned before, we also, one of our segments or one of our department at the ONGINEERINGCO, we are working with development of the STEM education for the high schoolers and for the undergrads in the universities as well. So we did a platform, educational robots, to be able for them to contribute with their science they get in the theory to be in the practical part of view. Also, we are putting a lot of optical sensors. We are made it and fabricated from scratch in our facilities here in Egypt in such kits for the guys who are tinkering with electronics and playing with that since the becoming a very small age or in the early age for their lives. For the biomedical section and the e-healthcare solutions that we did in the market, we had, beside the manufacturing and the big mega production lines we produce or we designed from scratch, we also have an applications we did for the dental monitoring system. And this is like the application for the patient that they could be able to put their cell phones in front of their mouth once they open it and take a picture for it, and that picture would be followed by specifically doctors who is working in that part of the surgery or part of the problem that the patient is facing, and that would be interacting somehow with the patient wirelessly. But the beauty of something like that, that the sensing element, not only the camera in the mobile or the iPhone or whatever brand, the sensing element with that we did it here in ONGINEERINGCO by plugging the built-in camera that the iPhone or the cell phone it has with our customized optical sensors to get the most efficient picture and the most efficient product for the doctor to specify what is the problem with the patient. Also monitoring the technology for the chronic diseases like the epileptic cases. We had a lot of research and we had a lot of design sensors, custom design sensors for the guys who are having epilepsy. The problem with the epilepsy, once it starts to happen, it's started dramatically without any warning before. So the problem for customize such a sensing element and optical elements for optical sensor like that, you need a really high efficient resolution, and you need to know like it's very minute change in the electric field or in the electrical signals coming through the nervous system. And by the way, the action potential signals coming from the nervous system of the patient is physically could be converted to the electric field phenomena. That's why the optical sensor at that time designed to be morphologically changed once we impose the electric field to it immediately. And we have here like 2 patents we published in the United States. Our products right now, we have like 3 series. It's called ONGIEX series, UNIX multi-purpose series, and ONYX series. Each of these series are working with controlling the laser, basically its temperature. And why we are doing that? Because we are trying to make the portable solution. As you can see from what I mentioned before, all our products almost wirelessly. We are working autonomously. We are working with the robots could be controlled from anywhere in the world to anywhere in the world. So we are working here with these controllers to offer several categories. As you can see, the Blocks edition, Standard edition, Pro edition, Industrial edition, all of these editions except the Industrial one. The Industrial one is purely customized based on the solutions. All the project that I showed you right now had one of these controllers inside, and this is one of our own technologies that we offered. This is kind of the merging between the microcontrollers and the PLC controllers, the programmable logic controllers, but all what the user is supposed to control it embeddedly inside the system itself, just by typing some sort of numbers, and all these numbers would be converted somehow to machine language to operate the laser, to operate the end effector of the robot, or etc. What else? The UNIX multi-purposes, which is the new product that we have, it's actually we offered for the young generation, starting from the high schoolers till to be customized to the industrial. It could be controlled with more than one languages, starting from the graphical language to the up to the C language or the high level languages. So all these devices, basically, it's controlled like the core of it. It's made with collaboration with the Atmel company, which is support us with the custom CPU for that. And what is the beauty, or what is our strength point into this devices or into these controllers? Basically, it has a dual core or multi-core. So you can work in parallel in real time, and you can measure your data in real time, and you should be able to operate it with IoT systems. So by that, we can do like the Internet of Things becomes more easier. And that was really important for the upcoming 4.0 fourth industrial system in the future. And here's like the pin out for what we have, like the several cores, and it has like the analog input device, the connections, digital connections, and it's really easy and handy for the people to be able to work. And this is a solution from starting from the STEM education till the industrial to the industrial level. And we have like 4 machines working with that brain right now in the meantime. So let me show you how can the optoelectronics platform in collaboration with our products could be really good for our partners or for the collaborators in the next future. As you can see here, like this is the schematic for the diagram of the optoelectronics setup working with the micro optical resonators. So once we have like the laser diode here start to shine the laser and coupled somehow with the micro cavity, and this micro cavities could be, we are fabricating it basically from different polymeric material like polydimethyl siloxane, PDMS, or PMMA, polymethyl methacrylate, or in whatever shape, in micro toroid, micro rings, spheres, whatever shape. We have to track any minute change in the quality factor due to the photodiodes and return it back to the circuits for the controller to measure its temperature and the laser diode to avoid any kind of fluctuation coming out from the surrounding medium, and to make sure that any minute change in the wavelength is just coming from the effect of the change in the morphology of the cavity. So what we did for such a structure like that, this is a really good structure for the researchers in the laboratory. But you can imagine how the size for something like that in the laboratory, and it cannot be portable and it cannot be able to merge with industry. So the Unix series that we made before, that I talked before, is caring a lot about making a difference for the temperature.
So you offer this test unit to the community, right? Everyone from the EPIC community would like to get this test bed for their platform. That's what they contact you, and they get it. And this is great. This is great. This is what we're looking for. So basically, you can actually actively control any laser diode photodiode pair with all the microelectronics that they need. And when it works, then you have all the truth table to actually make the ideal of the electronic design. Thank you very much. This is great, Amir. This is great. We have 570 members here, and I want them to contact you for this particular challenge. It's been great having you here today. We got what we wanted from you, which is room for cooperation. There is a lot, Amir. Thank you very much. I'm going to come to visit you in Egypt. I promise. I'm going to come and visit.
Perfect.
Prepare a nice restaurant. I love food. Thank you very much.
I'll be waiting for you. Thank you so much.
And now we continue in this area. We go in the Mediterranean Sea. We go to a beautiful, beautiful, beautiful area of this world. We go to GESTAMP. We go to Spain. We go to Miguel Ángel. Muchas gracias por estar aquí. Bienvenido. Good morning, Miguel Ángel. It is 10:40, exactly the time for you to start your presentation. We have the same time zone, Spain and the Netherlands. The floor and the attention of everyone es para ti. Muchas gracias.
Okay, hello, good morning, everybody. Thank you for this great opportunity to be here today and be part of this great event. And we hope that our presentation brings interest for all the participants, okay? So I'm the R&D director of the Bilbao Center, and I'm also the responsible for the material joining competence in GESTAMP body in white. So first I will start with some brief introduction of the company, and then we will go into explain you and let you understand what are our latest innovations and one of our most technological features that we are developing right now. So first, I will introduce you the company. This is a Spanish company that started in 1997, and we soon had a quick expansion in the South America region and in Europe. We moved into the hot stamping technology in the beginning of the 2000 years, and then we continued the expansion mainly in the emerging markets and India, like China, Turkey. We continue doing some acquisitions like the EDSA Group, Thyssen Group, and in year 2013 it was important, the joint venture we signed with Mitsui, Japanese, very important Japanese group, and we continue our growth in the Asia region. And from 2017 we are a listed company, okay, and keeping all the operational excellence of the group. It's the most challenge point. Here some of our product portfolio. You probably know us, but for the people who don't know, we are specialized in body in white and stamping and assemblies like doors, B-pillars, bumpers, battery boxes, skin panels, front rails, cross carbines, and also a lot of chassis parts like front axles, rear axles, lower control arms, and also mechanisms. Okay, so this is our main product portfolio in the GESTAMP group. And we are a global company. We are 112 plants, production plants all around the world, and being present in 23 countries. Okay, one of our last companies opened in Japan a couple of years ago. In terms of R&D centers, I'm located here in the R&D center in the north of Spain, in the Bilbao area, but we are present in most of the top countries where all the automotive industry has a strong presence, like US, China, Japan, obviously in Europe, and also in South America, in Brazil. So from there, we are trying to support all the big OEMs and make our developments. This is a picture of our main technologies, and as I mentioned before, stamping, high strength steel stamping, hot stamping, but a lot of cold stamping, and all our technologies that are needed to join these materials, like laser welding, remote standard spot welding, and we are also have a strong expertise in tooling. We manufacture a lot of our own tools. Okay. So from now on, I will talk basically in the material joining, my competence. So the challenge, as one of the main challenges of today in the joinability of materials, is the joining dissimilar materials. But this is not a new challenge. This is a very old challenge that started in the beginning of the car manufacturing industry, where they were trying to join steels with wood, with leather. It moved quickly into the main steel, okay, but it moved quickly as well into the joining of steel and aluminums. And as of today, we have new challenges. Okay, we have to join, of course, new high strength steels with aluminum. It's also the carbon fiber appearing, new plastic materials, and we have to comply with all the new CO2 regulations, new safety regulations, and we have to be focused on to try to find the right material application in the right place of the vehicle. Okay, and be able to integrate this in our current production lines with less investment would be the best. Okay, so if we take a look to what it represents, the 100% of consumption of a vehicle, we are we need to take into account several factors, and what we are focusing as of today is how to take into account this 23%, which is the weight of the vehicle itself. Okay, and in this 23%, we have a lot of our body in white chassis and body in white and mechanisms. So it's in this weight what we need to focus, try to reduce, taking into account all the new safety regulations, okay, small overlap, car to car, or the new pedestrian protection regulations that we need to take into account. This is very important. Safer cars, lighter cars, but keeping into account, manage not to go into increase our cost. We need to find the balance. What is the best weight reduction? Technology might be not the cheapest, so we need to find the balance. Maybe we cannot go to the latest, but we can find the balance between cost and weight. Okay, but keeping the performance at the right level. So we will show you now a lot of our tailored applications, material properties, assembly technologies for joining the similar materials. Okay, so safer, lighter, and at a competitive cost. These are the three items that we need always to take into account. In our joining department, we are looking strongly to all the laser applications, remote laser welding for steel, for aluminum. We have, of course, also tactile welding for both materials as well, steel and aluminum. We have our what we call BKT. It's a new technology that we have developed. This allows us to create new steel, new grades, new material grades in a part by a diode laser. Okay, and we have other technologies like ablation, cladding, etc. So in remote laser welding, currently in GESTAMP, we have equipment that is available in our R&D locations. We have PFO systems from Trump, IPG combined with Blackbird, Smuller, Coherent. So we develop our latest technologies in our R&D centers. Okay, same we do with tactile. And same we are doing with BKT in our laboratory in Barcelona. And I will explain this technology in detail later. Okay. This is a picture of some of our products that are in mass production. This is an aluminum door that is joined by tactile. Okay. We use the Scansonic system, Allo3, with SCI for online quality control, and this is in production in the States. Okay, and it's a full aluminum door. Okay, this is another product that we have in production in Spain right now. It's a remote laser welded bumper, a steel bumper. Okay, and this has been supported by our R&D team, and we have the part in production for quite a few years right now. And this is an example or where we see where the market is moving, remote laser welding, full remote laser welding application for joinability of aluminum doors. Up to now, we have and we are using still a lot of tactile, but we believe this is the future for the remote laser welding, which will allow us to reduce the weight by reducing this flanging. And this is a line, technology line we are developing at the moment in the group. Another idea that we have in production, and it's also a very good idea in terms of weight saving, is to eliminate the flange for spot welding and going directly with a remote laser welding solution. Okay, this will allow you to reduce all the flange here in the, for example, in a B-pillar compound, keeping the same performance inside crash test. If we combine this one with our in-die-substance solution, it's a perfect solution for the OEM, okay, for side crash. I was mentioning before our new BKT softening technology. So this is a technology that uses a diode laser, and we are able to create a partial hardened area by laser heating, laser annealing. So if we consider a UC-Bor 1500 part, we can create new grades, 780 megapascal, 980 megapascal, local areas, okay, that will allow us to prevent spot welding rupture, or to allow us to create new bending solutions in terms of crash. So here I have some pictures of what we can do, local areas in corners, full soft zone bands, and we can start going backwards for a fully hardened solution, going backwards and create new grades, okay? That here I show you how the bending works. You know, we create huge and new bending properties in the car, and this will allow us to not only to control the crash locally, but also to join the similar hard steels with aluminum, okay? So if I want to join locally with rivets, a full hardened solution, and with 2 stack, it might be possible. But once I move into 3 stack, I will have basically a lot of problems in the joinability. So by creating a local soft grade, I can use a much more simple rivet and be able to join without any problem. This technology, we will have it in mass production starting this year in 2 locations, in Europe and in Asia. And we are using TRUMPF modules to be able to create these new softer local material grades, okay? Apart from that, we are working in several founding projects with another partners in order to develop new technologies for the similar material joining. So as a brief, mechanical joining aluminum and press hardened steels is a challenge as of today. We need to look carefully. We need to look carefully to the joinings of new fibers and steel, and how to take into account the adhesives in all these joinings is very, very important, okay? So we are studying this. We are working in our R&D departments to try to bring these solutions as efficient as possible into our manufacturing plants. I'm working with a lot of partners that are currently participating today in this event. I mentioned some of the names, but we are very happy to be working with them, of course. And this is the end of my presentation for today. So I want to thank Carlos and all the organization for strong support.
Thank you so much, Miguel Angel. It's been so great to have you here. For those of you who don't know, this GESTAMP is a leading automotive engineering company, and as you saw, a multinational company. I like that you were coming from the location in the Basque Country in Bilbao. Myself, I was born in Baracaldo, Cruces Hospital.
Very close.
I studied in Pamplona, so I am aware of the metallurgic industry in the Basque Country, really strong, an example for the innovation in Europe. Having you as a user here today is priceless, really, really priceless.
Okay.
So I want to make the best out of this. The first question I would like to ask you is, if you could ask the Santa Claus Christmas wish list of the ideal laser system, what would you ask? I know you already asked TRUMPF and IPG and all these companies, but tell me, what is your wish list? What did you cannot just get yet?
Okay, I think we need power. We need now to move into a lot of power generators, okay? And we need to combine this with very thin alloys of aluminum. Most likely the joinability of thin alloys with new lasers that are capable to work with high power. So lasers that are capable to work with high power to create very thin laser beams would be my wish list.
If there are, of course, any questions at any point, all you have to do is raise the hand. Another point that you raised during the presentation was that you were talking about actually welding new fibers with steel. And this is something that's coming a little bit. Is there a new trend for new materials coming to the automotive industry?
Well, we are looking to the joinability of steel and fibers and fiber to fiber itself. And for in the example of, for example, fiber to fiber, we think that the use of the BKT system, our system of heating locally and applying some pressure, can be with a combination of an adhesive, can be a good solution. Okay, can be a good solution. Steel to fiber. There are another possibilities. We think that it can be done directly in the stamping tool, for example, but there are another alternatives, of course. Yeah.
How does it work on the R&D? So basically, if I have a very good idea of using certain beam shape to do the perfect welding of steel with carbon fiber, how can we work together? Do you have testing facilities in which you could put everything in place, or do we have to go to AIMEN in Vigo, in Galicia, to work with them? How does it work?
No, we work, for example, we work with AIMEN a lot. We have a very good partnership, but we can offer our facilities and collaborate with any partner. We have presses, we have laser systems, we have tools open. You know, we just need to find the right project that has benefit for both parties. Yeah.
A couple of months ago, because I travel a lot, by the way, I have to come and visit you, Miguel Angel. I travel a lot. I went to ArcelorMittal, and I saw the manufacturing facilities there based on high power lasers. And I told them, what is your biggest challenge? And surprisingly, they told me, well, maybe it's okay, nobody's listening to us. He told me the fiber for high power in these harsh environments that we have here. Is that also a challenge for you to have the right beam delivery or the right fibers, that optical fibers that can actually withstand what it is to be in a metallurgic workstation?
Yes, and I think all the strong players that are present here today as fiber manufacturers, power generator manufacturers, they are aware that we have the same problem today. We can develop a very strong fiber or a very strong power generator, but we need to adapt it with a laser system that is able to work with. So we have to work together, the users and the manufacturers. Yeah.
I don't know if you know this, but I make a living out of that. We're just putting people together. That's all the passion that we have in the world. So we talk about the fiber, talk about the high power laser. There is another one, which is the laser optics. When it comes to the high power lasers, many companies are developing laser optics. It is crazy. More and more companies every year appear in events with new laser optics. But when it comes to the kilowatt plus segment, keeping the optics and the whole instrument cool is always a challenge. Do you sometimes have to go back to your people and say, hey, be careful, we are putting this into a kilowatt plus system, it is not ready?
Yes, that's right. I mean, we need to keep an eye always in the using and in the right maintenance of the equipment, keeping the optics in the right condition. Otherwise, it will damage the equipment. And we are aware of that. And as I said before, to work with the highest power requires the right optics. So that's why we need to work together, both integrators, users, and manufacturers. Yeah.
It is priceless to have you in this community, Miguel Angel. I'm going to come to visit you, but I would like to highlight there is a whole set of companies here who manufacture laser optics, a specialty fiber for harsh environment, kilowatt plus lasers, power supplies. The guys from PVF, they are great on this. All of you want to talk to you, and I will make those introductions to be ready to answer some emails and have some conference calls.
No
Miguel
problem.
Ángel, muchísimas gracias. Eres la
Muchas
estrella.
gracias.
Hasta
Muchas
la
gracias.
próxima.
Muchas
Thank you
gracias.
very
Hasta
much. We
Thank you.
continue this crazy 24 hours of photonics, and we go to Israel. And the next speaker is a very, very good friend of mine, Oren. Thank you very much for joining today from DUMA OPTRONICS. It is 11 a.m. here in Noordwijk in station control in the Netherlands. What time is it in Israel?
It's 12 o'clock.
All right, so we have Kobi from DUSTPHOTONICS and Oren from DUMA. We start with Oren from DUMA, and then we go to Kobi from DUSTPHOTONICS. Oren, thank you very much for joining. 12 o'clock, lunchtime, the floor and the attention of everyone is yours.
Best time of the day.
The best. I've been doing this already for 8 hours. And look how fresh I am, eh? After 8 hours. 24 is going to be so easy.
You'd see me after 5 minutes. And okay. So
we are ready for you to share the screen. You can go
I
to...
share the screen. All right. Because I send you like the...
You prefer if I share them from my side? That's okay as well.
I think because I do have some like a video there, or we can do whatever you prefer.
I prefer when you share them from your side. If it doesn't work, as a plan B, I'm here to support you.
Okay, okay, I will share it. You see my screen?
Perfectly. The floor is yours.
Okay, so I'll start. Hi, everybody. It's a real pleasure to have another epic webinar. Today, I'm going to talk about DUMA products, and I'm going to introduce somehow revolutionary type of technology. We call it the electro-optics hybrid measuring technologies. We'll start a little bit with a short introduction describing what DUMA is doing. DUMA is actually like a relatively small company with 20 to 25 people working, but we have like what we call enabling technologies. Our technologies are especially in the area of instrumentation. We have instruments for beam analysis, optical beam positioning, alignment measurement system, electronic photocollimators, and high power laser beam profiling. All those instrumentation, they are actually high-tech enabling technologies for other companies to be able to develop their own products. We have 4 product lines. Position sensing, where position sensing means we can tell very, very accurately what's the position of a laser beam striking on our detector surface. We go down to 0.1 micron, and the reason that we are using a laser beam for position sensing is because, to best of my knowledge, laser beam, at least at Earth's level, travels in a perfect straight line. So we take advantage of this feature, and we are able to do all kinds of comparative measurements and alignment using like a position sensing detector of a laser beam. The second product line is the alignment sensing. With the alignment sensing, we have several instruments, among other an electronic photocollimator and an automatic electronic photocollimator. And with that, we measure very, very accurately angular deviations. The third product line are the beam profilers, where with these profilers, it's actually an enabling technology for development lasers. We are able to measure low and high power lasers, and we also are able to measure VCSEL laser arranged in multiple array format. And last but not least is the high power measuring capability, where we can measure several lasers, starting from deep UV up to IR at power level of a few kilowatts. And on an advanced development, we have like a new type of instrumentation that we are developing. It's called Flex MTF, and it's for testing
lenses and cameras in mass production. We test MTF feature of lenses. We are capable of measuring a lens in about half a second over its full angular field of view. What's the hybrid technology? Actually, our hybrid technology is basically fusing several instruments together into one instrument. We have our, let's say, like the flag instrument that we are using for this type of technology is an autocollimator. What we did with an autocollimator, we fused together, we gave it the capability of a electronic autocollimator. We gave it the capability to be a laser beam profiler at the same time. And that helped us to bring together those parallel type but very close related technologies, and to measure laser position as well, angular directions of optics, of mechanics, and it gives all new applications for this type of instrumentation. We can make interalignment between laser, mechanics, and optical elements in one instrument and in one measurement. And we can also do measurements of multiple wavelengths laser beam profilers at the same time with a single autocollimator. One of the application that it almost gets me as excited as Carlos and Jose is the capability, almost the capability of measuring VCSEL arrays of laser, and to be able to tell the user what's the performance of each laser within a VCSEL array. And moreover, I can tell the user also what's the total direction of its VCSEL laser in regard to some mechanical like reference that it's likely used for attaching the laser to such application like auto driving or 3D recognition, face recognition, and things like that. In all those applications, there is a need to know what are the laser doing and what's the mechanical reference of the laser in order to further process it. So we do this, we do measurement of optical assembly. We are capable of measuring silicon wafers as well as lasers mounted on the silicon wafers. We do mechanical axis alignment, and we have special equipment for doing high power laser measurement by sampling the laser beam and testing its performance. For LAM, like laser additive manufacturing, we have a special equipment that we can measure beam size and alignment. As for microscopic beam, and this is out of the technology that we are going to talk further today, we are able to measure optical beams, high and low power, down to 0.5 microns. Okay, now we are going to talk a little bit further about the hybrid technology that we are using, like a regular laser autocollimator is given by this simple type of ray tracing. We have like a beam splitter, and we have an optical objective. We project, usually it's a cross, we project across through the optical objective, and it is projected to infinity. If this projected image is back reflected, is collected by the same objective lens, and that's the reason why this is called electronic autocollimator, and displays on a CCD sensor, further display. By doing that, we are capable to assess the tilt angle of this specific mirror. On top of that, the same instrument and the same objective is now capable to accept a laser beam, which does the same travel through the same optical objective and falls on the same CCD or CMOS detector, which is now transferred by software into a mode of measuring laser beams. So by doing that, we can actually tell the connection between the lasers and the mirror tilt angle. And this is our hybrid technology, where we make several instruments into one instrument. In this case, it's the autofocusing electronic autocollimator. The reason that we call it autofocusing electronic autocollimator, because it has also a built-in capability of moving the objective lens and then to focus to various distances. And now, one of the applications which it's very in today is the application of measuring VCSEL lasers. The VCSEL laser is usually a laser which is it's a vertical cavity, and it's done by the regular silicon type of manufacturing. And with this laser, you can, on one silicon, have many lasers, depends on the application. And from our point of view, you want to know what the relative power, position, and the direction of those lasers in respect to each other and in respect to some mounting area. And so by being able to do this type of measurement, we can also go one step further and measure the electronics of the same system. We can measure the optical back focal length of lenses system, and we can adjust laser diode position in order to make a system that projects the said VCSEL laser to a certain distance. And although all these things we can do just by shining this array of lasers into our optical objective. Here we see like a typical type of setup. Here we have like a typical setup where we have our electronic autocollimator. This is how it looks. it has a built-in laser that shines and shows the direction of the autocollimator, where is it looking for. It has like an optical objective, and that's the aperture of this optical objective. Here is the motorized focusing, by the way, very accurate line of sight retention of about 2.5 seconds. And here is the under test combined laser beam array. So what we can see here, we can see an array of multiple lasers. Each is equipped with its own collimating optics, and it's mounted on a mechanical reference surface, which could be ceramic or silicon. And this shines into the autocollimator. The pass capability of this autocollimator can tell the user what's the reference of the silicon and ceramic submount. Then when you turn on the lasers, you can find out what's the laser angular deviation from this mechanical reference surface. Moreover, you can find out what's the beam divergence of each of those lasers, what's the difference between the various beam divergences, and what's the power deviation in between the laser beams.
Indeed, and you can see that this is the perfect solution to measure pixel arrays.
Exactly.
Your time is almost up, and I know there is something at the end of your slides that you really want to share with everyone. So I'm going to encourage you to flip through this and go to the slide with the coronavirus, because I think people really want to see that. And you are already out of time, so I want people to know this.
All right.
So let's go to that slide.
My guy tells me that I have still 5 minutes here, but he's probably wrong. Okay.
Most likely he's right, but just listen to me, it's fine.
Okay, so that's a typical output of our measurements if you have VCSEL lasers. And where is the?
It is slide 17.
17.
Yes.
Okay. That's a new startup that actually it is a startup that was put together with the help of Epic 2 or 3 months ago. And here we have started what we are doing is something that we want to solve the problem of the COVID-19 coronavirus by offering a respiration protecting mask. The idea is to have like a throwaway mask. This is a throwaway mask. And here we have like a tube where air is provided to the mask. And inside this small device, we have a UV radiating LEDs that will actually sterilize all the inhaled air.
Such a beautiful concept. And what I like the most is that you came us with an idea and we put together a set of companies who really wanted to help you. And I can see that they are helping you, and that's a success story. The takeaway is that for VCSEL array characterization, you need to speak to my friend Oren, because he has all the equipment necessary for this to be done with the resolution that is needed for the VCSEL community. And also, I think he has gold in his hands when it comes to this mask for coronavirus outbreak. Oren, it is an honor to be your friend. It is great to have you here. We have to move on to the next speaker, but thank you very much. See you soon.
The honor is mutual.
And I continue in Israel. I stay in Israel. I go to my friend Kobi. DUSTPHOTONICS is one of the companies setting up the pace for vertical integration from photonic integrated circuits to pluggable transceivers. Kobi, thank you very much for being with us. Tell us how EPIC members can help you be even better than DUSTPHOTONICS already is. The floor and the attention of everyone is yours.
Thank you. Can you see my screen?
Perfectly.
Okay. So I'll introduce briefly to DUSTPHOTONICS and what we do, and take it on from there. So a little bit about us. We were founded in 2017. We specialize in optical package. Specifically, we design high-end transceivers, headquarters in Israel, and we have fabrication in Thailand and China, and sales and marketing in the US. We have about 100 employees. Background is very multidisciplinary, from optical design all the way through semiconductor processing, electrical design, high-speed electronics, signal integrity, etc., etc. So it's quite a multidisciplinary team here in Israel. Our mission is, like I said, is providing the datacom industry with high-end pluggable transceivers, and actually more advanced transceivers. I'll describe that later. And we focus on four type of components. The first one is multi-mode transceiver. This is actually what we sell right now in the market. And then we have single-mode transceivers, which are based on EMLs, pretty similar to the multi-mode, only the coupling is, of course, much more complicated. And then we have a lot of effort in silicon photonics. We are developing our own silicon photonics platform from scratch. And this is actually the main technology that will take us into the fourth item, which is, well, co-packaging or integrated optics, which will be silicon photonics based. So I'll spend a few slides on where we are in this ecosystem, because it's not so clear sometimes. Basically, we are working in the ecosystem of the data center or the cloud or the network or the Ethernet or whatever we want to call it. On the right-hand side, let me see if I can show my. On the right-hand side, you can see actually our three market segments. The first one is, of course, the cloud data center. I think this image is from Google, Amazon, Microsoft, Facebook, all of these hyperscale Ethernet providers, data center. And then another area of our market is high-performance computing. Everybody's talking today about artificial intelligence, big data mining. So this is basically, in reality, this is actually also a data center. And then last but not least, these are the enterprise networks, which are the more legacy or more well-known telecom systems, Deutsche Telekom, British Telecom, et cetera, any university campus, etc. Now, the data rate or the bandwidth which is going through those data centers is growing in huge pace. And you can see this graph from Cisco, which is very well known. We are talking about an increase of about 25, 26% per year. And it's actually getting more steeper and steeper. And the reason, of course, we all know it, social media, big data analytics, artificial intelligence, everybody's on the Ethernet, and the requirement just grows on and on. So looking at how the data center looks, actually on the left side, we see data center. I apologize, I'm not really sure which one this is it. It's also Google, I'm not sure. So inside the data center, the structure is what we see here. We call this factory, or actually spine leaf network. On the lower part, we see the servers, and this is actually where all the Ethernet activity is going on. And then we see a complete network of switches, Ethernet switches, which we call them leaves and spines and cores. And the idea is that each server is connected to all other servers in the data center via a pretty complicated network of switches. And the blue lines connecting the switches are the fiber optics in the data center. Each one of those fiber optics is, of course, terminated with a transceiver. The transceiver, that's what we do, basically converts the high-speed electrical signal into optical signals and vice versa. The distribution of length in the data center connectivity varies from a couple of meters, where actually today we use copper, but that will change in the coming years, all the way from 100 to 500 to 2,000 meters in a single data center. And of course, that dictates the type of fiber we use, whether it's multi-mode for the sub 100 or 200 meters, and then single mode for all the rest. So looking at a little closer into one of those Ethernet switches, and again, we are talking about if in a typical mega data center, we have like several hundred thousands of servers, both storage and compute. We have like between 5 to 10,000 switches, Ethernet switches. And again, these are the core of the Ethernet. And if we look at a typical switch, so we have the switch ASIC from companies like Broadcom and Cisco. And then on the front panel, we have the transceivers, the pluggable transceivers. This is an example here. And if you look inside the transceiver, we have some electronics, and then we have the optics that drive the signals. We are talking today, the state of the art is 400 gigabit per second. We are already working on the 800, it should be coming pretty soon. And the data speed that these transceivers are working at is growing, is basically doubling or even growing by a factor of 4 each 2.5 years, because whenever there's a new switch coming to the industry, of course, you need the optics has to comply with the speed. So the metrics in which we measure the transceivers are 3 basic metrics. The first and most important by far is cost. The only thing that those companies are worried about, well, not the only thing, but the main thing is reducing the cost of datacom transceivers. And in this graph, actually, we can see the very steep decrease of the average sales price of several transceivers. And the industry goal is to reach $1 per 1 gigabit and even below that. This is an industry-wide goal. It is pretty complicated to get there, but everybody is working on that. So cost reduction is the #1 priority for everyone. And then we need to reduce the power. So on the graph on the right-hand side, you can actually see the power distribution in the data center. And as you can see, the purple area is, of course, the power consumption of the servers, and the yellow is the infrastructure. So the network itself is just this tiny red line here. So you might argue and say, what the hell do you care about power dissipation? In reality, we are correct. Because again, the vast majority of power dissipation in the data center is from the servers. However, within each rack, and in a rack we have about 24 to 48 servers, the power allocation is actually limited. So the power that we can actually allocate for the transceivers is limited. So reducing the power while increasing the data rate is a key requirement. And last but not least, of course, reliability. We have thousands and thousands, tens of thousands of transceivers in a data center, and if one fails, it's actually quite a project to find it and replace it. So maintaining high reliability is a must. So in order to comply with these 3 optimizations, cost, power, reliability, you actually need, when we founded the company, we decided to redesign transceivers in a new way that actually will enable high volume manufacturing passively. We didn't really want to do any active alignment of the fibers to the VCSELs and to the lasers and to the detectors. And we wanted to eliminate the labor intensive. So actually, it's always possible to do active alignment, but then you need a pretty large team of technicians to actively align each and every fibers. Of course, you can automate it, but still that's still a time-consuming process. And in order to enable low cost, of course, we needed to simplify the design, both electrical, mechanical, and optical. And then we wanted that the single design will actually support the various reach and various applications like high temperature, which is actually needed today for high-performance computing, or very extended reach, like 300 meters in multi-mode, which is very difficult to achieve. And of course, to support various data rates. So this is actually what we did. So we developed a technology, we called it Aura DP. This is the core technology of the company. We see an example here on the left side, and on the right side, we actually see some results from this optomechanical design. The key here is actually the mechanical design along with the optical design. And one noticeable feature is that the spot on which we couple light to the fiber is very, very small. So it's an under-launch condition. And this allows us to minimize model dispersion, and actually we can actually drive the signal pretty long. Optically speaking, the biggest problem is actually coupling light from the fiber to the photodiode, because we need a negative magnification, because we come from 50 micron fiber core into a photodiode aperture, which goes smaller and smaller as we advanced in speed, because the higher the data rate, we need to keep the capacitance low, and of course that requires that the photodiode aperture becomes very small. So optically speaking, this is actually a pretty tough task, and you actually would like to have the same optical set do both tasks simultaneously, both receive and transmit. So this is the ORDP technology, and this is what we have developed in the last couple of years. And one of the neat features of this technology is that it can actually support numerous devices. So for the multimode design, actually the technology support actually from 25 all the way to 800G. So we have all those transceivers, and actually they have also associated active optical cables, which is actually two transceivers fiber connected to each other. So the same set of optics and optical design, actually the same set of lenses, is used for anything from 50 all the way up to 800. And a similar approach is taken also for the single mode design. Now the previous one, the multi-mode, is of course based on VCSELs. We're using Datacom rate VCSELs. And right now we have 400, all of these are actually in production, and 800 is actually in final design stages already. So 800 gigabit, so it's 8 times 100 per VCSEL. And on the single mode, we have two flavors. One of them is based on EMLs. Now the EML design is pretty much similar to the VCSEL design, except of course for the required accuracy. And again, the same design will support 400, 800, and probably in a couple of years, we'll be designing 1600 gigabit devices. And then we have also silicon photonics based designs, which are coming, and they will support also the 400 and 800. The reason for going to silicon photonics design is mostly to reduce the cost, because silicon photonics, as we know, is a CMOS based technology, so actually we are leveraging on the facilities and know-how of silicon design to drive optics in PICs, in photonic integrated circuits. And then it also takes us to the next stage of integrated optics. Before we go there, here are some typical results from the ORDP technology. So actually what we see here are scans of the VCSEL, of the fibers above the VCSEL and the photodiode and the coupling efficiency. And we can see for the laser, we actually have somewhere between about 90 micron of scans on either axis. And for the photodiode, we have actually pretty large tolerance of about 30 micron. Now, these results are very significant because they implement whatever we wanted to design. We wanted to design an optical system where the alignment tolerances will be very much relaxed, and therefore we can actually do a truly passive assembly. So many companies are actually claiming to have a passive fiber alignment, but this is actually, I believe, one of the true passive alignment. We use actually the simplest pick and place tool in the industry. We don't really need any specific accuracy, like 7 micron accuracy would be more than enough. And we can actually couple the light extremely efficiently, both into the photodiode and from the VCSEL to the fiber. So this is the basis of the ORDP technology. This is an example of our recent 400 gigabit multimode transceivers. This is a QSFP-DD design. They work actually pretty well all the way to with 300 meters. So we see on the left-hand side, the upper-hand side, we can see actually a typical eye diagram. One of the measures for the quality of the eye is what we call TDQ, which is a measure of the transmitter dispersion in the fiber, or basically it's the quality of the signals, and we have an extremely low value of 1.3 dB, indicating that our signals are propagating pretty well. On the right-hand side, we see some sensitivity curves where actually we measure the penalty associated with going to longer and longer fiber reaches. This is 50 gigabit per lane, and we can see that, well, in this case, going from 5 meters or 3 meters to 200 meters, the penalty 10 to the minus 12 is about 1 dB. So this is a pretty good performance. Last but not least, on the lower left side, this is some measurements of those QSFP-DDs 400G on a VRV network analyzer, and it's difficult to see, but you'll have to trust me. The average bit error rate is actually on all the PCS lines is below 10 to the minus 10. So this is, as far as we know, the best bit error rate for 400G transceivers in the industry. And actually, what's more important is the number of code words, because these optical packets are going through a FEC, error correction code, and we measure how many bits are actually dropping within the 5,000 bits that the FEC algorithm uses. And actually, we call those code words. And when you have 15 such failed bits, actually you have what we call packet drop. So, which is basically the end of the world for us. Typical result, if you see here, it's difficult to see again, I apologize, but we have like on average 2 or 3 code words. So this is actually a quite amazing performance, because this means that these transceivers can actually run FEC-free. So the operator can actually switch off the FEC on both switches, therefore they can save on latency and power. Now, I'll skip the single mode devices, because I can't really show too much here. And I'll talk in the last remaining minutes on co-packaging of switch ASIC and optical.
Yes.
Sorry?
Yes, please. Co-packaging is key for us. So yes, let's go to co-packaging now.
So I'll do it pretty quickly. So the limitation when going to 50 terabit and above switches, there are 3 main limitations. The first one is signal integrity. When I'm trying to push 100 gigabit signals, so 25 or 26 gigahertz at Nyquist, you have a huge loss of about 25 dB, which is basically a showstopper in terms of board design. Unless, of course, you can always go out to very complex board designs using Megatron 7, but the real problem is actually breaking out from the switch ASIC to the package. Breaking 100 gigabit traces is actually pretty impossible, or very, very difficult and costly. The second issue is actually the power. So this is an example, I think I took it from Cisco. This is a typical block diagram of a switch. We can see the SerDes blocks on the perimeter. And at 100 gigabit per bit of electrical SerDes, each SerDes, and we have 512 of these in a 50 terabit switch, consumes about 700 milliwatts. This is using 7 nanometer CMOS. So that's 7 picojoule per bit. Okay, if we go to 5 nanometer CMOS, it can actually drop to 5 picojoule, but that's more or less the end of the road. This means, when you do the calculation, that about 1/3 of the total power allocated for the switch is actually wasted on cheap I/O, which is overhead. And this is a real showstopper.
Indeed. I think it is clear on that. When we come to the co-package optics, we have been talking to many of the key companies in the sector. Actually, we have been talking also to the Kobo Alliance. For me, the main thing to explore here is what is the future form factor of the pluggable transceiver for 800G and beyond. I still don't know. I talk a lot to IEEE, I talk a lot to Ethernet Alliance and to OIF. Where do you stand? Is it QSFP-DD or is it OSFP?
For the 800G, it's probably OSFP because of the space limitation. It could be pushed into QSFP-DD. I don't think it's a big discussion. I think most of the industry said is OSFP. We don't think it's a big issue. We support both for 800. Above 800, we believe that the trend that is being shown here on the screen is what we're going to see. So pluggables, of course, will support all the way to 800. I think the OBO will be skipped. I don't see any requirements for the onboard optics, at least nothing significant. And then we will jump directly into core package, which is what we are working at the moment. I should just mention that complete hybrid integration, which is actually what we did in my previous company, Compass Networks, where you put the photonic circuits directly on the silicon switch. That will be the next stage, but I think it's too early. But here is an example of something we did a couple of years ago and actually worked pretty well in the field, not in the lab. IBM had also a similar project.
When it comes to DUSTPHOTONICS, you are very, very vertically integrated, but of course there is room for cooperation. I think companies who can optimize packaging, who can do testing, who can provide fiber to chip coupling, all of you EPIC members, talk to my friend Kobi. There is a lot of room for cooperation with this beautiful success story of the ecosystem. It is great to have you in this epic adventure, Kobi. Thank you so much.
Thank you.
And we continue in Israel. We continue totally crazy. Many people asking me if I'm eating my meals. I am. I'm still really strong. It's only 8.5 hours. Don't worry. And we go to precision optics. And I love precision optics and I love SHAMIR optics. Thank you very much for being with us. Tell us how the EPIC members can make the optics of SHAMIR even more perfect than they already are. The floor and the attention of everyone is yours.
Thank you very much, Jose. Can you hear me well?
Loud and clear, and we also see you very well.
Perfect. So we are at SHAMIR Precision Optics. I will be very happy to tell you about who are we, what markets and applications we are serving, our current capabilities, and we really have an exciting R&D roadmap bringing us well into the future. So we are located at the very north of the Upper Galilee over here with some really beautiful views.
We don't see your slides yet. Are you going to share some slides with us as well?
I'm sharing. Hold on.
Not yet. So you have to go to the arrow, to the share screen option at the bottom. So the green arrow. Click there, and then it will show you some options to choose which screen to share, and then you just select the one that you like the most for us to see. I think it's coming. In the meantime, I would like to remind everyone that if you want to connect with any of the participants today or any company to the ones I'm mentioning, all you have to do is send me an email. So you want to get in touch with Kobi, send me an email, I'll put you in touch with him. Thank you very much once again. The floor and the attention of everyone goes to SHAMIR, goes to Israel. And we have you now muted. You need to unmute yourself now. Perfect. The floor is yours.
Perfect. Okay. So as I said, we are located at the very north of beautiful Upper Galilee, with amazing views you can see behind me. And I'm going to tell you about this agenda with the 20 minutes I have. So SHAMIR Precision Optics is an Israeli precision, actually spin-off is a better description than a startup. We were established in 2018 and we are fully owned by Kibbutz SHAMIR. However, we are based on almost 30 years of freeform optics manufacturing at the ophthalmic SHAMIR optics industry company. So while we are, for precision optics, we are a relatively young company, we have tons of experience of designing and manufacturing freeform optics for the ophthalmic industry. SHAMIR optical industry is one of the biggest ophthalmic manufacturers, which is a partner of Essilor. We currently have 25 employees, 50% of them are engineers and PhD degrees. Very unique team, coming from a lot of very experienced people from the SHAMIR optics industry and quite impressive industry, electro-optical industry experts. And now we are finalizing our 5-year strategic roadmap. What is our high-level strategy? We are enabling precision optics applications all the way from the very early prototype to small and medium serial production with custom products, and I'll tell you about the main markets. But this is really key to enable very good collaboration with developing prototypes. And we see that that's a gap in the market. Many electro-optic companies tell us they are looking for partners for fast prototyping, partners who can understand them, work with them on their custom optical design needs. And that's exactly where we are heading. We are doing both prototyping projects as well as serial per unit projects. And we position ourselves as fast, meaning flexible and fast response, accessible, synchronized with the customer need, and technology deep and transparent. Our positioning is manufacturing process expertise with direct control and deep understanding of the CNC technology and coating technologies, optical design know-how, we can help our customers, partners with the design for manufacturability challenges. We can understand well their optical designs, and we can actually do some of the optical designs for them, and close collaborations with R&D and flexibility. Here are the market segments and verticals we are currently serving. Defense and aerospace is key, but also various types of mixed reality and augmented reality, a lot in the healthcare industry, but also consumer mixed reality. That's where we are today. We have a lot of discussions with companies in the healthcare markets, industrial lasers, automotive, and semiconductor. So that is coming up in the future, but really we are not limited to a specific vertical. Any electro-optical industry that requires precision optics that is highly customized, we will be more than happy to work with. So we do have a couple of innovation authority projects with the Israeli Innovation Authority. One of them is the freeform optical element development in collaboration with the Israeli defense customer, which we started the second year. And the second is development of advanced coatings based on a new Buehler coaters that we are in the process of ordering, and this advanced coating will be developed as part of this project. So which type of optics do we manufacture? The answer is every possible type of refractive and reflective mirror type of geometry. Of course, spherical, but starting with aspherical, cylinders, acylinders, and freeform, as well as complex contours and mirrors. A significant challenge, many times overlooked, is aligning a very complex contour, mechanical contour, with the optical axis, especially when it's a freeform optical axis that is not well defined, and that's part of our expertise, and not a lot can do it well. Let me tell you a little bit about freeform, because that's key and that's coming up in the future. So we are taking our core expertise, you see it up here, from the ophthalmic freeform design and manufacturing to the high precision electro-optical. Yes, it's the ultimate general form of optical surface. It's difficult to manufacture with high precision and more difficult to measure. It enables unprecedented compact and conformal design. It requires very high-end market in the very high-end market segments today in the defense, space optics, astronomy. And today there is no clear industry standard that takes these freeform elements all the way from the initial optical design to the manufacturing and metrology. Some unique or coherent standard is really needed. There are lots of activities in the scientific community, but still it's not a mature technology and relatively very little commercial activity. We are constantly improving our engineering skills. We anticipate sizable business to come in the next 5 to 10 years, and all the tools and technologies we are developing are freeform ready. These are our glass processing capabilities. We are working very closely with OPTECH. We are actually writing the software of the what we call the G code of those OPTECH machines in-house, and that's quite unique. That gives us a lot of capabilities and freedom. And these are high precision grinding and polishing tools with a lot of customization, as I said. And we are going to do a lot of digitization of our manufacturing floor with these capabilities. The next challenge is, after you manufacture something, it's actually much more complex to measure what actually you have manufactured, and you cannot manufacture anything you cannot measure. So we have both profilometer and computer-generated hologram tools that we are working in a closed loop with the manufacturing tool, with the CNC. So we are also going to acquire a MAR metrology system that will give us even more capability, but one of the expertise is really closing this loop between the metrology and the manufacturing. The next step is coating the elements. Practically very close to 100% of the elements that are manufactured needs to be to get some coating. It can be anti-reflective, it can be high reflectivity, it can be filter coating. like here, but we do have both sputtering and PVD coating capabilities today. A lot that we are taking from the ophthalmic capabilities and adjusting, developing them for our needs. We are going to get Buehler coaters. So today is mostly Satislow, and we are going to get additional coaters with dedicated high-end coating capabilities. Just a typical flow chart of what does it take to take a project from the very initial prototype phase to serial production, okay? So it gives people a little bit better understanding of the phases we are going through with the customers and how we are going to improve and to shorten this cycle. So we are getting an RFQ or an initial drawing. We're doing a risk analysis. Do you see this risk analysis table with the yellow and red high risk items? And the key is to do this risk analysis together with the customer. So the customer fully understands our risks and what are we looking for at the time of the quote. Because later, after we're starting the project, it can be too late to start discussing and communicating the risks. So once the risk has been fully aligned, we are providing a quote, we are getting a purchase order, and we kick off the project. The first phase is the process design. We are designing the exact shape, the G code. We are writing the code for the manufacturing and measuring, and of course, ordering the raw material, planning the raw material. This is the concept phase. It's theoretical. Then we run a feasibility where the expert of our company, you can see him here, an expert can manufacture for the first time the element by himself. And the next phase, we are lowering the risks. Those risks in every phase is a typical engineer in the design validation should do the same process and prepare the process flow for serial production, okay? Now, we are in the phase of, there's a lot of roadmap. We are investing here in making those phases much shorter and much more digital, okay? Much less manual, much less single expert thought, but a database and a database management. So all of this process will cut to maybe half once we develop this digital manufacturing floor capabilities. To summarize, while still young, we are well established. We have well established expertise in the freeform and the precision optics. We are implementing an aggressive 5-year strategic plan to achieve significant growth, both technology-wise and working with different market segments. There is a clear need in the Israeli market. For a vendor like us, it's extremely encouraging, the current response, but it's not limited only to Israel. We are expanding or plan to expand our sales to US and Europe as well. And the aggressive technology roadmap based on the multi-layer strategic plan includes both advanced metrology, high-end optical coating, and of course, advanced lens manufacturing capabilities, okay? So that would, in a nutshell, about SHAMIR Precision Optics. I really appreciate your attention.
Thank you so much. This has been great. Whenever people tell me about freeform optics, I get goosebumps because, as many of you know, that's really my secret passion. So whenever I'm not talking to you, I'm reading about freeform. I really like that SHAMIR, an expert on precision optics, talks about freeform optics are just optics with no elements. Are you looking for any potential partner that could help you develop a platform based on freeform optics for any of the current customers?
Absolutely. So any challenging application that will take us into, and it doesn't necessarily need to be 100% freeform. All the levels of complexity of geometry from the, advanced aspheric, toric, etc., would be very interesting for us. We are working on some really interesting collaboration in the space arena. We are working on interesting applications for medical. So any customer or partner that we can jointly develop the precision optical elements applications to better serve the market would be of great interest. Absolutely.
Fantastic. This is what the EPIC members can do for you and what you can do for them. This is the EPIC collaboration platform in which you are very welcome. When it comes to many of your markets, you need coatings. You need coatings for different applications.
Right.
Is it a challenge, taking into account that you end having some complex optics? Is it a challenge sometimes to deposit the coating so it is matching the surface that you are developing?
Absolutely. It's today, it's a complete form of art. Okay, it's much more close to an art than a science. There are so much black magic about developing and challenging coating. We are using tens of years of expertise or experience from the ophthalmic company, but we are working very closely with some customers, expediting their development cycles for their coatings. So it's a huge challenge. We are stepping towards more and more advanced technologies, developing this knowledge, accumulating the knowledge, so it will not sit only in one genius head, but become part of all of the company in a digital manner, as well as our customers. So there is so much to do there. Absolutely. It's as challenging, I can tell you, as free-form optics development, not less.
Another thing that I'm also very curious about, it is, oh, actually, I think I have a question. He said, no, a quote. Somebody loved that precision optics is an art. So I actually do love that quote as well. No, the question here that I have for you is, you are aiming for some markets in which there is need to address harsh environments. You need robust optics. Some of these problems can be solved with coatings, but others need to have intrinsic material properties. Are you looking at other materials to manufacture your optics?
Absolutely. So the variance on and the amount of typical other materials we are working with is huge. We are going to look also in the near future towards more pulling it into the infrared areas where you need different different families, but also for the visible range, you have tens of different families of materials with its own characteristics and processing challenging versus advantages. So material science is a big part of it. Our process engineers are material engineers, material scientists. It's basically the core expertise that is required to properly manufacture precision optics.
So as you know, I have a lot of friends here with me, and I have, of course, I mean, look, my friend from FACONTECH, Greg, is saying hello, but I have Bernd from SABIC also joining here. Look what he just told me. They are looking for partners in material science to develop materials for optics in harsh environment. Can you help him?
Oh, absolutely.
Lior, absolutely. Yeah, we have our polyether imide solutions, the ULTEM, which is widely used in IR optical solutions. And this is one of the best if it comes to chemical resistance. So I think we should talk more.
So I'd be more than happy. Thank you so much, Jose. You're doing a great job of bringing people together.
Bringing smart people together is easy. Yes, getting you working together is super easy, but then you get do great, amazing things together. We continue in Israel. Thank you very, very, very much for this great presentation, Lior.
Thank you very much.
And we go to CI Systems. I went to visit them a couple of years ago. I was impressed with the technology that they have and how they help many companies in the testing sector of imaging systems. It is great to have with us. No, sorry, we go to GAVISH. Sorry. We make mistakes after 8.5 hours. We go to GAVISH. We go to the companies that are actually making the great technology for SAPPHIRE manufacture. Thank you very much, Joseph, for being with us. Tell us how SAPPHIRE is making a difference in this industry and where to get the best SAPPHIRE. You get it from GAVISH in Israel. The floor and the attention of everyone goes to you, Joseph. It is noon. It is noon. I've been doing this for 9 hours. What time is it in Israel? What time is
now in Israel, it's 1 o'clock.
1 o'clock, lunchtime. The floor and the attention is yours.
Thank you very much. Thank you, Jose. Thank you, Carlos. Thanks for Epi and everyone there for the opportunity to share and to contribute and to participate in this wonderful gathering of technical people. I think it's an honor to work with the leaders and the experts in optics in the world. So thank you, everyone. We'd like to share our presentation. So 1 second.
I'm sure you can. Carlos is a good trainer here. I'm sure he trained you properly how to do this.
Yes, can you all see this?
Yes, perfectly.
So
tell us about SAPPHIRE. Wait, we have you muted by mistake. Can you unmute yourself? Can you? Yes,
okay.
Perfectly. Floor is
Good.
yours.
GAVISH is a company that this year we're celebrating 25 years. And it's 25 years of developing new applications, developing new products. And I'd like to speak a little bit about the extreme applications of SAPPHIRE that, in our opinion, only SAPPHIRE it's good for. So the next slide. So a little bit GAVISH. We are established in '95. We have an office in a sister company in New Hampshire. Of course, we have all the ISO approved. We make our own SAPPHIRE as well. We have this technology. We can make shaped SAPPHIRE parts. If it's rods, if it's tubes, if it's ribbons. So we can do that. We cater to the biggest OEMs in the world, and the markets that we cater to are from medical, high power lasers for laser using manufacturing, imaging optics, special cameras, space, and a lot in semiconductor. And we're going to explain why. SAPPHIRE, it's inert to fluoride acids, HF, CF4, NF3. It's good. We have applications that we have 70 pounds of 70,000 PSI on the SAPPHIRE and nothing happens. And SAPPHIRE is have a transmission from CS200, it's 190 to over 5 microns. So there's a lot of uses there. So I'd like to speak about, I mean, you all know what SAPPHIRE is, but I'd like to speak and share about our extreme applications. This is a plasma generator for one of the semiconductors. At the same time that they're trying to get the fastest microchip in the world, they have to measure temperature. They have to measure gases. They have to measure certain distributions of atoms. So how you do that if they're using HF? Using HF or quartz, on quartz, the quartz is going to disappear in a couple of days. I'm going to show you a picture of what happened when HF or the strong acids touches regular other materials, regular glass or quartz. And you can see here the difference in pressure. There's a lot of pressure in this equipment with SAPPHIRE and quartz, regular quartz. It's just a factor of orders of magnitude. Why not other materials? Because it has to be transparent. You see a lot of the tubes, the difference between quartz and SAPPHIRE. You see the difference of magnitude here is very big. This is what happened with quartz. It just etches away. The parts start melting, or so you cannot see, you cannot measure. It loses the flatness, it loses the ability to read, to see what's behind that window. SAPPHIRE, it can be there. We have a customer have the window for years. In quartz, they're replacing the part once a month. So SAPPHIRE is a lot more expensive, but you just don't have to look at the price of quartz against SAPPHIRE. You have to look at the price of having a company like Intel closing all its line to change the window. So the return on investment is a lot bigger. But there are applications, you can see here, you cannot even read what's behind it. The part just disappears. Sometimes we have an application that sapphire lasts 1 year. In quartz, it lasts 1 day. 1 day. So it's a big difference. So now a little more practical applications. That's an automotive application. That's a customer in the automotive industry. They use a laser machine to weld certain plastic parts made of polyethylene. And before they replaced this in sapphire, they had a lot of problems, a lot of losses, less yields, and the line was down a lot. Why? Because this used to burn. When it used to be made in quartz, this whole part used to be black, used to burn, and used to burn the parts that they used to make. So they replaced with sapphire. You can see the size of that. It's almost 200 millimeters in length. It's almost 20 millimeters thickness. What is it possible today in sapphire? Wasn't possible 20 years ago, wasn't possible even 5 years ago. We are always investing in different technologies and different technologies and machinery and people, of course. Without people, you cannot get anything done, the right people. And engineers, a lot of engineering capacity. We are an engineering company. We get different applications and we try to find a solution. So now they use sapphire and they're very happy. Unfortunately, they only needed a couple because it doesn't go bad. It doesn't go bad. So they were replacing a lot of quartz parts. Now they have a good yield because the laser and sapphire is very good for laser cooling and it dissipates the heat. So the heat is not concentrating on certain areas. Here used to be a problem with the heat in the middle where the circle is, and that area used to burn. So the next application, oil exploration. We had a customer, the top leader in the world for oil exploration. And in Asia, they were doing some exploration and they're having problems because when you have an optics, they had to real time send all the data of what they're finding, materials, heat, it's measure the concentration of different environments that they have around it. It's 5 kilometers, and I heard it sometimes 8 kilometers as well. It's 50,000 PSI. I heard also can go to 70,000 PSI under the ocean, under the ocean floor. So it's not just 5,000, sometimes it's 1,000 Celsius. And if it was not sapphire, used to break. And if it breaks, they just leave everything there and they make a new hole. Imagine those big oil rigs. Big oil rigs. And they have just to start over again because a small optic is not working properly. You see the shape of this part. It's all polished. Under the trapeze area, it's also polished. So what we can do today in sapphire wasn't possible years ago. We bonded the 2 pieces of sapphire together and still it's able to withstand 50,000 PSI. I don't know, if that's not incredible, I don't know what is. And so we can do different shapes. We can do different shapes and optics and put it together. The next parts, okay, these are the parts. We can, a little bit about other applications that we have in the oil field and semi. We have a lot of applications in the oil field and semi, and they had to do with resistance. We make thermocouples for different measurements. Some of them are up to 1 meter long. and they have an optic at the tip, whereas the optics is actually part of the thermocouple. It's all made as one piece. And it's born, sapphire is born at 2054 Celsius. So applications for these tubes where they have to measure heat and light and other sensors, it's made, it can withstand 1500. Another application that we have, which is not in a slide, but is here in my hand, why sapphire? We have a lot of applications where the optics, and if you can see me, you can see there's a sapphire window here. We can put sapphire within different mountings. And these mountings, why sapphire? Because I have to throw a 1 pound ball with a force of 7 joules on this window. Means a metal ball on this window, and you have to withstand. If it breaks, the whole project is off. And we're selling thousands of this window. We are testing in-house, and they have to withstand the same reason that a lot of watches are done with sapphire for scratch resistance. Now we see a lot of optics, big optics. So we can do up to 12, and we have 15 inches in diameter. We have windows that are up to 350 millimeters, which I'm going to show you right now. And they're made with sapphire, and they are wave, half a fractional wave over the whole area. So the things that are possible now in sapphire that wasn't possible years ago. So, and we're always ready for a good challenge. Challenge us. There's a lot of opportunities in sapphire. If it's for underwater cameras, to semiconductor, to space. We see uses in every opportunity. We sell a lot in the medical industry, where sapphire used as a cooler. Without the sapphire, customer had to develop this whole cooling device. But once we implemented sapphire, his device was a lot cheaper, a lot more useful, a lot user-friendly, because it was a lot smaller as well. No cooling device was required. Now, I don't know how we're doing with time. I think we're almost on the time. So I'm open for questions.
You're perfect on time. I liked so much that you managed to tell us exactly why sapphire is useful and what kind of application domains you have. But now you get the epic question. What can you do for them and what can they do for you?
We need to know what they need. Anything with extreme environments, very high heat, anything that requires transmission from 190 to 5 microns. Sapphire is great. We can provide parts with coatings, without coatings, shaped parts. We can do the whole turnkey in sapphire. We can, anything that has very high pressures, crazy pressures, 70,000 PSI, sapphire. They have my contact through you, and we're ready for the challenge. You're ready for the challenge.
No, you are totally ready for challenge. Me too. Look, 24 hours, what challenge.
We need to get you some coffee.
Yes, no, don't worry about that. There's a lot of coffee here. But what I think there is a need for is in the space industry. I live in Noordwijk, the European Space Agency, just behind these roll-ups. There's a big demand for sapphire optics, but they want to use them for free space communications. Do you see there is a challenge? There is a challenge with the transparency of sapphire in that domain?
We cannot really change the transparency of sapphire. The problem up until now with sapphire was the size. And the size lately has been growing. not just the size to making the crystal itself, is the challenge is the manufacturing. What was possible, like once again, things that up until 5-10 years ago was possible in 6 inches, now we can do it in 12 to 15 inches. That's almost 350 millimeters to make good optics in sapphire. The challenge was always the handling and not the properties of sapphire, but the capability of polishing big optics to a very good flatness. And now it's possible.
About 1 hour ago, we had an amazing presentation from GESTAMP, which is a leading automotive engineering company. And I asked them, because I knew you were coming after, I asked them, what kind of optics, laser optics are you demanding? And he was saying, well, we need to, they have to withstand very high power, they have to withstand very high temperature around, and they have to be able to survive for quite a long time. This is the kind of unique selling point that you have, right?
That's what I love, yes.
So of course, I will introduce you to them, but they need certain coatings. When it comes to especially laser welding, you need to have certain coatings in the optics. You said that it's possible to coat sapphire. Are you working with
sapphire, and we have applications where we can achieve transparency of over 99%.
That's what I was hoping for.
99%.
Yeah, you are really, truly in business. One thing that I also want to understand a bit is for the IBS coating, for the ion beam coating, do you have partners? Do you do it yourself? Are you looking for companies with IBS capabilities? Yes.
We have partners. We have great partners who've been working for many years, almost like the extension of ourselves. We're looking for other partners. GAVISH is growing. We're looking for joint ventures. We're looking to grow, and we're looking for good people to grow with.
What would be the ideal prototype of a partner for you? The kind of person that if I find you, you will be, I'm so happy, Jose, I'm going to buy you dinner. What would be the ideal partner?
Even without that, we'll buy you dinner. What about that, Jose?
That sounds perfect, of course. But what would be the challenge?
Things that complement ourselves, things that can take partners that can take one, and with them one, it's 11, not 2. This the type of partners we're looking. Not something specific just now, but partners to look long term. We want to go up in the chain. We want to go get into more assemblies. We're making parts. We want to get into the assembly level. So we are looking for partners that can help us get there.
Fantastic. Before we go, because we still have 1 minute, and I want to ask you something that's important. The automotive industry. When it comes to the automotive industry, we have seen a big growth on lighting, optics for lighting. And do you see this as a market for sapphire optics? We
see a market as the LiDAR, as in the cars that are driving by themselves. Not so much in the car per se, because the car hasn't really changed in 100 years. What is changing is the systems around the car. And when it comes to systems around the car, optics is going to play a big part. The cars are going to drive by themselves, and sapphire will be there.
Thank you so much for a great presentation.
Welcome.
If anybody is looking for optics that can withstand anything, 50,000 PSI, you go to my friend from GAVISH Sapphire, will help you out. It was a great presentation.
Thank you, everyone.
We continue in Israel. The last time I went to Israel, I was in Tel Aviv, and I took a car and I drove north. It was almost close to Nazareth. I stopped at a city called Migdal HaEmek, and I visited CI Systems. And I was really amazed with the technology they have for testing of any kind of vision camera system. Thank you very much, Amir Hill, for being with us. Tell us a bit about the technology of CI system, and also, most important, tell us how the EPIC members can help CI system be even better than they already are. The floor and the attention of everyone goes to you, goes to Migdal HaEmek.
Hello, Jose. Am I coming through fine? Hello?
Hello, we can hear you. It's not the best sound, but I think we can understand what you're saying.
Is it better now?
It's better, yes.
Okay, thank you for the opportunity, and thank you all And share the screen.
Carlos told me here on the back that he trained you very well to share the screen. He said he's now an expert on the matter. Fantastic. Yes, the floor is yours.
Okay. So thank you all again, and I hope you find this interesting. I've been listening for, I don't know, 3-4 hours, and it's really great. It's really nice. So I'll dive into my presentation. It's not going to be a very long one, and let me know if you have any questions. So CI Systems has been around for a long time, over 40 years actually. We are well-known and well-established manufacturer, mostly of electro-optical components and systems, and more specifically for testing electro-optical systems. That's what we do. That's what we did in the past. This is a kind of a short, very short and brief presentation of our products. We have a vast number of standard items, but our products are kind of split into components and systems. So components, we can look at them as the black bodies. We're the world's probably #1 manufacturer of black bodies. Black bodies are calibrated sources for infrared radiation. Integration spheres are used in the visible range, visible shortwave IR range for testing as calibrated sources. Stages, accurate precision stages for optical equipment. And then we have higher level products. So we are the world's leader in what you see here on the left is a spectroradiometer. It's a system that can test the spectral content of a single point, a single area in the scene. It's very useful for many types of investigations, I would say atmospheric, environmental, material studies. Whenever you want to get a good spectral profile of an object, what it's emitting, this is the instrument to use. And then in the middle here, you can see one kind of a big test bench. This is a very long focal.
Amir, would it be possible for you to speak just a bit louder? Because you have some white noise in the background that I think with a bit of signal to noise ratio, we're going to be in a better shape.
Is this better?
A little bit louder.
Okay, even more?
Perfect now.
Okay, so as I was saying, we can see here in the middle, we can see a test bench, a long focal length collimator with some target wheels and sources. So this would be a test bench used for like a space grade camera. On the right hand side here, you can see two of our many solutions for boresight equipment, for aligning electro-optical systems. When you have a payload that has let's say a few optical instruments on it, like a laser rangefinder, a designator, a day, a night camera, and you want to align them all. So we supply solutions to do that. But now moving on to the subject of this presentation is actually our first attempt into the IR imaging market. And we've just coming out now these days with a new product that we're very excited about and want to use this opportunity to interest people in. And actually, it's an imaging platform that is aimed at applications that are complex. So this is a small box, kind of, like I would say a very small shoebox. And in it is everything you need. So it's a visible camera, it's a long wave IR imaging camera, and inside it is a very strong computing hardware, everything integrated into one small box. And all of the processing is done on board, And what you get out of it is the results streaming over web interfaces and ONGINEERINGCO protocols, so like a real-time video. Plus, you get onboard signaling from the unit itself, so you can get directly from the unit without needing to pass through any additional computing device. You can get a 420 milliamp, and you can get RS-485 outputs in parallel. This solution that we call TCAM accommodates, it can come with different focal lengths for different applications, and the infrared images are, of course, calibrated using our sophisticated calibration equipment and registered with each other. So you get a perfect registration between a full HD type of image and long wave IR calibrated image. And then one of the nice things that we did here, I think it's I don't know, actually, you know, I don't like to brag, but I haven't seen anybody that reports an accuracy that is better than 0.5 degrees constantly in an uncooled camera. So this is something that I would like to focus on for a minute, because I think I haven't seen it done yet. And what you can see here on this chart is a simple test that we ran last night or the day before. And we left the camera running for 10 hours, looking at a few black bodies at different temperatures in the 34 to 40 degree C range. And this is the type of measurement error we are getting on those temperatures. And I think this is really outstanding for an uncooled thermal camera. You can see that on average it's 0.2, and there's hardly a single point where it goes over 0.5. So this is very good performance that we can compensate for ambient temperature changes and correct our measurements to get this kind of good quality. Since we have this high quality thermal image, the first solution we implemented on this TCAM is the elevated body temperature screening that is very, you know, you've seen it all over because of the COVID-19 pandemic. And actually, to be a viable product to do this screening, there's a directive out there that is called IEC 80601-2-59 that says that you need to be accurate better than 0.5 degrees C to get any kind of, I would say, sufficient information to say if a person is you know, below or above a certain threshold. And typical for what is now typical for uncooled cameras, because this is what everybody uses, is to have an accuracy of ±2 degrees. So if you really want to do some, you know, real screening and report some real temperatures, you need to get down to that 0.5 accuracy. Because of our large computing power that we have on board, we have, of course, artificial intelligence-based algorithms that quickly detect the tear duct in the human eye and measure the temperature there. That's the only place that you're actually allowed to measure that has good correlation to the core temperature of the person. And this camera can operate connected or even standalone without just supplying it with power. You want to stop me, Jose? Jose?
Yeah, it's going well. Continue.
It's okay? Okay. So this is kind of an illustration of the process where a person gets screened by this TCAM. You come up to it. You need to stand for a few seconds and get your selfie taken by the camera. You get the camera automatically finds the right location to measure, which is right here in the inner part of the eye. measure the temperature and gives you the okay or the, go get tested invitation. But this is just one application. This is the many connection options you can do with this camera because of its advanced. It's actually has an embedded computer in there, so you can go wireless. You can go no connection. You can go with a direct cable connection, or you can go through some kind of local network. So this was the first application that we worked on, but we are really pursuing industrial applications of temperature monitoring in environments where the capability is limited today because of false alarm sources. So there are many of those out there, waste management, all kinds of places where temperature monitoring is important, but it needs high quality image-based algorithms to differentiate between false alarm sources and the real sources that need to be monitored. And actually, that's the end. This is what I wanted to pitch outwards. This is what we are looking for. Anybody interested implementing their own, using this as a platform for scientific applications, for any monitoring application that you have out there. We are open to get your, questions, connections. That's it.
Thank you so much, Amir. Thank you for joining this. I apologize for everyone. The sound was not ideal, but we could hear you and we could understand you. Most important here is that we want to cooperate with you. So if you could tell me, and please speak loud, but you could tell me, what can the EPIC members do for you and what can you do for the EPIC members?
Okay, so I hope you hear me. I'm sorry about the sound.
Don't apologize about the sound.
Okay.
We can hear you.
Okay, so this is a kind of a new product in terms of its accuracy and its imaging algorithm capability. And if you are out there and you need something that has this added capability, you want to use it, integrate it into your own product, use it as a scientific research, you have a specific application that you could not find a solution for, we would really like to hear back from you.
Excellent. Thank you very much. I think because of the sound, I am going we're going to move on with the program. But before that, I have a person who just joined the channel and I would like him to say hello. Hello from PhyContech, which is a company that I really, really love, all the way in Akim, next to Bremen. Gregory Flynn just joined. Greg, thank you very much for joining today. It's a 24 hours and a special day. PhyContech has been positioned itself in the middle of the supply chain of packaging of optoelectronics. What can you do for the EPIC members and what can the EPIC members do for you?
Oh, well, put on the spot at short notice. Well, we are, in general, we are looking for partners and companies that we can help. Let me start again. We are heavily involved with development of the ecosystem for photonics assembly and test. We're looking increasingly at developing testing systems for VCSELs and PICs. We are looking for partners and anybody who has specific needs in photonic integrated hybrid circuit development, assembly and test tasks. We have applications groups, we have apps labs, and we are looking for challenges as well, just as much as anybody else here in this session.
What I love the best about PhyContech is that you have managed to help the industry automate their solution. And when the industry told you, we don't know how to do wafer level testing, you said, okay, we're going to put all the instruments there together to do the wafer level testing. I have a lot of friends today and I want to say hello to all of them. I see that my friend from ST Microelectronic, Eric Masailerat, has just joined. Eric, how are you doing? Let me unmute you. You're muted right now. Can you unmute yourself? Yes. How are you doing today?
I'm fine. Was very pleased to follow some of the presentation this morning and quite happy to present as well this afternoon.
9 hours and 35 minutes awake, and I'm super happy so far. We have seen a lot of presentations about optical pluggable transceivers and the idea of going into the semicon manufacturing business. In my mind, interactive photonics is a semicon technology. So as I said many times, we need to have ST microelectronics very, very involved with the members of EPIC. I know your presentation is later, but if you could summarize just in one sentence, what can you do for the EPIC members and what can the EPIC members do for you?
Regarding this silicon photonics, we had, let's say, quite important experience in that field, mainly directed to datacom activities. But now we are able to, let's say, refocus this know-how in terms of process, in terms of devices to new applications that we are targeting, which are more, let's say, directed to other type of applications like biosensing, like spectrometries, like LiDAR. So I will briefly describe this afternoon what we are.
It is, at least for me, it is very exciting times to be in the semicon technology because optics are coming constantly. So now you have the people with the quantum dots that are enabling the next station micro LEDs. You have the people with the pixels who need to be there, they'll directly plug into the semicon processing. You have the micro optics, the wafer level optics, the co-package optics from the datacom. So for me, having you in the ecosystem is priceless. Once again, I would like to thank you for all the support. I introduced you to so many members and you are following up with all of them. And we'll keep doing so. So if anyone from the EPIC membership wants to be introduced to ST Microelectronics, Eric is our contact and he's a star. Just send me an email, I will make the introduction. And we continue with the program. 9 hours, 37 minutes, and we keep rocking and we go to Greece. We go to Greece to talk about photonics in Greece. I have been talking to my friend Ioannis Tonkos in many different projects. I know in the telecom sector, you guys are fantastic. I have been to Iraklio many times, so I know very well also that the work that is done there is awesome. But I want to know, as an industry association, what is going on in Greece? Thank you very much for joining us this beautiful afternoon. It is 12:38 here in Noordwijk, the Netherlands. What time is it in Greece?
It's an hour later. It's 1:40 right now.
Did you already have lunch? Because as you share your presentation, I'm going to have my lunch because here is 12:40, so I will have lunch enjoying the beautiful photonics from the Greek ecosystem. The floor and the attention of everyone is yours. Llamas.
Can you see my presentation? Because
it is coming. I think you are trying to share it, but it is not yet here. So if it's okay with you, let's just give it one more shot. If not, we will share it from my own screen. It's here. Now we can see it.
Okay. Doesn't like to go to the, okay.
The floor is yours.
Thank you very much, Jose. I'm Elias from Jopoulos. I'm coming from Greece, and I will Hellenic Photonic Cluster. It's an organization that is formed in 2015, and it is started from different companies, enterprises mainly, and also in collaboration with RTOs that already Jose mentioned some of them that he knows and collaborate. Of course, it's all these places and organizations that Jose mentioned are part of our group in our company. What I mentioned earlier, it is that we established in 2015 as a private not-profit entity. And we have as shareholder the companies that belong to the cluster. RTOs and not Greek companies can be associate member to this entity, to the cluster. What is important is for us, what we like to do is most of our partners are close to the region of Athens or in the region of Athens, because perhaps you know that most of the facilities, RTO facilities are located in the great area of Athens. But of course, there are some in Crete, in Salonika, and other places in Greece. Further, what is important is that we like what is we are aiming through the cluster is to produce new products and services. And actually, we're working in a complementarity scheme, like a value chain, and we try to address specific application. So in our cluster, we have end user, and we try to serve them by providing holistic solution to their needs. And this is what is sometimes different from other clusters in photonics that are a pure photonics organization involved. So this is what we like. It is important for us is to have the value chain, and what we try to do is to organize an ecosystem that most of the companies and RTOs that are related to photonics, or they're using photonics, or they serve photonics technology, could be integrated in order to have this, to develop the new ideas or innovative products. The cluster is active in technology and research, collaboration, the ecosystem. I talk a lot about that. But what is also important is to go abroad, because Greece is a small country, and we are never talking only for Greece. But all the companies that belongs and organizations that belongs to the cluster are looking outside Greece in the global market, let us say. As I mentioned, we start in 2015 with certain partners. This it is increasing by the time during this period, and you can see the logos of different companies that belongs to a group. That most of them, or a lot of them, are startups of the different research organizations that participate also in the cluster. Mainly, we have SME company, because this is the 80% of the companies in Greece. So what we like to do is to collaborate in a chain and to have an integrated solution for our production line, let us say. Here you can see more companies that are, and organizations that belongs to our network, and this is our international network that we collaborate in different projects. The cluster is already involved in a few European projects. You can see the two first are actually helping and supporting the Photonics 21 PPP, while the third one that started this year is a research project, and we participate as the technology diffuser and innovator manager for the project. The common questions that are coming, I'm try to be a little bit faster, Jose. So we have different working groups in different areas, like scanning, sensing, and imaging, energy system and photonics, photonics and additive manufacturing space, digital infrastructure and manufacturing. So, and try to organize the ecosystem. This is what we have to offer to the EPIC member. And we like to provide reliable partners from our group to the other member of the EPIC. Also, what we like is to assist collaboration with the Greek RTOs. Of course, they have a lot of projects with many companies and organizations in Europe, European project, but what is important is to talk about bilateral contract and not only on research through the European Union. And what we like, what we can, the EPIC members can do for the HFOS is we are interested for technological business networking, collaboration to cover the missing value chain links. We need companies that produce different components or different hardware, let us say, that can be organized and complete our value chain. It is interesting the collaboration of our companies in HFOS with for product and services in the development for the international market. Funding, of course, always funding for the startups is very important, and everybody is talking about this, but we know that it's not so easy for photonics directly, but it is there, and there is a need. And other things that I would like to ask is collaboration as a supplier or subcontractor of the Greek companies to the international companies or the companies that are member of the EPIC. And of course, as I mentioned earlier, companies to use our RTOs, the Greek RTOs, for their R&D project. I was a little bit fast, but this was what I would like to share with you. Thank you for your attention.
You were
and
perfect. You were perfect. Thank you very much. You see, I was eating my lunch while you were talking, because of course I need to survive. I've been already doing this for 9 hours and 48 minutes, and it was really good. I have one key question here, which is I go to Greece a lot. I love Greece, and you have some of the best scientists in photonics in the world. Some of them still in Greece, some of them they went outside. However, the creation of startups has not been at the same level. Is there anything apart from investment, of course, anything that you think EPIC can do to help the creation of more photonic companies in Greece?
It's a problem with the laws that government governs the Greek RTO organization. So this brings a lot of difficulties. And this is an area that we try as a cluster to involve and try to change methodology and the way that the startups can be formed. I mean, how people from universities and academic areas can form their companies, because this status is completely different in Greece than in other countries in Europe. We have now a more positive environment, but we have a long way to walk.
Being in Greece, one of the cool things of being the cluster manager is that you are constantly talking to the CEOs of the companies, and you are also talking to the main people from the RTOs. What is the next big thing in photonics coming from Greece?
You know that in Greece we have done a lot of things in the past for cleaning the different sculpture and icons, which is very important. You can see this situation and these systems working in Acropolis Museum. It is not clear what will come in the next period from Greece, but as you said, there is a lot of work is performed in Greece with high value, high standard personnel, and we're working to have our best to support the photonics community in Greece. But of course, we need a connection with Europe.
I think there is a lot of connections. The fact that you are engaging with EPIC will help. The fact that you should know, in my opinion, the work of optical network design, it is out of this world. Also, the work on laser-based manufacturing that is done also in Irakli or in Crete is also out of this world. I think there is a lot of room for cooperation here, and I think there are many big things happening. And I hope Europe can support the ecosystem of Greece to make sure that there are more photonic companies in Greece, because we deserve that, and we also want to have an excuse to go to Greece more often. So thank you very much for a great presentation. Thank you for being with us, and stay tuned, because the next presentation is one of the big things. It's one of the big things I'm seeing in Europe. We are going to go to one of my favorite countries in this continent. We are going to go to Estonia, and we're going to go to a company, Marduk Technologies, that I've been engaging with them always in the defense sector, but the technology for computer vision, the technology is really fascinating. Let's understand what they do. And most important, let's understand what we can do, all these 570 companies, what we can do to help Thomas, and what Thomas can do to help EPIC. The floor and the attention of everyone goes to one of the companies with the most beautiful name in photonics, Marduk Technologies. Thank you very much for being with us. The floor and the attention of everyone goes to you.
Hello, everybody. I'm Thomas Pruden from Marduk Technologies. Let me now see if I can get the presentation starting up. Just a moment.
I'm sure you can. Just go to the bottom of the screen, share the screen, green arrow up, click there. People from ST Microelectronics, Elbit, SHAMIR, GESTAMP, SUS want to cooperate with you. This is their chance.
So I hope it works.
It works great. The floor is yours.
Thank you. So Marduk Technologies, we are just a small Estonian startup. We were established actually on Estonian Ministry of Defense grant for specifically dealing with targeting and tracking of small objects. The name maybe actually is familiar. There is a rather famous hard rock band called Marduk, but this is not actually the name we got the inspiration from for Marduk. Marduk was actually a Mesopotamian god who was active something like about 5,000 years ago or so in the area of Syria and Iraq, and he had to take a part of civil war and quickly recognized that he needed to develop actually a anti-dragon capabilities. The good news is that he succeeded, developed the technology, and now we are something like 5,000 years later in pretty much in similar situation. There is again civil war in Syria. We do need anti-drone capabilities, and the name comes from similarities. Okay, what we actually mostly do is concentrating on automated targeting and tracking, as already mentioned, and specifically on small unmanned autonomous vehicles. Core competencies is machine learning, optics, mechatronics. Mostly we actually concentrate on the machine learning part. Yes, just a short overview what the systems do look like. Just typical optical gimbals with different payloads. The main task is to have a sufficiently good image quality, sufficiently good accuracy over reasonably large distances. This is up to 5 kilometers depending on the situation. Mostly currently we see that there is a miniaturization trend towards making the drone smaller, so the task is going, in a way harder and harder all the time. The effectors we currently use are mostly laser blinding, sensor destruction, but the platform itself, the carrier, can actually carry other type of effectors, but this is more like, outside of Marduk competence. Okay, just a small video here about typical segmenting and target tracking. This is actually here about, I believe, 1.8 kilometers, 30 centimeter sized object, so reasonably good, at least for us. Okay, about the problem more a little bit. There are different aspects of the problems. There are civilian and military both. We do have, the airport problem that is now quite well, alleviated by the virus, but still it might be that, the rare things like passenger planes still do come back. Then we have actually critical infrastructure like nuclear power plants, civilian protected objects, military protected objects that do need some kind of protection against also surveillance. We do have problems that takedown methods currently cost too much. So there was very specific event where the Patriot missile lead took down pretty much consumer drone. This is not really viable, so we need to just get costs down. About the market, this is just a general overview. We expect something like 20 to 24% annual growth, and the objects are so numerous that the market probably exceeds growth predictions instead of underperforming. About the current countermeasures, most of the stuff that is currently developed is to jam radio frequencies, just to jam the control signals and jam the GPS. This most probably won't work very well. Already it somewhat doesn't. There are optical navigation methods. Pretty much similar things that we are developing are, developed for the drones that are looking down and can actually fly around and have the correction of the position from the landmarks. So without any kind of control signals and GPS locations, and still can reach the target. Most of the typical takedown methods are some kind of kinetics, rockets, nets, something like that. Also, there are high-powered lasers in development, but the price ranges of actual laser weapons still are somewhat prohibiting of widespread use as a counter drone weapons. Okay, the main thing there is that takedown method cost needs to be in at least somewhat same ballpark as drone cost itself is. Just a short overview what there is, magnetometric checking, acoustic checking. Typically the current is radio communication already mentioned here. Then we have optical detection methods and tracking methods like LiDAR and the longest range currently, but the most error prone is still radar. But for small objects, it's just either doesn't recognize or is just over helmet by clutter. Okay, yes, this is just funny notation that Eagles biotech is still quite viable. This shows that the market is still quite young, at least for the anti-drone stuff. Okay, this is just somewhat boring. Who is doing what? Yes, traditional Miltech systems still pretty much above $1 million per piece that are effective, even just going even to the ballpark of $5 million. So there is a serious need to get the price down to to be at least somewhat competitive towards the fast development of the commercial drones that can be used as any kind of either noise sensor or then a actual weapon. Okay, short introduction, just image. This is one of our platforms, fully automated classification, confirmation or dismissal of either it's treat or either it's just bird or either it's just a consumer drone that doesn't actually approach enough to be actually any kind of treat. Total passive detection as option, so it can be so silent that in military situation you don't have any kind of reveal of the system. Various possible payloads, as already commented. What we do, we just detect it mostly optically in different conditions, specifically high turbulence conditions. Also, we attempt at least some development in fog and in heavy rain, but this is somewhat in early phase in connection to event cameras and gated systems. And secondarily, we identify and track if we have good classification and the object is classified automatically, then the track can be also automatically continued. And the third option is either destroy the imagers, or if there is a third-party payload, then we can also destroy. Okay, now just a short overview of what can be, let's say, developed if necessary, or if there is actually a, let's say, request for the technology. We have a small laser-based system. We have a mobile car-mounted anti-drone system. There is an early development phase of small rocket carrier that is actually in some ways interesting. Typically, rockets are self-guided, and this drives rocket prices up. For small targets that are maybe also in areas that are prone to collateral damage, you do need very specific things that are cheap and actually very harmless. So specific rockets that are actually not explosive, we do some development on those areas. Mine development still goes to the precision targeting. This is how to say the basis of our stuff what we're doing. And also there is a automated surveillance that is not actually specifically in connection to the targeting, but still we also do, the machine learning methods are pretty much overlapping anyway. Okay, what we actually, let's say, plan to do and what we actually do develop already. One thing is featureless behavior classification. If you are attempting to classify very many small objects far away, then it's just one or other thing. Either you have very narrow field of view, or you have wide field of view and you have almost no features. So from 5 kilometers, wide field detection needs something to actually detect on. If there are no features, then there needs to be automated behavior classification. This is one development. Then additionally, event analysis and classification. Event cameras are very promising for very specific parameters of drones and other flying and moving objects, to have automated clustering and automated learning actually of the behavioral parameters that don't need anymore that much human labeling. Then we predict that hybrid light field and event systems might be very lucrative also. We just very briefly have looked on this. We assume that we are going to do development on those areas. Then further on, if we can get event analysis working, then the unsupervised classification systems further on the road. And then also unsupervised data fusion can be probably done if the classification is already unsupervised. depending on the inputs, external radars, external different wavelengths, this can be most probably all automated as a labeled clustered system for classification. And later on, multi-device unsupervised cooperation, this is more like we are dreaming about it, but we don't yet actually do any kind of active research on this. This means that if you have, for example, on the field 20 to 40 devices, then coordinating between them and actually having data fusion done between those kind of systems is somewhat complicated. So we do need to have some kind of vision how to do it. Most probably it can't be, at least on current technology level, totally automated, but at least some maybe semi-supervised systems can be done. Okay. What we have as a challenges, as a more interesting part, it was this is something like, what it all does actually do with actual photonics. When we come to actually the sensor part, we do have conventional imagers that are already something like 20 or 30 years old in a way. Even actually, the basic components are older, but let's say this is, the usable versions are something like 20 years old or so. We do have typically frame readouts. This means that frame parameters can't be easily tuned between the frame readouts. We have quite fixed frame readouts, readout speeds. This means that we can't just say, for example, say in the reading the first 10 pixels on one frame rate, then rising the frame rate very high, multiplying it to 10, and then reading the rest of the frame. This all limits in a way what we can capture. Comparatively, most good way to actually show this in context of targeting and specifically drone targeting. If you are having very fast movements and having very high resolution on the imager, the readout will be actually limited by the pixel count. So we can't expect something like 500 frames from the, let's say, 100 megapixel sensor. So it might be that if the target dynamics is very not matched to the sensor, either we have no image at all, or if we have low resolution sensor that is reading very fast, then we have something like 10 to 100 times of redundant frames that still need to be analyzed somehow. Okay, let's see what I missed. Yeah, there is additional motion blur, all those kind of things, but let's continue. From there, directly, I would say that very significant development is neuromorphic sensors, not actually that new anymore, but they are now quite cheap and widespread already. So this is for sure has been already EPIC's conference theme, I believe. And we have seen here prophecy representatives. So this is quite well covered. So I won't go very deeply into this, but I find very interesting for the neuromorphic sensors is very high dynamic range comparatively to the normal CMOSs or CCDs. We can easily have 140 decibels or better. Actually, if we are combining this with iris, then the dynamic range is just unbeatably better. Additionally, the latency, as we don't need to do the frame readout, but we have actually events on pixel level, then the latency is very low. We can have millisecond level readouts, and the timing is actually around 1 to 5 microsecond. So we have very high timing accuracy compared to the normal CCDs or CMOSs. Additionally, considering that the events themselves are sparse, the readout is actually very energy efficient computationally. if you only have just few pixels that are changing and we need to analyze them, we just move from watts or hundreds of watts to the milliwatt level of energy consumption. Just a little comment on the matching the neuromorphic sensors to the actual processing chain. Typically, we are using analogous neural networks that are not event-based or spike-based, but now way better match would be spike-based analysis system that is also, in a way, processing information sparsely. And we expect that spiking processing of neuromorphic sensors will actually gain additional magnitude, at least, of energy saving, and actually computational resources will be a magnitude cheaper to do this. Yeah, just a quick comment about the analysis solutions appearing. It used to be very problematic to train spiking neural networks, any kind of them, vanishing gradients or just runaway gradients. There were no good methods. Now we have publications that are showing that networks can be easily trained with pseudo gradients, and the methods are well published already. This is just a link to a very specific article that is commenting on this kind of processing, probably helpful for us also. Why to bother with neuromorphic and event sensors at all? We just run into the processing problem. Example, we are using 65 megapixel sensors, 10 cameras. This is something like 350 gigabytes unpacked data per second. This is somewhat serious to process this. And the actual useful data from the images for us is 1,000 or less. Sometimes even there is nothing, but we still need to process a full image, and this is quite pointless. And the illustrative video here. I hope those red dots are actually visible. This is the actual information that we need to process. But if we are reading, the 65 megapixel sensor, something like 30 to 60 times per second, it is not very wise, actually. This is just a short illustration. How much I have time? A few minutes more. Let me just run the video. Yeah, those are actually birds, and we need to find from those actually the drone. So the analysis points are running there. It will continue a little bit and show actually the tracks, so we can have the sparsity problem here also. We would like to have higher frame rates here. Here already you can see that the readout speed is not actually enough. We would like to have overlapping information, but we won't get from the high resolution sensors. So the neuromorphic sensors would greatly help here. Additional, the dynamic range. This is actually a drone picture against the sun. You can see that it's not very good, I would say. Even if it's this, I believe this optical system was F22 or so. So it's very hard to actually have reasonable dynamic range with normal sensors. This is not our video, but this illustrates very well the actual capability of neuromorphic sensors. This is specifically running the drone against the sun. And this is Guido Zarella video. This is public video. Very perfect illustration. The fun part is that he also captured insects flying over the sun. So you can see. So you can see that the capabilities of neuromorphic cameras are perfectly suitable, at least for our purpose, probably for many other things also. Pros and cons here. The only con actually for the neuromorphic cameras is not mature technology yet. The sensor resolutions are not high, time resolution is high, but it's going fast towards the smaller pixel size.
Thomas, you're really one of the ones to watch, and I really want to allow some time for questions because people really want to know more. I already said to many people, this Marduk company, when it comes to the defense sector, they've been very, very closely followed by the key companies in Europe. And we have a couple of questions for you, but first you should get the EPIC question. What can the members do for you, and what can you do for the EPIC members?
Apparently, I took a little bit too much time. The actual thing, what we like to do, would be to bring actual neural network processing before the sensor, not after it. Currently, we are doing it in silicon. We are just using the simulated models. The actual SHAMIR here, the screen SHAMIR, is a published document about diffraction layers before the actual sensing elements. So those kind of developments, actually diffractive micro-optics before the sensors probably is a way to do it, as it allows physical optical computing that is greatly simplifying the task. And any kind of cooperation on those areas, anybody who is doing this kind of stuff.
Fantastic. Diffractive micro-optics is really our strength right now. So any company that can help Murdoch on diffractive micro-optics, I will put them in touch with you. I have two questions in the room. The first one is coming from ST Microelectronics. Eric, what is in your mind?
Yes, thanks for your presentation. Quite interesting. New topic to me. I did not catch, but I think at the end of your presentation, you partly answered to my question. Which wavelengths are you considering for your optical imaging system? Is it visible?
All ranges, actually. We are also greatly hoping that the quantum dot sensors will extend the neuromorphic sensors spectral range. So this is development not yet happening, but it is very close. I believe the quantum dot sensors are developed on many companies, and by many parties. So we do think that pretty much the more spectral range we can cover, the higher probabilities to classify anything there is.
Okay.
So right now, quantum dot sensors, I would like to say hello to my friends from Levin, Qstone Dot, new company member of EQVIC, and QNA Technology from Wrocław in Poland. Quantum dot manufacturing in Europe is booming. So you're looking for cooperations there, lots of introduction to be done. Next question from FICON-Tech. Greg, what's in your mind?
Hi, Thomas. Thanks for your talk. I'm just curious, there are no birds in space, but there are perhaps applications for object space debris recognition and tracking. Seems to be a similar application.
Very close, actually. We do have already some contacts here in Tallinn University. We are in contact of space technology development departments are. And they, I believe, already did somewhat show interest for this, but I'm not actually the contact person, so I don't know very well what was actually talked there. But there was some kind of talk. It was probably actually tracking some microsatellites, but I don't know actually. So yeah, pretty much the same mathematical methods would actually work probably there also.
Okay. Thank you.
You are indeed one of the ones to watch here. I'm going to ask you a question, answer whatever you want. Are you looking for investment?
Yes and no. We do look for investment, but this is, how to say, it all depends on what areas and what conditions, as usual. Always can talk about the investments, but currently we are grant covered still, so we will see. But yeah, always, investment would be most useful if we have this investment as a, cooperation for technology development.
The company is being seen now as a defense company. This is the feeling that because you raise so much attention, people see you as a defense company. Do you see applications, business plan, roadmap be outside the defense, or do you want to be confident, comfortable as being seen as a defense company?
I would say that firstly, civilian market is way bigger, and we already target most of our developments as either primary or secondary, at least as a civilian market stuff. So any kind of, high precision targeting can be used in very many areas. For example, agriculture is currently what we are looking at. Having, how to say, having reduced pesticides use would be quite promising. So this is just one area that we are looking at. Yes, also civilian, it might be that the focus actually shifts from the defense. But currently, we were established on the defense ministry grant, so yeah, it all depends.
I really love this company. If any Epic member can help Mardo getting better, first because I'm a black metal fan, Swedish black metal fan, but second because I love what you do, it's out of this world. We need to help you. We need to help you get there. Thomas, thank you very, very much. Some of you are asking me to repeat the name of the quantum dot companies I mentioned are QNA Technology from Wrocław and Qstun dot from Leuven. I'm happy to make introductions to these companies. I will make an introduction to my friend. And now we go to Israel. We go to Elbit System. We go to my friend Alex, thank you very much for being with us. It is 1:20 here in Northvik at the station control. It is, I guess, 2:20 in Israel. The floor and the attention of everyone is yours, Alex.
Thank you very much. I hope that you can see my presentation.
It's not here yet, but I'm sure it's about to come. So you go to share screen, the green button. When you select it, then you can. Then you will be able to see the screens for you to choose which one you want to share. So at the bottom of the Zoom window, there is an arrow up called Share Screen, which is green. You press on it, and then it should give you some options, which screen to share.
Yeah, okay. Do you see it now, right now?
Not yet.
Not yet,
but okay. I'm sure you will manage. We have all the patience and all the technologies in photonics in front of you.
Yeah.
It's coming now. It's here. Yes, go to slide mode.
Okay.
How beautiful is the Hebrew font. I just love it. The floor and the attention of everyone is yours.
Good, thank you. Hello to everybody. I'm glad to be here, and I will try to describe in shortly what we are doing at Elbit Systems at ISTAR. ISTAR is standing for Intelligence, Surveillance, Tracking, Acquisition, and Reconnaissance. It sounds quite complex, but things that we deal with probably are a bit more complex. Sorry about that. But anyhow, ISTAR division is one of the division of Elbit Systems. As you can see, Elbit Systems has several divisions, 6 divisions, one in the USA. And we are the ISTAR division dealing with actually 3 fields of technology. We are dealing with electro-optics. We're dealing with UAS, with unmanned platforms, unmanned airborne platforms, and also platforms ready for use in the sea. And we are dealing with data, with intelligence and data for putting everything together. So just a few facts about our history. We were established in 1938, actually before the establishment of the State of Israel. And you can see how things were done then in 1938. Right now, we're quite in another state of being and working. And we have a large infrastructure in Israel, Rehovot. Actually, our company is a leading company in the field of electro-optics and systems in general, electro-optic system in general. And we won a few times the Israeli National Defense Award, actually 7 times. We make both systems in electro-optics fields, in certain electro-optics fields, but we also have comprehensive systems built with a lot of subparts in order to be able to gather intelligence. And altogether now, the UAS division joined what was once ELOP, the electro-optic divisions, and right now we're 2,700 employees altogether. when a major part of the employees here is are scientists and engineers. Some of them, quite many of them are PhDs, hold PhD degrees, and we also have very skillful technicians because it is really needed to have a lot of skillful technicians for performing our optical assemblies of lasers and other kind of systems. One of the systems that we're very proud of is the DIRCM's line of systems. One of them you can see here. Our systems are installed on big civilian airplanes. And for example, the one that you are seeing here, and actually all the airplanes, all the civilian airplanes of El Al, of the Israeli company, aircraft company, are defended by such anti-missile systems as the one you can see here. But we also have other kind of systems meant for helicopters, for transport platforms, tankers, or VIP airplanes, which can be smaller size. For performing our duties and make our systems, we have to actually to have a multidisciplinary kind of engineering procedures. So we work with lasers, with infrared sensors, and what you see here is a vacuum chamber meant to test cameras that are sent to the space. We have several such cameras that are actually activating in space, about 8 cameras that are working right now. And such a chamber as the one that you see here allow us to test the space cameras through different stress, environmental stress, and make sure that it works properly. Another thing that we're specialized in is the optical coatings, and we also manufacture optics, but we are also we have a high expertise in optical coatings, and I'll talk a bit about it afterwards. And there are other things that we can have to put together, the control and navigation, and also advanced thermal systems and signal processing, mechanics engineering, material engineering, and so on. What you can see here is some of our manufacturing capabilities. Actually, we have, especially when I'm talking about the electro-optical division, we have internal manufacturing capabilities in the optical field. We talked a bit about it, and you can see here a lot of different optical coatings. We have also a mechanical and internal mechanical manufacturing site. We produce in our site, first of all, the prototypes, and afterwards we work with other companies outside in order to produce the other products after the prototypes are already used. We also have an electronics and assembly and manufacturing site in Elop, and we also have many assembly units dealing with lasers, thermal equipment, we're especially we have a specific specialty in making fiber lasers. What you can see here is our trial to work throughout automation. Automation is an issue that we pay great attention to it, especially during the last 1 or 2 years. We try to automate some of our manufacturing, especially the processes that are highly specialized, in order to maybe lower a bit the degree of expertise needed to make such manufacturing, and also to speed the rate of products manufacturing and make it more efficient. We are putting a lot of effort in this trial to automate our products, and we work both internally and also externally. We try to make as much as possible collaboration with other companies, and this is something that I would like to maybe to try to share with others that are attending to this conference right now, and maybe to have several collaborations about it afterwards. What you see on the right side is on an automated cleaning process. The cleaning processes are very important to us, because when working with lasers, as you know, the degree of cleanness have to be very high in order to not to make damage to our optical parts. Okay, if we talk about some of our solutions, systems and solutions, we mentioned the DIRCM, but we are also active in the naval field. We have some naval systems, autonomous naval systems that combined with optical systems can perform the task properly. And we have a lot of work in the thermal imaging and homeland security fields, using both thermal products for short ranges and for long ranges also, combined with laser technology. You can see here one of the examples of one of our laser designator installed on an airplane, able to work at quite long ranges and perform its duties as required. Another field that I mentioned is the image processing and data exploitation that we perform in order to put together the optical systems and the UAV solutions that we have. And here you can see all kind of target recognition, motion detection, and change detection that are allowed based on our electro-optical systems, together with deep learning systems that make it possible to find whatever we are looking for. We talked already about the DIRCM systems, so I won't say anything about it. We have also a lot of several payloads on airborne payloads that are very compact and long range, and also multispectral. We're specialized in the multispectral technologies in order to perform results for our customers. And last but not least, the head-up displays. We have several head-up displays for civilian platforms and also for military platforms. And we also use our advanced laser technologies in order to make such displays. Okay, I think that in short, I try to make it in time.
You did. Look at that.
So,
1:35.
yeah.
Exactly in time. That's what I like about Elbit. Precision. Exactly on time. There's a lot of things that we need to discuss, Alex. The first one is the epic question. 572 companies here. What can they do for you? What can you do for them?
As I said, one of the things that we are most interested during the last 2 years is the automation, especially automation that is relevant to manufacturing, to optical manufacturing. It's not an easy thing to do because we have different products and we're looking for something that is on one side, on one hand, generic, and on the other hand, they can be used for specific and quite accurate processes. So we are looking to make maybe some joint efforts with other companies to look for such opportunities. We are also interested in advanced laser systems, maybe specifically in QCS, quantum cascade lasers, that may allow us to make some more compact systems. And those are just two of the issues that might interest us for joint collaboration, maybe under Horizon 2020 or other platforms that's also good for us.
Of course, and it is great because those two challenges can be very well addressed. Automation for manufacturing, of course, you do require active alignment. So we have FICON-Tech in the room. There's other companies also, Aixentech, Tehema. We are very strong in EPIC on that. I don't know, Greg, you want to say something? He's looking for a partnership on automation for manufacturing. I guess that you're interested in follow-up. And then we also have very key companies in the field of quantum cascade lasers there. On that, I have a question. When it comes to QCLs, of course, we have NanoPlus and we have Hamamatsu, and I really love Alplacer in France and Thor Labs. We had the best technology on QCLs. Are you worried about the price of the QCL, or is it something that doesn't worry you in this sector?
Actually, we're looking for QCS in order to try to keep the cost lower, and usually our systems are big systems with a lot of sub-assemblies. So sometimes the QCS are not a major factor in the cost of the whole product. But of course, we prefer cheaper QCS. But we also we're also looking for powerful quantum cascade lasers. So we have to pick the right choice for
it's important for the companies here. Are you okay with individual bars, or do you need a single high power for quantum cascade laser?
Actually, we need both, because the single emitter is important, but also to put several QCS together might be also of some importance when talking about high power or high power density. So both are things that we are interested in.
Another one, when I see your beautiful images from the sky and I see your deep learning algorithms, is interesting. Are you interested also in combining it with hyperspectral imaging for detection of any kind of chemicals or any kind of gases, or is that out of the scope?
Yes, of course. We're quite interested in hyperspectral imaging because we are looking for all kinds of targets and for all kinds of ranges. Sometimes some time ago, we were also trying to act in the field of precise agriculture, for example, although it's not a military or a defense issue, but we try to make some work in this field. So all kinds of ranges are of interest for us, of course.
For you, Alex, and also for your speaker, Thomas, on the 10th of July, I organize an online meeting on precision horticulture and agriculture. So if you want to join, you are more than welcome. Alex, once again, thank you very much. It is so great to have Elbit in EPIC. You've been such an opportunity opener for many of our members. On behalf of all of them, thank you very much. And we go to...
Thank you. It's great to be here. Thank you.
It is a crazy day because now we go to an amazing company, one of the companies everybody looks up to. We go to Coherent. We go to Finland. Jarno, thank you very much for joining us from Finland today. Here it is 1:41 right now. We are exactly on time. I know the way that you like it. The floor and the attention of everyone is yours. I have you muted right now. Let me unmute you. Can you unmute yourself so we can hear you? Yes, the floor is yours.
Thank you very much for the opportunity to come here and join this great meeting and explain about our products and processes. So my name is Jarno Kangastupa and I'm a managing director in Coherent Finland, and I will talk about some of the challenges in the e-mobility joining processes. So I will talk about a little bit about the company. And then the ARM fiber laser portfolio and what is ARM fiber laser, and then some of the challenges in the e-mobility materials joining and some of the solutions, and then I have a short summary at the end. So Coherent is an American-based company founded 1966, so one of the oldest global laser companies. The turnover in fiscal year 19 was 1.4 billion. We have 5,200 employees, and we are basically providing various kinds of photonic solutions for our customers globally. Optical components, laser sources, laser subsystems, which means laser plus optics, and certain type of laser machines for some of the industries. The core markets where we operate are microelectronics and displays, different materials processing markets, OEM components and instrumentation, and then scientific and some government contractor type of projects. In addition to the fiber laser technologies, in Coherent we have lots of different laser technologies. So this is very nice for our customers because when they select one of the technologies for certain application, they can very effectively work with us and expand their requirements and needs for other technologies, and then we can cover all of the laser needs that they have. So you can see the list from the carbon monoxide laser all the way to the different type of solid state lasers and excimer lasers, and then finally some tools and measurement devices, and then ultra-short pulsed lasers. So we are a global company. So for the global customers, this is a very important point that we can serve them in 50 different locations with our sales and service organization. We have 27 factories or manufacturing sites globally. And then also in order to keep all the production lines running all the time, we can provide in very timely manner spare parts as needed from 18 warehouses, which are strategically situated in the industrial areas. And then we have also 17 application centers where we can develop different type of laser processes. We can verify the customer needs, that we can actually do it. We can then have a shorter or longer projects together with customer and check the process windows and what it means to make mass production finally, and get the parameters right and really make the proof that we can go to the production with the laser processes. So then I have something, a few words about the ARM fiber laser portfolio. So as you can see, there are 5 different laser cabinets for this product family. And then I think it's important to a little bit describe what is the adjustable ring mode laser. So the ARM acronym comes from these 3 words, adjustable ring mode. So it means that we have 2 1-micron wavelength beams in one process cable. So we have let's say conventional high brightness center beam coming from the center of the fiber, and then that is surrounded coaxially with the ring mode beam. And in our design, this is a really important point, that the center beam and the ring beam, they are truly independent from each other. So we can make any kinds of power ramps or modulations or CW settings for these 2 beams. So the specification basically is from CW to 5 kilohertz modulation. Also, we can dynamically control the both beams during the process and have a very wide power tuning range. So we can go to very low powers and then of course to the maximum rated power. And this is really important point in the beginning and end of the welding processes. Also, we have developed state-of-the-art back reflection resistance for our lasers. So it means that we can make a 90-degree angle perpendicular welding for the workpieces, and there are no needs to tilt the optics to avoid the back reflection, because we have capabilities to handle that. When we combine these laser sources together with our accumulated application know-how, then we can achieve welding processes with reduced spattering during the welding. And after welding, when we check the weld seams, there are no porosities, and also we can very well control the penetration depth. Also, surface quality can meet the most stringent requirements. And then because of these 2 beams and the combination of them, we can have very wide process windows, which is of course important for the mass production environment. So in the right-hand side, there are some examples how to use the laser basically. So like I said, that the laser is, these laser beams these 2 beams are totally independent from each other. So you can do it so that you can make a preheating with the ring mode. So you can very smoothly ramp up the ring mode and wait. And then when the workpiece is preconditioned properly, you can launch the center beam. Or you can make it so that you can ramp up the ring beam and keep it then stable in the CW mode, and then you can modulate the center beam. Let's say you need to make spot welds and you move the beam of the optics, and you can make in the several kilohertz range this modulation. And this type of things are possible with this laser. So then I have the image in the bottom right, which is from the high-speed video. When we apply only the ring mode, so you can see that how beautifully the steel is melting in the ring shape when we are smoothly ramping up the ring power only. So then there are of course many kinds of applications, and we have found out that we need to have not only one type of arm laser, but kind of a portfolio of different optical configurations for different applications. So we have very high intensity center beam with beam parameter product of 0.6 milliradian, and then in case of these connectorized arm lasers, we have 5 milliradian. And we can also have detachable output cables by help of fiber couplers, or even multiple outputs with fiber switches. Then let's go to the e-mobility side. So there are lots of challenges in this space, and there are lots of developments happening all the time. The main applications that we are looking into are related to the electric powertrain, power control modules, which are controlling charging and discharging of batteries. Then, of course, various types of high current devices, also inside of the battery cell and battery cell sealing, we are providing lasers, and then battery pack welding. And because these are automotive applications, it's really important that all the weld seams are withstanding thermal expansions and the vibrations over the lifetime of the car. So first, typical materials are aluminum and copper in almost all of these applications. And when we look the aluminum and copper welding, so people typically look to the absorption curves, and they say that, okay, 1 micron wavelength is not optimal for these materials, and they start to think something else. But then when they think a little bit more, they remember that these curves are measured in the room temperature. And this is really important point, because now when we involve arm laser, it means that we can make a preheating with the ring and then elevate the temperature of the workpiece. And what this means is that this increase is of course the temperature, and then the absorptivity for 1 micron wavelength increases in a dynamic way. And then when we continue this preheating, we can get very good absorption finally for the center beam, and very stable and high efficiency energy in coupling to the workpiece. And then, of course, depending on the process, but in those processes where we open the keyhole, then we also get multiple reflections inside of the keyhole. And then when we consider molten aluminum or copper with the keyhole, suddenly the wavelength is not an issue anymore. So this is the theory, and this is what we have been working on. And now I can show you some real life applications. So first thing here is the aluminum. So in the automotive space where we have batteries, of course, the batteries themselves contain lithium, and we have to make a hermetical seal, and this seal must withstand the different vibrations, even accidents, if those happens to the cars. And in the past, these weldings have been made with heat conduction welding, but now in order to reach enough mechanical strength, we need to make a keyhole welding, and this we can do. And as you could see in the video, this is spatter-free, and the right-hand side cross-section shows you very nice cross-section with good beam seam quality and no porosity inside. So then, if you look the copper welding, so first we look the conventional fiber laser. What happens? So we will get at the 1 micron wavelength discontinuous seam and lots of spattering coming. And when we compare this to the arm fiber laser, you can see very nice weld seam, and the spattering is virtually non-existent. And then this we can then utilize in different copper welding processes. So here we have an example of the electric motor stator hairpin welding. This is real time, only 0.1 second, so 100 milliseconds. But now we can make this welding without spattering, so that we first ramp up the ring power, and we have analyzed with the high-speed videos when it's the time to launch the center power, and then we can do it, and then finally we can get really nice quality welds without porosity inside. And when the resolidification happens, we can see also very nice surface quality. So this is the copper, and then also we have applied this technology for copper foil stacks in the battery applications. So even 100 copper foils, only 8 micron thickness each, and by this preheating center beam high brightness combination, we can achieve the good welding result. So now there are many kinds of applications, but in the automotive applications, it's always important to have very high quality welds. So and very clean processes. So no porosity, no voids. These are in our focus. Good surface quality, and we can optimize the heat input so that when we are welding also dissimilar materials together, we don't heat too much, because that could cause excessive intermetallic growth between the materials, and that of course would reduce the electrical conductivity and mechanical strength. So you can see also here high-speed video what happens when we make this weld, and also this is very beautiful welding process in that sense that there are no spattering coming. welding aluminum to copper, where we have very different melting temperatures. We can utilize this high brightness arm for welding only 200 micron thickness aluminum foil on very thick copper. And I think this is very unique thing now, which many people need for their processes. And as you can see in the high-speed video, there are no voids or anything like that in the aluminum foil. Even it's weld on top of the much higher melting temperature copper. And here I have finally some examples. Right-hand side, we have exactly this part where we have copper on the bottom and then the aluminum foil on the top, and then the cross-section of it in the rightmost image. So we can see that we have 200 micron thickness foil, which has penetrated roughly 200 micron into the copper. And then different types of teeth joints, aluminum to nickel-plated copper or copper to nickel-plated copper, and just regular pure copper to aluminum welding in the top left corner image. So basically, what I'm saying is that for our customers, that if they choose Coherent as their photonics partner, we can operate globally together with them. We can recommend ARM laser for these processes, because then we know that we can most likely achieve even the most stringent requirements for the welding processes. Sometimes also we have been able to make welding seams which people have thought that they are impossible with this technology. So I will not go into the details of the product, but you can find them from the coherent.com, and then of course you are welcome to send me questions by email or ask now. So thank you very much for your attention.
Thank you very much, Jarno. Fantastic. From Tampere, and I can see the trees behind you and the birds. Yeah. In the beginning, I thought it was like a picture, but it's not. It's true. Yeah. You are outside. Wow.
Yes. Yeah, we are because of coronavirus. We are working remotely, and I think this is. In the short Finland summertime, this is a nice place to be.
You have a beautiful home office. I can tell you that. I have 572 companies here from EPIC, yes. And they want to do business with you. So what can you do for them, and what can they do for you? The EPIC question.
Yeah, so of course we can discuss with them what are their needs in the many kinds of laser needs that they may have. But of course now today I think that we would like to discuss copper welding, aluminum welding, or dissimilar materials welding, and anything related into the e-mobility applications. Of course, we don't want to limit this. If there are other interesting people are interested for the other things also, I think we can of course discuss basically any, because the lasers are applicable for titanium welding and the brass welding and steel, zinc coated steel welding, where we have some nice IP also. So yeah.
Two things that pop into my head. The first one is when you are talking about the ARM laser for the aluminum and copper welding, you talk about step 3 and you talk about preheating by the rim beam.
Yes.
With what accuracy do you need to monitor the temperature?
What we typically do is that we don't monitor the temperature so much, but we monitor the surface of the workpiece material with the high-speed video equipment when we develop the processes, and when we can start to see alteration in the surface. This is typically the indication that we are very close to the melting point. And at that time, we usually launch the center beam and make the welding process. But the important point is to smoothly ramp up the power and not suddenly explode it.
I've been doing this already for 11 hours. 2 hours ago, I had an amazing presentation from GESTAMP. And I asked him, what is your challenge? And Miguel Angel told me, I want to put fibers with steel. Miguel Angel, was that right? Is that the challenge for Coherent that you could have?
Yes, for sure. I mean, we are working already with them in the States. We have their equipment installed, and we are really working really nice together. And yeah, that's one of the challenges: fiber to fiber, fiber to steel. Yeah. And all these thin aluminums and the similar joinings that he was mentioning, he's absolutely right. Yeah, for sure.
Are you noticing, Jarno, that trend in the market? More companies, more customers coming with exotic new materials and wanting a perfect weld for them that is reliable, durable?
Yes. So we have the miniaturization trend in many components. People want to make smaller and smaller things, and also lightweighting trend in the automotive industry. So thinner and thinner steels and high strength steels and these kind of things. And the material technologies is pushing things forwards, amazing speed. And I think that we are working very hard in Tampere and in Coherent to keep up with these trends and provide laser solutions for the whole market.
Jarno, thank you very, very much. We are in Tampere now, so we go into the train. We take 1 hour train south and we go to Espoo. Beautiful area there. And we have my friend Timo Aalto from Espoo, from VTT, talking to us about how all these EPIC members can help VTT in the silicon photonics sector being even stronger than they already are, and they are setting the pace in many of the aspects of silicon photonics. Timo, you are a very good friend of mine. We know each other for so long. Thank you very much for accepting joining me in this completely crazy adventure. The floor and the attention of everyone is yours. It's 2 o'clock over here. It's, I guess, 1 hour more where you are at 3 o'clock in Finland, correct? The floor is yours. I think we have you still muted. Possible? Yes, now we can hear you. Yes.
Yeah. So I'm not sure if you are seeing all the kind of videos here as well. So should I kind of take this?
Right now we can see your slides crystal clear as you were next to me.
All right. So I'm going to talk about kind of silicon photonics, and this is a bit kind of going further into the integration that was discussed in the previous presentation about making things smaller. So we are talking about making optical waveguide circuits that are even much smaller, the size of small silicon chips. So so this is about kind of ultra broadband low loss silicon photonics for communication and sensing. So first of all, the different applications for this technology, they are shown here. So there's the healthcare, there's the autonomous systems like LiDARs, communication, computing, industrial sensors, military, aerospace. Actually, you can imagine that almost any optical system that is now made of discrete components, you can integrate on a chip, almost, not everything. And the benefit is there to get these things smaller, less expensive, more power efficient, and sometimes also add the performance that you cannot otherwise achieve. So our technology platform is a bit different from most others that use silicon photonics. So what we are having here is called 3-micron SOI platform, so silicon insulator. So let me briefly kind of explain that. So we have a silicon wafer. On top of that, we have a 3-micron thick buried oxide layer, so glass, silicon dioxide, and then a 3-micron thick layer of silicon. And that's where we pattern these optical waveguide circuits. And we have 2 waveguide types, and the combination of those is what makes this platform quite unique. So we have single mode RIB waveguides. We can make with those single mode photonic integrated circuits. On the other hand, we also have these multi-mode strip waveguides, which have the cross section like a rectangular cross section, and that allows us to make extremely compact circuits. And what is crucial is that we can couple light between these 2 types of waveguides without launching higher order modes. So the system works single moded even if there are some multi-mode sections there. Then we have spot size converters, and we can turn the light extremely in a dense footprint, left and right, with this kind of Euler bends. And then also alternatively, we can use these TIR mirrors. And that kind of both of them allow to have this kind of few micron kind of turning bending radius for the optical circuits. On top of this, we have a thin layer of oxide, and to get light in and out, we can use this kind of horizontal coupling with the anti-reflection coated edged facets of the waveguides. And then we can also get the light in and out vertically from these up-reflecting TIR mirrors, which are also coated with this anti-reflection coating. So this gives a kind of a variability. You can choose kind of where to get the light in and out. Sometimes we also leave a very thin layer of silicon underneath those waveguides or around them, and that allows to make a kind of phase modulators. So it could be thermo-optical or kind of semiconductor diode-based devices, so we can kind of tune the light, make modulators and tuning elements. And then the last thing is that we have this germanium photodiodes, and they are very fast, and they can be monolithically integrated, also grown on this thin silicon pedestal. Then a little bit of kind of technology and kind of physics, so bear with me. So these are two examples of optical waveguides, conventional single mode waveguides, not the ones that I showed. So there's a standard single mode fiber on the left and a submicron thick, 220 nanometer thick silicon waveguide on the right with the two polarizations. This shows what happens to the fundamental mode when it propagates along these waveguides when you change the wavelength. So as a function of wavelength, you see that the kind of mode field is expanding out from the core, and the kind of confinement of light inside the core is kind of reducing when you change the wavelength, increase the wavelength especially. And if you would go to the other direction, you would kind of make a wavelength shorter, so it becomes multimoded. So you have to balance somewhere between the kind of multimode operation and the kind of high losses and large bending radius to only work in this kind of a green area there in the wavelength scale that is relatively narrow single mode region where these waveguides work. This applies to all the normal single mode waveguides. You can see the same behavior in this submicron silicon waveguides on the right, but there's the additional feature of the polarization dependency, which is very strong when you have a kind of a high refractive index contrast between the silicon core and the oxide cladding around it. So it makes it very polarization dependent. Practically means that these circuits are working typically with one polarization only, at least the functional parts of those. So what we do is something quite different. So we use micron scale waveguides. So you see there these two types of waveguides that I showed, these rib waveguides and strip waveguides, and they are 3 micron thick. And what you see there is that the mode is almost fully confined inside the silicon. So it's totally different from this conventional single mode waveguides. And the one on the left is actually single moded. So the higher the modes kind of escape through this slab of silicon. The one on the right is this kind of multi-mode waveguide where we keep the light in the fundamental mode. But what you see is kind of a remarkably wide wavelength range covering kind of a microns of wavelength, and hardly anything happens as a function of wavelength. And there's hardly any polarization dependency that you can actually see. So the benefit of that is that that you can have a ultra broadband single mode operation with these rib waveguides from, like say, 1.2 to 4 micron wavelength. You can have ultra high mode confinement. So this leads to very low propagation losses because that comes from the kind of cross section, kind of the edges of the waveguides. So 0.1 dB per centimeter, which is extremely low loss for a silicon waveguide. And this is the normal waveguide without any tricks. So it's kind of all the straight ones, and also the bent waveguide circuits have this loss. You can have this polarization independent operation, like I said, even totally zero birefringence operation, and reduced sensitivity to fabrication tolerances. And this is because if you change a little bit the dimensions, it's the same thing as changing the wavelength. So basically nothing happens, all the light remains confined inside the silicon. There is this very dense integration that you also achieve. So like I showed with the bends and the mirrors, you can have like a few micron bending radius. We have pushed it down to 1 micron, but you can do it with a few tens of microns to make it very, very robust. And that we can make fancy optical functions in a very small footprint. And finally, there is this large mode area that you get with these thicker waveguides, and that allows you to kind of couple light efficiently and easily into these waveguides from the end facets horizontally or vertically with these up-reflecting mirrors. So just a 0.5 dB loss with a lensed fiber. And this is broadband, so you can get this for both polarizations over a very wide wavelength range for kind of hundreds of nanometers wavelength. And you can also, because of the large mode area, you can kind of handle large optical powers. Then some of the basic building blocks in these waveguide circuits are the wavelength demultiplexers and filters. So we have different ones on the types. I'm not sure if you are seeing the ones on the right because I see some kind of video images from the others, but I hope that you are seeing it. So there is different wavelength multiplexers and filters that can be done, and they have their own pros and cons, but in general, they are very low loss. They are very broadband operation. They can be made polarization independent, and the kind of here is an example of a 40-channel wavelength multiplexer or demultiplexer with kind of few dB kind of a maximum loss only and over 500 nanometer bandwidth. So you can actually couple use these for covering both the O band and the C band, for example, in optical communication, or make spectroscopy for the whole near infrared region, even extending to mid infrared if you like. Then one example of just a very recent paper that we published now today with the Boston University. So this is showing kind of ring resonators. We didn't actually use these in the past. They take a lot of space, not like a micro rings. And what we did was to demonstrate normal rib waveguide rings, very large ones, with a very high Q, so millions of Q, so proving the kind of really low loss, and you can get narrow line widths of those resonator peaks. And then we also made these racetrack resonators, which combine rib waveguides and strip waveguides, and kind of make a filter banks, and they can have then very, very small footprint, also very dense integration, and with the multi-million Q values. So these are quite recent and I would say excellent results in kind of showing kind of advanced resonators with very low losses and small footprint, at least for the racetrack resonators. Then we used to have this challenge in this kind of micron scale waveguides that high-speed devices are more difficult to do there than in the small submicron waveguides. But last year we did a kind of a breakthrough there with the germanium photodetectors. So we made photodetectors that reached up to 40 gigahertz. So these have the germanium grown on silicon. They are monolithic. They basically collect all the light. There is very little light lost anywhere, and the bandwidth is up to 40 gigahertz with the kind of 3 dB bandwidth. There is dark current of 5 microamps. That's a bit limitation for some really high sensitivity applications. So this is not as good as some kind of discrete photodiodes, but still quite okay for these for high-speed optical communication applications. What is interesting is that if we reduce this bias voltage of the very same photodetector, so we can convert that into a fairly efficient monitor photodiode or kind of a sensor photodiode. So then the dark current drops to about 10 nanoamps, and you can use it for many sensing applications. Of course, the speed also drops, but it can still be around in a kind of a gigahertz range, but not in the tens of gigahertz range. So this at least makes the receivers also very fast on this platform. Then if you want to have something that cannot be monolithically done, like even faster modulators or photodetectors or lasers, since we cannot really kind of do monolithic lasers on silicon at the moment. So then we can do the hybrid integration. And this shows some examples and principles of that. So we have done a lot of those devices. And there is kind of conventional flip chip bonding of compound semiconductor light sources and modulators. We typically use the kind of machine vision and flip chip bonding with the solder pumps, and you can have like a passive vertical alignment like shown on the right. And then we have worked a lot with the German VCSEL laser company WAVELENGTH, and demonstrated also the kind of coupling of these VCSELs light directly into the silicon waveguides with these up-reflecting mirrors that are shown there. And talking about that, there's kind of one project, and it's kind of a target what we are having now. There's also some of the other project partners shown here. So this is the passion project, and the idea is that we, in one of these kind of silicon chips that you see there on the right, we would integrate 40 of those VCSELs. So we have already proven the kind of the chips are ready. The VCSELs have been integrated, kind of demonstrated separately. Some of the VCSELs have been integrated, but not all of them yet. But once we get everything integrated here, so this chip should then support like a 40 times 50 gigabit per second. So that's total 2 terabit per second data coming out of this one silicon chip. So this is quite exciting for this project that is led by the Polymi in Milan. And then about our facility, so we have the biggest kind of clean room in the research clean room in the Northern Europe. It's an IC clean, but also some other backend processes, I-line stepper lithography, and wafer size 150 millimeters. And we offer from there kind of the multi-project wafer runs, dedicated runs, and also contract manufacturing for small and medium volumes, and some additional assembly and packaging services. And here are the kind of MPW runs, multi-project wafer runs, that are the way to kind of share the costs of these runs. There's 2 of them per year, and there are different process modules to choose from. And an interesting thing that we really try to do now is to have this also brokered by the Europractice IC service. So there's the CMP company in France, which will hopefully we have kind of preliminary agreed that we would kind of start this late this year to kind of get them also to kind of do the brokering. So you can also order the services from there. And there are design kits already available and PDKs, especially in Synopsys, but also we are growing something in IPGIS. And something for the future, just before I finish. There's a bit of a roadmap for this technology platform. So we want to reduce the propagation loss even further. So we are now already extremely low loss, but we want to make it even lower loss. So 0.01 dB per centimeter by hydrogen annealing. Very promising results have already been gotten. They want to develop also these high-speed modulators. So kind of reaching tens of gigabit per second, maybe potentially with Plasmonics, we could go to kind of hundreds of gigabit per second. So we are working on that as well. And then on-chip circulators and isolators. So we there use the silicon itself as a Faraday rotator, and we can make isolators, and preliminary demos have been done already. And then we want to include in the MPW services this kind of wafer level testing, hybrid integration, fiber array attachment as kind of standard services there, and some wafer level packaging. So in conclusion, I think we have in this platform, we have the low losses in small footprint, policy independency, ultra broadband operation, monolithic and hybrid integration of the active components, these multi-project wafer runs, dedicated runs with the process design kits. And this technology can be used in many applications. So it's just kind of, I leave it up to you to figure out where this could be used. So we have some of our application ideas. I would really want to hear from you, like where you could think about applying this technology in the future. And as it is a group effort, of course, so I list some of the funding organizations, some of the project partners, not everybody, but at the most important ones at least for this work listed here. So thank you all, and thank you, Jose and Carlos, for organizing this amazing event.
We are totally crazy. You have to be totally crazy to organize something like this, and we managed, and Carlos has been on the back office training everyone to deliver these fantastic presentations. And applause to Carlos and applause to Timo. That was really fantastic presentation. You get the epic question, of course. 572 companies here. What can they do for you? What can you do for them?
Okay, I think I partly already answered that question at my final remark. So we are the foundry, we are the fab, we design the components, we can design the masks, but we are not the system experts. And this is something we would like to mostly leave for the others. So what I'm looking for is the companies and the partners to kind of look at like where to apply integrated optics, where to take the benefit of these low loss, polarization independent, ultra broadband devices and start kind of designing products and systems. We are not a product house. We do the prototyping. We can offer the contract manufacturing. I'm looking for the others to actually sell the products based on this technology.
Fantastic. So we have questions for you. The first one is coming from Evana Technologies. Edigius, what's on your mind?
Hello. I just get some questions for you. Do you working with waveguide formation inside silicon as changing properties of silicon to form directly by direct writing waveguide inside silicon? It means that to manage the wavelengths, light inside silicon, not by lithography, but by direct laser writing.
No, so the short answer is no, we don't do that ourselves. I think one of the benefits in this platform is that we can have this kind of really high index contrast. So the core has a huge index contrast with respect to the cladding, allows to make very dense integration. If you would do the direct writing, you can typically only achieve like a very small index contrast. So maybe that could be some like additional feature for some particular function on the platform. But I think that that approach is not suitable for doing the kind of ultra dense integration that we are doing, where we really, I mean, the policy wavelength independency is depending on that there is a really sharp, strong index contrast between the core and the cladding.
But in fact, here it's much cheaper and much easier to make some prototyping for some kind of applications.
For some applications, definitely true. But at the end of the day, what we are trying to do here is to have a perfect waveguide with ultra low losses. And I want to ask Timo, before the time runs out, because you said, let us dream about applications on my platform, but you showed me a roadmap 0.001 dBs per centimeter. You want to go to very low losses. That's because you have an application in mind related to delay lines. What application do you have in mind for that?
Well, there are two application areas. One is microwave photonics, including all the nonlinear optics there as kind of a part of that. So maybe three, like a microwave photonics, where you typically want to kind of have long delay lines and low loss long delay lines. And the other thing is really the nonlinear optics, where also you think like a long interaction length between the different wavelengths and pulses. That would be another one. And then the last one could be these inertial sensors like gyroscopes. I've seen a lot of work in the integrated optic gyroscopes, but nothing has really been able to compete with the conventional gyroscope, simply because the losses are too high. So you would have to have a kind of tenfold kind of reduction in the propagation losses to do that. And exactly that's what we are aiming to do.
Low losses, visible in mid-infrared. You integrated detectors, you integrated modulators. You can actually do very high efficient planar coupling of optical fiber. You have all the ingredients. And my friend from ST Microelectronics, Eric, needs to talk to you afterwards. Thank you very much, Timo. Do me a favor. Right now, all of us, we walk to the harbor and we take the ferry to Dansk. And there we rent a car and we drive to Warsaw, my favorite city in Europe. Dziękuję bardzo, Adam, for being here with us. Vitami, the floor and the attention of everyone goes to Vigo, goes to you.
Hello, everybody. It's great to be at the event. So photonics is the future that we are, and also it's our today superhero, photonics superhero, with promoting all of us. So it's great to be here. I'd like to show the screen and show you what we are doing at Vigo. So hopefully I will do it right now. Can you see the full screen?
We can see it very well. The floor is yours.
Great. So we had a wonderful presentation from Finland about integrated circuits, and we are on the detector side of the mid-IR. So at Vigo, we are since late 60s, we are trying to develop best possible mid-infrared uncooled detector. So that was a goal, and this is still a goal of my father, Joseph Piotrowski, professor of physics. He founded the company in 1987, but he actually created the idea of uncooled detector in 1969. So yesterday we had the Polish Father's Day, and for a whole day I was talking about detectors, about new ways to integrate them with optics and electronics. And then at 11 p.m. I reminded that I need to talk with my father to give him all the best for the Father's Day. So I'm proud to continue his work on infrared detectors. So at Vigo, we are now 150 people, all of them concentrated on the right areas. At Vigo, we are vertically integrated manufacturers, starting from epi wafers, going to electronics and optics. So, so that's kind of a tough job for me to manage this kind of team with lots of expertise, with lots of hands-on experience that we have to continue to develop. And it's wonderful that mid-infrared detectors have so many applications, and we work through it. The Vigo right now is a public company, so I'm open to speak about our revenues. We are continuously growing. So I was installing a MOCVD system for first mature architecture technology in 2004, and then everything started to grow at Vigo with our applications, industrial customers, also space applications, detectors for Mars Science Laboratory, for Curiosity rover. It was great adventures, and now we are scaling up towards new areas, biosensors, air quality monitoring. So our sales in Poland is quite small. We're mostly in Europe, throughout Europe, France, Italy, Germany, Great Britain. That's our main market. But US is also, it was always a very important partner for us, and now Asia is growing. So it's a great time to manage the company. Right now at Vigo, we are starting with epitaxial growth. We have two MOCVD reactor and one MDE for mercury cadmium telluride and 3,5 materials. So quite a large range of substrates, materials. Then we process the materials by ourselves. So the photolithography, depositions, ICP, wet etching is all done with very tough material, mercury cadmium telluride or very thick 3,5 semiconductor for detectors. That's really unique technologies. And then we integrate detectors with optics. We have our own technology to make those tiny lenses monolithically integrated, so they polished on top of the substrate, so no glue between lens and the detector. And then we have to protect those devices with hermetization and shield them against all kinds of electromagnetic interferences and integrate with very fast electronics. So some of our detectors are working up to 5 gigahertz, and we have many continuous customers that are working on 1 gigahertz. So that's really interesting part of the technology. And now for the break, I will show you some movie. Hopefully it will run. So we are now inside of the MOCVD reactor, multi-wafer system. We can grow even on 6-inch wafers, 8 6-inch wafers that we could use to make hundreds of thousands of devices every day. So in here, it's a 3,5 material system. So we can control all the flows. We design the structure for ourselves, but I will tell you later on that now we are opening a new area to offer the 80 wafers to everybody. That was also my job on the beginning in my career to control the quality of wafers, to grow them, to design how to make those multi-layer structures and make them pure and easy to design for our theoretical physical engineers that are designing different structures. And now with this totally new extron system, we're also entering new areas like demonstrating VCSELs. And this is just a demonstration. And because actually what we are doing with this new reactor is that we are offering wafer services. So it's not just material for Vigo itself, but we are open to take any structure, and we can grow it on gallium arsenide, on gallium antimonide, or indium phosphide to create laser structures, detectors, and that's really something that opens a new area for collaboration. This the system was just installed in September last year, and since then we already demonstrated several structures for single photon emission, or for the VCSELs, or for indium gallium arsenide detectors. So it's really going quite well as a totally new system, but the team is quite very experienced. We have a main engineer there that has more than 30 years of experience with MOCVD. He was designing MOCVDs in the 80s, so a really great team and totally a new product, wafers on large scale of production. But for Vigo, infrared detectors was usually a core technology. So we can offer devices that could cover all the range from 1.5 microns up to 15 microns. So of course, our unique capabilities are in the longer wavelengths, where we can do gigahertz uncooled detectors that could work in the 10.6 micron range or even 15 micron range. That could be used for FTIRs. They are perfectly matched with the quantum cascade lasers, where I remember first time when quantum cascade laser became visible on the market, and it was perfectly matched component for us. Same size, uncooled, easy to use, and now I'm hoping that together with quantum cascade laser manufacturers, we can go even further to integrate those components, use the VTT or others platform for integrated photonics, and create a mid-IR integrated systems. In the beginning, we could do it as a hardware components, but in the end, probably monolithical components. So I'm very open to discuss about this kind of areas for collaboration with everybody. It's really amazing how much you can do with all those new components that are coming right now to the market, and of course the silicon signal processing on the bottom is also very important to make the devices miniaturized, low cost, and all the functionalities that customers require. So what are right now the main applications for Vigo detectors? It's temperature sensing, so passive sensing, where we can detect people entering the buses or trains, where we can monitor temperatures of people itself, or we can finally protect infrastructure like a trains against fires or against other failures. Thousands of our detectors are installed on the trucks across Europe to monitor fast trains, to measure the temperature of each wheel online when trains going even 300 kilometers per hour, and all perimeter of wheel is visualized on the system. So we could do active sensing with a laser, like for sorting systems. In mid-IR, all the lines are much stronger than in near-IR. You can find there almost any kind of chemical compound, and so it's very great tool to make a small sensors to detect chemical compounds in the air, in the water, or in the solids. So that's really something that we could work together in the community to improve sources, to integrate detectors, to make a whole setup as good as possible. So of course the new applications are coming right now. Biological sensing, all kinds of fitness and medical equipment that could detect all kinds of signals from the human body. We have customers in breath analysis to measure online breath composition to detect any kind of diseases from the composition of the air, and we are now going towards all kind of wearables, so very small component that could be used by general customers, not industrial or a special application like before. So that's a really eyes-opening market, and our goal is to scale up our mature technology to introduce it to industry, to medicine, and other markets. We are making our detectors smaller and cheaper. It used to be a price of €1,000, and we would like to make it down to even a few euros per detector. That's really possible with the large-scale production, and we are very open to talk to you with any kind of applications that requires low-cost devices. We are not demonstrating very small devices integrated with electronics already. That's the strength of Vigo is that we could integrate many components. We can work on different kinds of licensing that we could really speed up development of the final systems. And of course, in terms of optics, our monolithically integrated lenses was a great solution for many years, and now we are going into diffraction lenses, into mass production lenses that could be made just on top of detector, and finally fully integrated with photon integrated circuits. So that's really a great agenda, and mid-IR, as it is now, it should scale up to consumer electronics, automotive industry, and to much larger scale of production. That's the future that we are looking at right now, and investing with our equipment. We spent like 25 million euro recently on new buildings, new equipment, and new production halls. So we are really inviting everybody to work with us in a way to create great future products. So photonics in the future.
Thank you very much, Kobi and Parcho Adam. It's so great to have you here, and it's so great to see one of the success stories of Europe keep evolving, never relaxing. So you were very well known for your detectors, and you're saying, what's the next step? I'm gonna make sure I make lasers, and you make the first Polish VCSELs 3 weeks ago, which was quite fascinating. First question is the epic question. I have 572 companies here. What can they do for you, and what can you do for them?
So I'd like to invite everybody to use our technology to enter to our production line and play with us on any part of what we are doing. It's not separate technology that we don't control. We control everything. We can create a multicolor devices. We can change the shapes of structures. That's really something that we can work on together, because we design the structures. I see the question, what's the unique in Vigo technology? For years, we were fighting with the liquid nitrogen-cooled mid-IR sensors because they were looking at the highest quality of crystals, and we know that it's a heterostructure. It's a unique point to make a best signal to noise ratio. So for those 50 years of experience, we developed a structure that could work on any wavelength from 2 microns or even 1 micron to 15 microns, and it could be uncooled, and I'm really open for any kind of introduction of this technology to the mass markets.
We had a presentation about 1 hour ago from Elbit, and I asked him, what can the members do for you? The epic question, you know me. I asked the same question, and he told me, I'm looking for a partnership with the QCLs. And I keep getting that from the defense sector. But the defense sector is very interested in QCL. Are you seeing also push demands also from other civilian sectors or environmental monitoring sector for QCL technology?
Yeah, that's really the goal for gas sensing and for biotech is to have a multi-compound sensor that could detect many different materials in one sensor. And QCLs or ICLs are the potential components that could really provide us with tunable sources that could use our detectors and detect many gases without any mistakes. So that's really something. Actually, the price of the QCLs right now is quite high, and we are one of the demonstrations that we already did with our new epi wafer foundry is a material for QCL. So we are hoping that the development and scaling up of the QCLs we really enable to make all the mid-air components low cost.
At the end of the day, you said it the right word. So you said that the price of the QCLs are expensive, but I have a foundry, I make wafers which can be actually processed into QCLs, and those don't need to be expensive. So it is all about raising the demand. Is that correct? It's all about getting the right volume, because at the end of the day, it's a piece of semiconductor, right?
Yeah, so you need to have a technology, you need to have a demand, and you need to have the reliability of those components. So of course, hundreds of thousands of devices need to be manufactured to prove that those devices could be scaled up. But we are almost there with all the mid-air components. So I see no barriers.
For those who want to visit Vigo, 22nd, 23rd of October, epic meeting on mid-infrared sensing at Vigo System in Warsaw, at the amazing facilities that Vigo has in the center of Warsaw, which is a great city, and I just love it. Thank you very much once again, do widzenia. Until the next time, here we are, the epic family for you. And we go to Norway. Yeah. We go to Norway, we go to a fantastic country that they make fantastic hyperspectral imaging system. HySpecs has been one of the companies who has attracted most interest in the recent years as a young company out of NEO. Thank you very much. Thank you very much for being with us this nice afternoon. The floor and the attention of everyone goes to you, goes to Norway, goes to Trond.
Hello, Jose. Thank you for that introduction. Yes, I am Trond Løke. I'm coming from a fantastic Norwegian company called Norwegian Electro-Optics. I am the CEO of the hyperspectral division in NEO called HySpecs. And we are designing and developing scientific grade hyperspectral imagers. Yeah, I will quickly go through just an intro of NEO and HySpecs, then tell a bit about our R&D capabilities, our product portfolio, and at the end, some applications. Yeah, as I told you, it's a fantastic company, and one of the reasons is that we are owned by a foundation that was established by the founder. The foundation's vision is to support both art and physics, a quite interesting combination. We are an SME that was founded in 1985 as a spin-off from the Norwegian Defense Research Establishment. We are doing research in electro-optics with the objective to develop state-of-the-art products for the whole world, basically. In the early days, we did a lot of projects for ESA and the Norwegian oil industry. And we have commercialized quite a few of those R&D projects. And one is laser gas, which is gas spectroscopy. The other one is HySpecs, which I'm representing, and also underwater optics. Today, we are about 40 employees and 25 in R&D. So quite a research-heavy company, even if you are producing electro-optical systems. We are ISO 9001 certified. So R&D projects. Yeah, we are an attractive SME in Europe and also for international projects. We have a long history of working on prestigious R&D projects with key players in the world of photonics. Currently, we are participating in several Horizon 2020 projects, a couple of Norwegian Research Council projects, a few projects in food quality, one in the offshore industry, and we are participating in 3 research centers, 1 German and 2 Norwegians. And what I like with HySpecs is that we have all the resources internally to develop a product from the design phase all the way to producing the system. So we have like the optical engineers and designers, the software developers, the mechanical designers, the electronics designers, and so on. Yeah, our main focus have over the last 3 or 4 years been imaging spectroscopy. And hyperspectral imaging is imaging spectroscopy just with a large number of spectral bands. And we believe to do that properly, you need to have a high quality spectrum in each pixel. So our main focus and what I think is unique from our competitors is that we have this huge focus on the spectral fidelity per pixel. We deliver always sharp optics per pixel and per band and low spatial and spectral distortion per pixel. So as a company, HySpecs, we are very research heavy company with a lot of researchers in the size. We are about 28 people in HySpecs altogether. We have 17 years of experience with selling scientific grade instruments for research mostly, but in the last few years also industrial applications. We are recognized for our scientific grade and the quality, and we are delivering system in the visible near infrared and the shortwave infrared range. That means from 400 nanometers to 2,500 nanometers. Our product portfolio is like 3 areas. It's HySpecs classical cameras, which is a generic camera that can be used for airborne, field, and laboratory. We have the Mjolnir line, which is a drone-based, UAV-based system. And then we have the Balder line, which is flexible, fast, and is tailored for industrial applications. Yeah, so the main product platforms or areas are going all the way from airborne, where we are coming from with the first system we made, to laboratory, to field, and UV and industrial applications. All the cameras that we are developing at HySpecs are use the push-broom architecture. And we believe that that is the architecture to use to get the highest spectral fidelity in your imaging spectrometer. So what that is doing, we are capturing a very narrow spatial line on the ground with all the spectral information at the same time. So we do not need to reconstruct the spectra of anything. So that's captured at the same time. But depending on how you move your imager, you need to reconstruct the data in the spatial domain. So if you do it from laboratory, for example, you typically have to move the scene, or from a field operation, you rotate the camera, or in the airborne operation, the movement of the aircraft is making the second spatial dimension. And of course, from airborne and UV, you need a high-end navigation system to find the INS data for each frame to actually reconstruct the image. Yeah, then some quick applications for the airborne segment. Geological mapping is a big one. Forestry mapping, precision agriculture, urban mapping, and military and defense is also quite large. As I told you in the beginning, we have been collaborating with the Norwegian Defense Research Establishment for the 17 years I've been doing this. And we have a lot of the other countries' defense research establishment as our customers. Yeah, search and rescue, oil spills, environmental monitoring. And the customers are usually universities, governmental research institutes, and remote sensing companies for the airborne segment. This is a classical airborne system with 2 classical cameras, a navigation system, and a passively damped platform. On the right side, you see the touchscreen to interface in an airborne installation, and you can see the pilot is having a flight management system to operate the cameras. Some applications, this is from a French company, Actimar, been doing scanning the coral reefs in Madagascar 5 years in a row to see the health condition of the coral reefs, to see the vegetation index, to see how it bleaches and dying out. Another application is oil spill monitoring, looking at the thickness of the layer, what type of oil, and so on. And then I move to the UAV segment. Yeah, it's kind of the same application for the UAV. What we have seen is that the threshold for buying a UAV system is quite much lower than actually having an aircraft and renting a pilot and aircraft together. So we've seen that in the university segment, there's been a huge boost in sales due to this. We're not only like supplying our core business is the hyperspectral camera, of course, but we have seen to sell system in the UAV segment, you have to offer a turnkey solution, which means that we also offer UAV platform, data link, ground station, and processing software, of course. And what we also offer in our UAV systems is a board site calibration before we deliver the system. That means that we are actually finding the offset between the camera coordinate system and the navigation system so that you can actually do direct referencing from day one when you receive the system. Yeah, this is our real-time processing software working on the drone, doing real-time georeferencing while we are flying. Now I just show 3 RGB bands visualized on a background map. What I show now is the nitrogen contents of the plants in the image, so the NDVI index. The next line will show you anomaly detection. It's kind of a search and rescue application where you're looking for spectral signatures that are anomalies. And here we have a gray bag on some rocks. We can see that this man-made object is lighting up as a white object. For example, for search and rescue or target detection for military. This is just to show the potential, right? Here we want to add a lot of customer-specific algorithms and yeah, for example, mineral mapping and stuff like that. Yeah. Field applications as I said in the beginning, then in the field application to operate a push-broom camera, you need to rotate it. So it's typically on a tripod with a rotation stage. The applications are, again, geology, outcrop and man-face scanning, cultural heritage, vegetation, and defense and security. Users are here, universities as well, governmental research institutes, and also corporate research labs and the mining industry and survey companies. Here's an application example from CSIRO in Perth in Australia from 2008 from an iron ore mine, just showing the classified minerals on a mine face. This is an example, also geology example from GFZ in Germany. Been our customer for more than 10 years now. They started off with our classical system and last year bought a drone system. They are doing here rare earth element mapping based on our spectrometers. Another geology application from SAPPHIRE in Norway. Here looking at a mine face with a different kind of limestone and dolomite. In 2011, we actually also developed an ARC scanner for the museum at Louvre in Paris. That's what you're seeing on the right here, the image on the right. 2 years ago, we made a new version of that one, and that has been sold quite a lot these last few years, the new ARC scanner that we have. And for the art application, we have its restoration, its pigment fading, its color research, also actually research purposes, or I mean insurance purposes, where the technology is used. For laboratory applications, we again deliver a complete system, right, with stages, illumination. We are building up labs for different universities so they can do their research, right. So to do that, we of course have to also design custom lenses for different working distances. Are always focused at infinity. And we don't use any off-the-shelf lenses because to keep all the spatial and spectral misregistration low, we have to custom design everything, all the optics. And for the lab application, we go down to 24 micrometer pixel size. Here is an example, some soil research from University in Trier. I'm not spending a long time on the applications here, just to show the potential of the technology. Yeah, core scanner, looking at drill cores and mineral mapping and classification and quantification of the different mineral and elements. And then the last platform or application area we'll talk about is industrial. So last year we released a new brand of high-spec systems called Balder, which is working in the industry. And the biggest application there is quality control of food, wood, minerals, and pharmaceuticals, and sorting of glass recycling, waste recycling, and also minerals. On the right side here, you can see a system that will be launched or commercialized in 2 months. It's what we call a fish quality analyzer. What actually this is doing, it's a imaging spectrometer looking down at fish with the skin and everything. We are illuminating the fish at a different place that we are looking. So the photons that we're getting have actually gone through the skin of the fish twice and scattered inside. So we are actually looking then through the skin. And with the software from Predictera, we are able to detect the species of the fish and also the blood content of the fish, which will be telling something about the quality of the fish. So then it's sorted based on the quality of the fish afterwards. Yeah. So for the industrial machine suppliers, we are supplying an SDK to easy integration And there are a few companies out there today that are doing making software for processing hyperspectral data, and we are fully compatible with them so that you can do real-time processing on an industrial conveyor belt. So to sum up, HySpecs delivers scientific-grade hyperspectral imagers for a big application area, airborne UV, lab, field, and industrial platforms. We are interested, HySpecs and NEO, and is interested in collaborating on interesting R&D projects in the field of photonics. And yeah, please contact us if you want like demonstration, to send us samples to be scanned, demo data, or in general just want more information.
Very clear. Thank you very much. A perfect answer to the epic question. What can I do for you? What can you do for them? You are looking to have more R&D cooperations to further develop the camera system. I have questions for you in the room. The first one is coming from ST Microelectronics. My friend Eric has a question. Eric, what's on your mind?
For taking my question. So my question is regarding the spectral range of your system.
Yep.
Can you describe a little? I guess it depends on the final application, but mainly.
Yeah. So we use the complete spectral range that we are making systems is from 400 to 2,500 nanometers. So we are using 3 detector technologies: silicium for 400 to 1,000, then InGaAs from 900 to 1,700, and MCT from 900 to 2,500.
So when it comes to my second question, all these different detectors are quite heavy, and when you put it in a UAV, it gets a problem for the payload. So do you see any promising technology to have, let's say, all-in-one?
I'll actually say we are using the first ever 10 micron MCT detector from a German supplier, which you might know, with a compact Stirling cooler, which is extremely lightweight and small, especially tailored for us for UV applications. And for the silicon-based one, you get quite small systems. So the hyperspectral camera itself for drone-based weighs 1.492 kilos. So it's not too heavy.
Okay, thanks.
We have a second question in the room. This is from a young entrepreneur. So I think, Tron, you need to also excite her on how cool it is to build a successful company. Asa, yeah. Thank you very much for joining. What's on your mind?
Great. Thank you, Jose, for the opportunity. So for the UAV, my question was that what is your field of view? And then also, since you've mentioned, I asked both of them together, sorry. Also, since you've mentioned you have the software, I was wondering, have you considered combination with any LiDAR system for overlaying of the data, basically?
Yes,
Thank you.
Thank you for the question. Yeah, so 20 degrees field of view is what we used for drone systems. Yeah, we sell, if you looked at close at one of the images I showed in my presentation, we have a fully integrated LiDAR and photogrammetric solutions that we sell together with the camera. So you can fly the full VS 400 to 2,500 with a LiDAR at the same time. So we have that fully integrated.
Trond, I live in Noordwijk. Behind these roll-ups is the European Space Agency. They love you there. And every time I go there and I talk about spectral imaging, did you talk to the Norwegian guys? This is the starting point of every conversation. If we had this presentation in 5 years, how is HySpecs going to look like?
Okay, when you talk to the space guys, of course, we are doing stuff in space as well, which I didn't mention here. But I hope in general, you will see a 3 times larger company. You will see where I think that, and I think we can expand 3 times in the research region where we are. I guess we have the best reputation today, but where I believe the big volumes and the biggest potential is in industry, in sorting and quality control, where a lot of the different machines today use people, right, for this, where you can have a lot more reliable technologies in the future. And hopefully HySpecs will be that technology.
The food and beverage sector and the recycling sector are the ones who are attracting most interest. You are saying in 5 years you want to be 3 times bigger. That's your preferred future. What do you need to get there? Do you need investment? What do you need? Tell me. I will find it for you.
Also, basically we need the knowledge. So one of our biggest sales activities, all our salesmen are PhDs. They need to train the customer and tell them why they need the technology. And it's quite, that's why we are offering free demonstration. Just send those samples and we will scan them and process it for free to show you how good the technology is. So that's part of the sales job. And I think once everybody knows that this actually can be an also affordable technology now in the future, then it will be used a lot more than it has already. Not only for research, which is basically the biggest application today.
Trond, you are a role model, and I'm really happy to have high specs in Europe. In my opinion, the future is very, very bright for you. Thank you very much. One more thing.
Thank you very much.
Look at the clock. Look at the clock.
Perfect.
It's almost 3 p.m. It's almost 3 p.m. You know what that means? I've been doing this for 12 hours straight, and I'm fully fresh, like a flower. You got this. Eh? Do I look tired?
No.
Not at all, right? Edward, do I look tired? Edward, I look okay, right? People told me Jose is gonna die. Jose is not gonna die. He's fully awake. And I'm going now to Slovakia. I'm going to Slovakia because I want to know more about specialty fibers and I want to know more about SILEX technology. Edward, thank you very much for joining this epic journey. Halfway through, you are the one in charge of kicking the second half of the tour. The floor and the attention of everyone goes to your fibers, goes to you.
Okay, so hi everybody. I hope that you can see the screen.
Well, not yet.
Not yet. No.
Did you press the share screen green arrow button at the bottom? At the bottom of the Zoom window, we have a green arrow. Yes.
So now should be okay.
Yes, and now go slide mode, and you are ready to rock. The floor is yours.
Okay, thank you very much, Jose. So it's really a great opportunity to say something about our company. Actually, what we are really very proud of is that our company just celebrated a couple of days ago, 25 years. So we are really quite a long time on the market, and we are really firmly standing on two main legs, I would say, as any people, or most of the people. And these two legs are fiber optic interconnections, products and systems, and fiber optic sensor and sensing solutions. We act in a different markets. We serve OEM customers. We also have a full turnkey solutions. And I would like to present our activity in these two areas. I'm here with my colleague who will take care of the sensor and sensing systems. And to show you our complete portfolio and our impact on the market. In case of interconnection, we are ready to help our customers and to help to develop the solutions then in a field of LAN systems, in a onboard optic systems, data center, telecom, even in defense applications, industrial applications. In case of the sensor and sensing systems, we offer really a turnkey solution. There is the main advantage that we can cover from the really first analysis of the problem on the customer side to perform all the features which are required by the customer, to design the solution, to install, and to offer also some data analysis in a field like structural health monitoring, geotechnical systems, industry applications, also offshore, marine, and subsea systems. The best way how to say something about our real products and projects and what we offer are really, as we name them, business cases. And maybe one of you or some of the people know the very strange abbreviation like LHCb or CMS, ELISA, and so on. Maybe it's not so known for everybody, but once I say that behind these abbreviations is a biggest nuclear research institute in CERN, where we really literally helped to discover the Higgs boson, thanks to the fiber optic interconnection which was deployed, and where we provided on one side a very robust system of connectivity with a high fiber count, very thick style of cables, and on the other side there is a very tiny, small, high fiber count, state-of-the-art lens-based system interconnectivity, which is used on the board optics, gathering the amazing quantity of data produced by the experiments at CERN. Another area is the one which is actually very, very actual also regarding this event, because you can see on the map that the whole world is completely cross-connected. There is the New Zealand, there is the west coast of America, and just thanks to this complete cross-connectivity, we can have now this event, and we as SILEX contributed really to the connectivity of the subsea and submarine cables to the on-ground system, where the signal is really transferred from the subsea cable to the ground backbone of the interconnections. On the other side, most of us are now connected to this event from the home because of this very unpleasant situation with the virus. And this is again thanks to the fiber to the home applications, where we helped to develop really a complete solution, for example, for the Belgian telecom, where were really a couple of challenges which we were able to solve. On the other side, I think everybody has now a kind of gadget phone or whatever, where is really a computing power, which is amazing once we compare it to the 80s or 90s. And to be able to move this even forward, one of the emerging industry, which is really not so visible maybe, is the supercomputing and the electronic design automation. And we are a partner of companies, well-known companies in the world, who are really perfect and the state of the art in this area. And we supply to them an interconnectivity system based on the very complex shuffle-based products, multi-fiber interconnectivity up to 64 fibers in one cable and in one connector, which are the essential part of the interconnection based on the optics board, which really gather the information and post-process them later on. And of course, all the data which are generated nowadays, either in the industry or with the coming 5G or any other, should be somewhere stored, moved, transferred. And here we again serve the customers with our solutions, which are ready to cross-connect the sources and the end users, which are outside of data centers, inside of data centers, co-location data centers. So whatever what should be somehow connected with almost always a tailored solution against the measures of the customer. So there is almost no similar products which we supply to our customers depending on the specific project. Here we use the very basic style of interconnectivity interfaces, but really also the very last developed one, which are dedicated for the latest QSFP-DD or OSFP transceivers, which are definitely the future of the interconnectivity, attacking the 400 and 800G applications. So these are all the areas which we cover with the fiber optic interconnection. And there is the second part, the fiber optic sensing and sensing solution, where I'm giving now the floor to my colleague Peter, who is really best to explain what is available from SILEX at this area.
Hello, everyone. Thank you, Eduard, for the word. And I'm happy to join this amazing marathon of presentations. And thank you very much, Jose and the whole EPIC team to organize this event. It's really encouraging to speak to many people. So as Eduard was showing some previous applications, we always speak about the fiber. When we speak about the fiber, that means fiber is the essential of the fiber optics as a technology, and fiber optics is some kind of subgroup of the photonics. That's why we are all together here today. So those applications that Eduard was describing about are on the background of the infrastructure in telecom data communications. I want to show you some more slides showing where the fiber is emerging into many other environments, and very lightly speak about how challenging it is to protect the fiber in such environments so that it can retrieve the data and it can also transmit the data to all of us. And one of such great examples for the sensing applications are our civil structures. So everybody uses bridges. We need the concrete dams. we need to have these structures to be monitored very similarly like you are using now, for example, your intelligent watches to tell you what is your heartbeat. So we want to know the same thing about the structures as well. That's where the fiber is being deployed, and I would say all the photos you see here, they are not downloaded from internet. They are real life projects where the fibers are really existing. So we are looking at the bridges in Europe. We see some dams, and those are long years lasting projects, still today working systems, collecting the information about the deformation of such structure and whether their structural health, that's the abbreviation of SHM. So structural health monitoring is one of the great emerging areas for fiber optics. Geotechnical is another world. It's quite similar to the one before, but we are also showing some examples where we are going a bit of underground. So we see on the left top side, one of the biggest open pit mine in the world, which is located in Chile, and is equipped with our sensors to monitor the soil movements. We can see another photos showing the sewage system down in London. This is a Victorian area sewage system. It's an explosive area actually, which allows only fiber optics to be deployed in a reasonable cost and with great effectivity by retrieving the data about the structure. So why people sometimes monitor the structure is because there is a lot of new high-rise building being built. They are digging new tunnels for new metro lines, and you want to be sure that the existing infrastructure is not going to be intact by these new activities. And very similarly, we can deploy the same things in the picture of a tunnel. And on the bottom sides, you can see some product examples showing how that packaging of fiber, by packaging of fiber, we mean sensors suitable for really harsh environments and still providing very, very sensitive microstrain, micrometer precision of measurements every day, 24/7 at any speed the actual interrogation allows. Then we need to also transmit sometimes oil, CO2 or gas between our cities, between our continents, and that's where the fiber optics is also very nicely suitable. It's very easy to be deployed. You need to have some good tricks about how to build that sensors and how to install those, because those tubes are transferring, of course, very expensive, but also very explosive material inside. So the fiber optic is here to measure, again, the strain, which is a mechanical parameter of any structure. We can say in easier words, something like deformation. And we want to also measure the temperature many times. So you can see the bottom picture showing the sensors being directly deployed, and the other pictures are showing how the fiber optic infrastructure, so it's a lot of cables around, are very easy to collect those things. The benefit here is that we are completely from the energy point of view, we are completely passive here. That means we are not bringing any electricity. We don't need any power supply other than for the data acquisition unit, or in our words, speaking about the interrogators. Going from the ground to the sea and subsea or maybe marine application, we see some pictures here. On the left top side, you can see a monopile, which is 60-meter long. It's more than 1,200 kilos weight. And we are coming there with a tiny fiber that is smaller than our hair, and it senses the touch of such pile while it is being hammered to the ground in the offshore area. This process of hammering is used to basically to allow a touch with the solid ground, to bring it on top of the sea level, where you can then mount your oil platforms or wind turbines on top of it. So while doing this hammering process, you want to be sure you are not destroying your pile, because that's the only connection to the ground. So the dynamic analysis, even with maybe 8 kilohertz sampling, is very useful, and it's unparalleled with other technologies so far. And you can see also piers being built on a marine structure. So the sensors are covered with soil, with concrete. They can survive these environments in very good conditions. And so that's basically everywhere the fiber is now being spread so far. Apologize. And industry automation, you can imagine any kind of application, from car producing industry, paper processing industry, analysis of wind turbines, individual structures, where the tiny fiber again can come very easily inside of those devices and give you remotely very nice structural information, what's happening with your structure, how that can perform. And there are now much more new applications being developed with our clients that they can bring up more and more useful information to optimize the energy sourcing in this world. And when we say the fiber optic is part of the photonics industry, we mean that those photonics elements, the fiber and the sensing and the data transmission is really everywhere on our planet already. So again, here are real project pictures. On the left side, you can see a glacier in Alps. So the guys have been, in this case, combining our FBG technology together with the distributed sensing technology to compare and retrieve the data more precisely. So both technologies have been very nicely exploited and used in large scientific papers that we can share later on if you would be interested. And on the right side, we see monobuoy. So we speak about an ocean, and this monobuoy is connected to the ground with an pipeline filled with an oil. So those are the elements that needs to be monitored because of ecological situations or prevention of some troubles. And on the left side, when the glaciers, we are just checking about how quick our glaciers are disappearing from our planet so far. But it's of course very important to know this process in all details, so these people can retrieve new data that they didn't have 10 years back ago. Now they can work with them and maybe take more particular measures. So we really speak about fiber everywhere. And that wouldn't be possible without being in touch with such a great community like EPIC companies. We also speak to a lot of academic institutions. We were helping in projects like Edward shown in CERN. We also are partially involved in an ITER project. Our work is basically to package the fiber in a correct way and give the people the tool to give them the information about their structure. If it is pressure, if it is strain, deformation, temperature, vibration, anything else, that's what we do with the fiber. And that's how we also bring that information via the cables back to the user who knows what to do with that and how to deal with such data. And that would be very quick, I know, but we are happy with Edward to receive your questions now. That's it.
Thank you very much. Fantastic. The whole thing to cover datacom, telecom, and fiber sensing in 20 minutes. The most important question that you get is the EPIC question. 570 companies here. What can they do for you? What can you do for them?
So what we can definitely do for them, it was already presented, that we have the capability to really contribute with our knowledge as regards the connectivity, which can be really a basic type of connectivity on the cable and connector side, but also a very complicated one, down to the shuffling products where the really complicated transmitters are connected together. So this is what we offer. And what we are looking for are really ideas how to include some new requirements into the maybe very easily looking interconnectivity or fiber optic sensors, which can move a little bit on a higher level, either TRL or some other level, the product themselves, to help the industry move forward.
So yesterday,
I can maybe add a few words, and it has been said at the beginning, but Silex is 250 people company. So we are basically a producer and engineers in the same time. So what we do is that if there are good ideas coming from anywhere and it touches somehow the fiber, then we are the right people to speak to, because then we certainly have already existing experiences, or we can develop them together with anybody else.
So yesterday I was on the phone with a company in Portugal. The company is called FiberSail. Pedro, you're watching, obrigado. He told me a couple of things about his business. He wants to monitor strain in the blades of the windmills. So then I told him how you're going to do that. And then apparently there is the need to you can use standard standard fiber, you can use FVGs, but you have to protect the fiber for these harsh environments. Does Silex, when it comes to do the fiber sensing for harsh environments, does Silex look for partners to do that, or do you want to address the challenges of harsh environments yourself?
We are always partnering in that situations. We are not really a turnkey solution with closed ecosystem. We mainly work like OEM partner in these businesses, and every environment requires a little bit different conditions. And our advantage is that we know how those conditions should be addressed by all the engineering work and by all the sensor design that we can provide. If there are particular questions of your client regarding the wind turbine, I would really tell him fiber optics is the right way to go into the wind turbines because of the protection against the lightnings, which makes absolutely sense. Fiber optics is also lightweight, so it doesn't create any troubles, and you don't need any electricity power supply for those systems in that environment. So your installation is very simple. There is no big complexity, and there are a lot of good companies that have already a turnkey solutions, and they utilize the production of Silex for those solutions.
You know the best part of this? You are going to tell him yourself, because he's going to be the keynote speaker at the EPIC meeting on fiber sensors at HVM Fiber Sensing in Lisbon, 16-17 of September. And I know Silex is going to give a fantastic presentation there. Thank you very much for a great presentation. It's 3:20 and we move to the next speaker right on time.
Thank you.
We go.
Thank you very much, Jose.
Thank you. We go to a tier 1 supplier in the automotive sector, Autoliv's Veoneer. We want to understand what the photonics community can do to reach the automotive industry, and that can only be said by the tier 1 supplier. Thank you very much, Jan Erik, for being with us. The floor and the attention of everyone at 3:20 in Noordwijk, the Netherlands, is yours. I think we may have you still muted. Let me unmute you.
Okay.
We hear you very well. You
hear me now?
Yes.
Is my voice good enough?
Your voice is beautiful. Goosebumps.
Level is fine.
Level is fantastic.
Okay, let's start then. So I'm going to talk about how to put your fantastic technology into automotive production, which is a challenge by itself, and I've done that before. So the content of my talk is, first of all, Veoneer. Who are we? Perspectives on automotive R&D. I think it's important to understand the potential and challenges, and then what it actually means to go from technology, promising technology, to automotive supply, and some closing remarks. So first, what do we do? Veoneer is basically a tech company delivering automotive grade electronics. So we have produced so far about more than 4 million cameras that are in vehicles today. We have produced over 33 million radars, and we have accumulated about 750 million plus airbag electronics and other things, sensors. We are a spin-off from Autoliv, which belonged to before, and we are part of they spun off the electronics because the airbags and seat belts is a different phase in development than the very fast expanding electronics. And if I then go to the next slide here, we are blessed with rapidly expanding business. We have expected lifetime orders of almost $6 billion. But that's also a challenge, because that means that you have to rapidly expand your business, and you have a lot of R&D before you can start that in production. If you're an automotive supplier, you basically have to be where relevant automotive are developed and where they are produced. And so are we. Just some last year key launches, you can see who our customers are, from Mercedes, Ford, Honda, and some Chinese and others. I still think it's interesting that you can nowadays produce cameras in Sweden and ship to China. It's not the other way around, for instance. But that's how the industry is moving. So perspectives of an automotive R&D. I'm going to take an old example which I was part of many years ago, but just to show the part of it. We started with an inflatable curtain about 25 years ago, which is now in almost any new cars that you have, and you see that it's not electronics or anything like that, but it just shows that how things can change. The initial demand was estimated at about 100,000 per year, and it was questionable whether the production volume would justify the development cost. Last year, production was about 50 million units. That's about 50% of the world market. Accumulated production of the 20 plus years is about 1 billion units. And even if you estimate at a low of $40 per unit, that's about $2 billion turnover per year. And if you take 1 billion units times 40, it's about 40 billion in accumulated turnover at a very healthy profit margin. So you can actually make a lot of money in this area if you're just successful. Good patents has been important here to protect the IP, and also others had to pay royalties to us for the 50% of the production that Autoliv didn't take. So you can make a lot of money if you're good and if you're doing your homework. Then what does it mean to transition into automotive supply? Well, first of all, it's basically the normal thing here that you have a laser, for instance, a detector, optics, etc., and you go to module integrator, and then you go to tier 1 supplier, and then eventually go to the OEM. But you're not a component supplier, even if you are a detector supplier. You're actually part of the system, because it's almost like a chain here. So you're not stronger than the weakest link. Technology production. Methods and processes that may be suitable for small or modest volumes may be unsuitable for automotive scale. Selected equipment capacities may not scale or force redesign. Design tolerance may not be cost effective or achievable at scale. Specialized suppliers may not have the means or desire to scale, and high volume yields may not support cost demands. And there are tough environmental specifications like temperature, vibrations, EMI, substance immunity. And another financial thing about it, nomination is not a firm order, it's a forecast, and then you have to deliver. Delivery is called close to shipments, and that those deliveries schedules may change depending on market demands. The potential for high volumes comes with a modest profit margins normally, unless you have very good IP protection. Very rarely are in double digits. The curtain I showed there was probably one of the exceptions. Year-on-year productions is what the OEMs require, typical 3 to 5%. They basically want to have a cut of your expected efficiency improvements. And for new technology, the price may be below your total cost of sales. You may actually have to take a loss initially and then recover that once your volumes take off. Capital equipment required for high volume production will be amortized on production, and cash flow demands can be crippling for a smaller company. The required investments must be done well before recoupment. So if you have a long product, you can have maybe 3 to 4 years, and new platforms 5 to 6 years, but you have to be able to scale up before that that happens. Auto industry is excellent at making parts commodities. So you have several suppliers providing similar parts. You have highly competitive sourcing. IP provides differentiations, and they protect profits. traditional business models may not often push higher up in the food chains, but if you don't have the buying power to really source things economically, you may want to have, for instance, a tier one to help you getting the best prices. So it may be more advantageous to license your IP to more skilled manufacturers like a tier one, or just sell your core technology. It may generate less profit over the product lifetime, but it's a less capital requirement and a less risk. I'm not sure if I can, I have full screen here, if I should go to anything else. So I see what's any comments.
No, just continue. Everything is
Okay,
very
good.
great.
Very good, then I continue. So product development system here. You need to have a product development system tool as a risk management tool, as a workflow for different linked tasks from quality, purchasing, and so forth. And it's used over cross-functional teams. And this is very essential. So if you run into an automotive, you actually have to follow more or less this module with many strict gates, and for A prototypes, B prototypes that you see here, I've circled them in red in the below, and the different things. And you have a bunch of steps that you need to take. And if you haven't done that before, you're going to be in for a rough ride. So you basically need to get help with somebody that has done that thing. There's a bunch of major deliverables. I won't go into them in details here. We don't have the time. But they are essential, and they will be scrutinized by the customer, the end customer. You also have to consider quality. I mean, quality is a process. You design robust products, you buy flawless components as much as, and you try to manufacture flawless products, and you want to verify conformity. And basically, if you show those things, you have level 1 quality levels, you have like inspections, and level 2, you're reactive, you have good problem solving skills for non-conformative elements, lessons learned, bunch of other things like that, quality alerts and so forth. But you won't get to where you want to be unless you instigate proactive quality control, which means design for reliability, process FMEAs, go and see, adherence to standards, etc., like that thing. You won't get there unless you are proactive. You have to basically foresee what can happen and prevent them before they happen. And this is following the Toyota model, and they basically illustrate it in a very good way. That is like a body of water. When the water is high, the problems are hidden, and the problems are seen as rocks. If you may only have a few problems seen, or you maybe even can guess that they are there. You may see them just below the water. So you think everything seems to be fine. But when the water level is reduced even further, then all the rocks come up. And what you have to do, you have to take care of the rocks that disturbs the process, and make sure the water flows nicely again. But then you lower the water, and new rocks appear, and you take care of them. And then you lower the water again, and you have more rocks, probably not as major as in the beginning, but it's a never-ending story. And it's very important for the mindset too. I mean, quality is never finished. And then we have the tail of the tail. You have to get production output and start measurement. As a startup or coming from low volumes, you probably don't have much of a good idea of where you are in that case. So you expect maybe a Gaussian distribution, and you basically assume around something nicely centered around the mode, and you think that you're pretty good. But it's the tails that are important. And they are disasters waiting for happening. And when the scale is small, they may be as minuscule, those blips. But if you're unlucky, you may actually have, when you scale it up to volume, that you have a failure mode that's happening 100% of the time, or a majority of the times. So it actually pays to start build your sample size quickly to bring out the corner cases, because these happens, it just don't happen as often as otherwise. I say the difference between possible and impossible is the frequency of occurrence. Even impossible things happen, but not as often. A good choice, then that means that a good choice is to cooperate with the tier one. And they will help you transition into automotive supplier. Your competitive advantage with the existing customers will also increase, which actually is what should make your competitors really worried. Because if you learn automotive talk, you will be very efficient in your other businesses. The Toyota production systems that we and many others adhere to may be the gold standard, but it's not easy to implement it by us reading a book. A good partner that teach you from lessons learned is good, and it's essential for the automotive manufacturing process. So finding a suitable tier one is likely beneficial to all parties. So as a closing remark, what it means to supply automotive is develop and production processes are essential. And we recommend that you find somebody to cooperate with to transfer into automotive supply. You will benefit from that thing. And that is basically what we have as a business to do. And thank you for your attention.
Thank you very much, Jan Erik. Thank you for this presentation. This is priceless. The things that you just told us, I should really pay for working today. It's quite spectacular, but you didn't make it very attractive for me. I had to say, if I had a company in photonics with low TRL technology who can solve a problem in automotive, the thing that you told me that initially I had to sell it below the cost of goods could make me very worried.
It's a tough word, unless you do it properly. That what I started by saying is that you can make a lot of money. I mean, the first example I showed, I mean, it was basically profit levels of around 5 billion euro total. That's money too in my book. So you can make a lot of money. But if you don't do your homework, it's going to cost you money initially. So that's basically the story. You can make a lot of money, but if you don't do your homework, it may cost you initially.
So for me, I'm going to tell you one thing. Look, people really are used to me speak my mind. So I'm just going to tell you what's in my mind. And don't judge me, please. I believe that this market, the automotive market, need more new companies in automotive who are less afraid of taking risk and want to push technology. I think, and you're going to judge me for this, but I think we need more Teslas, we need more Google cars, and we need more crazy people with dream ideas to revolutionize this a bit, because I think you are setting up rules which are very interesting for the car makers, but are not interesting for the automotive industry in general in terms to evolve and, of course, innovate. What do you think of that?
Competition is good. That's what makes the world go round, and that's what makes things efficient. But we shouldn't just think that just taking risks and being gung-ho is going to solve all the problems. You also need to do your homework. So the devils are in the details. And what I'm basically saying that if you have new thinking, and that's what I'm saying, if you have exciting technologies, new thinking that you think can bring into the automotive world, which has an enormous market, that's good. But in order to fall into the traps that are there, hitch a ride with somebody that can help you, because then you both of you benefit. We don't have your technology, but we have experience of industrializing it into high volumes, and we have experience of avoiding those potholes that you may not see. So just being enthusiastic and risk-taking and not watching out for potholes is going to cost you. So better look out for control. Keep the other things, but then help somebody, take a ride with somebody that helps you look out for potholes.
You raise also a very interesting topic, which is cooperate with the tier one. I really like that. But a couple of times it has happened that the tier one competes with some of the tier twos. It has happened, I know I'm not going to mention the name, but you know them.
Yeah.
That now they make LiDARs. So how do you feel about this? Is it easy for the companies to say, I'm going to cooperate with the tier one, and eventually the tier one becomes a competitor?
That's the challenge of a business, and basically the only thing you can do there is to make sure you have your IP in order, and that you have agreements for that things. If you do your homework before, I mean, we've had companies coming to us and say they have great ideas, and I want to see their patent. I said, oh, we haven't filed it yet. And I said, please do before you talk to us again, because otherwise you just get into something where the lawyers get healthy and nobody else.
Okay, I think on that we fully agree, of course. One thing that I can tell you now on the positive side, what I have seen in Europe right now, which is we are living the micro-optics revolution right now in Europe. We had the best micro-optics in the world, and now you can see the light carpet for very high-end cars manufactured with micro-optics manufactured in Europe. We can see micro-optic manufacturers being automotively qualified. You can see that the next stage LiDAR technology uses micro-optics manufactured in Europe. Is that something that you are feeling as well? Because I think we need more attention to that. People still maybe don't know that the best micro-optics in the world are in this continent.
I agree. I mean, Europe is, when it comes to photonics, Europe is actually not the big established big companies. It's many smaller companies, and actually has a lot of things to bring. It doesn't only come from China or the US or something like that that we traditionally is used to. So there's a lot of things, and another. What I think may come as a revolution in sensing for automotive is active imaging, active thing. Basically, you have to send out energy and not just use passive energy. And that is actually a tough one, because if you start calculating on it, how to get enough light at the right place, at the right field of view, at the right distance. I mean, I've been on meetings with also companies when they told me something and I put it into my small link budget and I say I get half a photon back. I don't like half photons. So we have to also make sure we do our homework and make sure it works. But it's possible to do, and it opens up a lot of possibilities with active imaging. But it's also requires homework to be done.
Having you, Jan Erik, in the EPIC network is priceless, and this presentation, I can tell you, is memorable. I'm going to use it a lot. You really have defined the homework for entering the automotive sector. It's not an easy one, but the main takeaway is if you go through a very difficult road, at the end, there is a gold mine. Thank you, Jan Erik. I really appreciate this. We go now to IBM, and we go to my favorite topic in the world, co-packaged optics. Paul Fortier, thank you very much for joining all the way from Canada. We go now to the other side of the Atlantic. I want to know a bit more about co-packaged optics at IBM. The floor and the attention of everyone goes to you.
Excellent. So let me just share. Do you hear me correctly? Just to make sure.
I hear you loud and clear. Perfect tone of voice.
Great. And you see my presentation. I'll just put it in.
Excellent. The floor is yours.
Mode. Okay, great. So yeah, so I work at the IBM Assembly and Test group in IBM in Bromont. I'm responsible for all of our photonics packaging technology roadmaps and strategies. And as you said, Jose, I'll be talking about our assembly technologies for the co-packaged optics. So maybe just a quick overview of who we are in IBM Bromont. We're basically a packaging OSAT for complex semiconductors. So we offer a lot of services going from wafer finishing services such as backside grinding, dicing, assembly. So that's one of our biggest areas of mostly focused on flip chip type of applications and photonics. Test, going all the way from wafer test all the way to module and card level test, and a bunch of other offerings of modeling, design, liability, and whatnot. Where are we located? So as you said, we're on the east coast of North America in the province of Quebec. We do a lot of work. I just wanted to show our spread across the world. We have 3 big research labs in IBM, and we do a lot of work with them. They bring a lot of the fundamental research, and then we bring that into real life products through development and production. If we look a little bit more locally, so this is an image. We're in what we call the Northeast Microelectronics Corridor. So if we look at the state of New York, a lot of IBM sites, global foundry sites, AIM Photonics, and we're at the top of that, about 30 minutes from the US border. There's an image of our manufacturing site. So it's 850 square foot. In the little yellow circle we see over here, that's a dedicated development center that the founding members were IBM and Teledyne DASA, which does MEMS, and that's managed by one of the universities, local university. That's where our development work is done there, and then it's an easy transfer over to manufacturing site, which is right next door. Our packaging portfolio, as I would call it, so we've been working in microelectronics for 30, 40 years, concentrated a lot on really the complex stuff, very big chips, complex MCMs, and all of the different 2.1Ds all the way up to 3D packages, so all types of packages. And then in the photonics, so mostly silicon photonics that we're working on, and we've been starting on that probably about 8 years to build the building blocks for the next generation of co-packaged optics. So I'll get into these in a little bit more detail. There are two innovative approaches to fiber connection to the PIC chip. So we'll see those in more detail. Go through. For our vision of photonics packaging, so I guess the legacy, and maybe it's becoming less like that, but I think there's still a lot of that. Things are done very manually. It's very low volume type stuff, and that's, as we go forward, we need to get higher volumes and things have to be automated. So what we're bringing to the table is our vast experience in microelectronics packaging and bringing that and adapting that to the photonics world. That's what's needed to get to the lower packaging costs that we know we need to get there, and increasing the scalability, either bringing up volumes rapidly or more and more physical channel counts. This is a chart I've shown a couple of times before. I kind of like it. Things have changed a little bit, but it's just historically packaging. If you go back not that far back, people would always be more concentrated on the chips, which are just important, obviously. But they were not taking into consideration much the packaging. They would do the development on the chips and just send that over to the packaging as an afterthought. Hey, you guys figure out how to package it. That's no longer the case. I mean, with the disaggregation of all of the functions, the system in a package, the package itself is extremely important. And if you want to meet any of the metrics of success of a product, you got to get packaging involved right at the beginning. And I think that more and more people now realize that. So one of the building blocks that we're working on, what we call the chip scale optical package. So what I've shown here is a very generic kind of image of what I would see as a 2D MCM integrated optics. This could be, there's more complex structures which bring in 3D or 2.5D and other things. But what I wanted to show here is more that what we're trying to do is a microelectronics type package and integrating optics functionality within it. So the building blocks that we're working on are a photonic flip chip, integrated lasers or SOAs, and then the two technologies that I'll get into more detail later are fiber and polymer interconnect, and then how you connectorize the optics to the module itself, whether it's a pigtail coming out or if there's connectors on it. I'll show you that images on that as we go forward. What are the implementations of this? Well, obviously, more and more people are now talking about the co-packaged switch. I think that's become a major topic at a lot of the conferences, and I think it's becoming real now. Everybody, I think most of the industry is positioned that when we get to these high bandwidth switches at 51T, that optics need to be used. I think we're talking in 2023, maybe a little bit later time frame. So those things have to be worked on now to be ready for production. So that's one of our target areas is these co-packaged switches. And also it can be any type of optically enabled device. So if you have high bandwidth, either an FPGA, a CPU, basic memory, whatever it is, then you can integrate those chips within that chips. A few recent demonstrators that we've done last year, 2019, at OFC, we were showing some customers some of these high fiber count packaging that we were doing. So we were trying to figure out how close we can get fiber ribbons coming in onto the package, either with boots or with boots. reflowable, and I'll show you a little bit more detail that later, a reflowable fiber attach process. We showed that at C 2019 with SEMICO. Integrated connectors, I showed you an image a little bit earlier, so that we were showing to customers last year at ECOC, where we have 2 empty fibers and ferrules, and you're connecting them in. An optical switch, so that we've been working with the IBM research teams and ARPA-E from the US government. So this is a full functional optical switch, and that was presented by one of my colleagues last month at ECTC. With respect to public collaboration announcements, so obviously we have lots of collaboration and not all public. This is one that one of our partners, Renovis, that published this during the OFC of this year for co-packaged optics. Between these 4 companies, Renovis, IBM, TE, SEMICO. So our contribution to there is our optical interconnect technology and all of our packaging, co-packaged optics. Okay, so how much time do I have? So if we take a look at,
I think you're 5-6 minutes is okay.
5-6 minutes, okay, that's good. So let's take a look at the fiber technology itself. So if we look at this test vehicle here, I've taken away the rest of the package, so it's easier to see, fibers coming onto the PIC chip. We've been using 12 fiber test vehicle to show some scalability. So basically, the edge of the PIC chip has V grooves. V grooves are well known, and those will actually self-align the fibers to the mode converters that are at the end of the V grooves here. So it's a fully passive, so it's not active, and it's even more than passive. It's actually a self-aligning process. So the V grooves will self-align the fibers there. Here's an image showing more in a package where this chip here is flip chip to the backside of the substrate, and we have an opening here where we can access the fiber attach regions. The chip technology is coming from Global Foundries, so they're a leader, one of the 3 or 4 main fabs for silicon photonics. So we work with that technology. As I said, it's passive aligned. It's these other elements are more on the chip level, but it has a wide spectral range, so it's good for coarse wave division multiplexing and whatnot. One of the main elements also is that this assembly process is used doing high-speed pick-and-place tools you generally see in microelectronics. So it's part of what I mentioned earlier. We want to leverage the microelectronics, which has low cost, high volume, high automation. So the actual alignment, so you can be quite far off the line. The fibers are all loose; they're not held in anything. And the V groove will actually realign them. I have a short video here. You can actually see. So you're looking at the PIC, you're on sort of the top of the PIC chip looking down into the V grooves, and hopefully this will work. And you can see the fibers are off aligned quite a bit, and they just nicely reposition themselves into the if you do a tolerance analysis of the manufacturing tolerances of the V groove, of the fiber positioning of the core to the cladding concentricity, you'll see that you'll have approximately a 1 micron alignment between the core, the fiber, and the mode converter on the chip. So everything is designed to be able to accommodate that small amount of offset. Optical coupling. So here's some data that was presented at the JSTQE journal. There's a lot of better, newer data, and that can be shared in CDAs with us or Global Foundries. But some pretty good peak performance in TE of 0.7 and 1.4 in TM. So obviously we're not hitting the sub half micron that people use in telecom, but this is for high volume, low cost products in the datacom. So these are the type of numbers that are acceptable for that industry. Solder reflow compatibility. So that's something that we have that I have not seen anywhere else. So our fiber attach process can go through 250 degrees C and still be good. Basic key to that is these V grooves, because the V grooves hold the fiber in very securely. And we're using what we call a dual adhesive concept where we have structural adhesive for the fiber and optical adhesive in the optical coupling area. This can be, there was a presentation done by one of my colleagues at Photonics West in 2019 on that. Reliability, so reliability, and this is just one element through CDAs or NDAs, we can share a lot more, but the two main elements that people are concerned about, obviously, is thermal cycling and damp heat. So thermal cycling, so the Telcordia spec, going up to 85, and even the JetX, that's all the way up to JetX, because with co-package optics, maybe that's going to be important. We did 1,000 cycles each and 200 hours of damp heat. And what I'm showing here is the change in insertion loss before and after stress. So 0 would be no change. So there's a small oscillation around 0, which is pretty much in the measurement area. Error variability. Reliable. People are interested in taking a look. There's an assembly video that we did in 2019 at OFC, so a promotional video that's on YouTube. So I'll take a look at that. I won't show it here. And then I'll finish off with our compliant polymer technology. So an alternative to the fiber in V-groove. So basically, you have a polymer photolithography of all of the waveguides within there. You can kind of see it over here. So it's one piece, very scalable to a lot of channels, and it's only one part that you get to assemble. Very efficient. It has all of the same features as the fiber stuff. It's passive alignment, self-alignment. It's done using standard pick-and-place tools. Some of the other advantages is its waveguide density. So our test vehicles are done at 50 microns between the actual physical waveguides versus the fibers, which are at 250 microns. And this can actually go even lower than that. And compliant material, so it's chip package interaction risks. And just about finished. So the ecosystem, so there's a lot more detail I can give on the polymer, so if people are interested, they can always contact us. So the ecosystem, so AMF is the wafer fab producing those chips designed by CMC Microsystems here in Canada. Asahi Glass is providing polymers. Furukawa is providing the ferrules in the attach process. The ecosystem is set for that. We're developing right now a demo that might look something like this for early next year. And some of the optical coupling results are really great. I can't talk about them just yet because they've been submitted for a publication that's coming. So in conclusion then, so the key messages are get packaging involved early on. I think that's key. And the IBM's packaging technology is really well positioned for the co-packaged optics with our experience in microelectronics, leveraging that for our photonics. We have a one-stop shop, so we right from the beginning to the end, all the microelectronics and photonics and our innovative optical interconnect technologies.
Thank you very much, Paul. Merci beaucoup. Thank you for being with us in this beautiful meeting. It's been crazy. Always I ask the same question. It's not very new for you then. 572 companies here. What can they do for you? What can you do for them?
Well, what can we do? We offer, obviously, our services are for packaging. We don't sell products, right? So if any company has products that they need to sell that have a need for both either microelectronics or microelectronics and photonics, well, we're I think a site that has the technology, the experience to make these things happen. So, yeah.
We have 2 questions in the room for you and 3 minutes. So let's see how to make it happen. The first question is from Bob Musk from Entropics. Bob, what's on your mind?
Okay. First of all, thanks very much. That was a very interesting presentation. I had some contact with IBM about 2 years ago about your packaging capabilities because I was particularly interested in the SMT capability and BGA products for the future. Not seen too much in evidence of late. Have you got any comments? Are you seeing more interest in BGA, SMT, photonics?
Yeah, so as I showed, we have our technology is compatible to BGA reflow, right? So that's one of our advantages. So I think for the co-packaged optics in switches, I don't really see that much need there because I think people want to use sockets and stuff. But what I showed, someone's doing a lot of, yeah, that'll be better, Jose. But in the other application space, so where we have these optically enabled devices or, you know, one unit, those, you know, either you have a CPU in there or an FPGA or whatever, those ones I see more of a path to those being BGA reflow. Because I mean, in the co-packaged switches, when you have to put 8 or 16 of these things on a big MCM, all the rework processes are not that simple with BGA. But in the smaller devices, yes. So if you have smaller devices that it makes sense to do BGA reflow, well, our process is compatible with that. So
the second question, Paul, comes from FICONTECH. Greg, what's on your mind?
Hello, Paul. Thank you for your talk. I know we're talking to IBM, and we have a mutual partner in the form of C2MI.
Yes.
Just curious as to how much of this development work is together with C2MI in Canada, which is also located in Bromont, and your partners, right? So.
Yeah. So right. So like I showed in my chart, that's the dedicated development center that's right beside our site. So, I mean, our work, we use that site to do all of our development work. And obviously we have collaboration projects with C2MI and a lot of the partners of C2MI. Our personal work and our technology is IBM's IP. So, yes, and we use FICONTECH tools in the C2MI to do our development work, definitely. But
fantastic.
C2MI, so, yeah.
Thank you, Paul. Thank you very much. And Greg, thank you for a great question. Great to have collaborations in the room. We continue. It is 4 o'clock. We are right on time today. We go to the next presentation, NKT Photonics, all the way from Denmark. Basil is one of the people who is making a difference in the photonic industry at large. It's great to have you with us. It's great to have you also in the board of directors of EPIC. It is your chance to rule the world. The word is yours.
Okay. Thank you, Jose. Good morning, good afternoon, good evening to everyone who is listening to this. It's a great honor to be on this EPIC 24-hour World Photonics Tour. This is something I know the team at EPIC has been working really hard on. It's good to see that so far everything is worked on time, and I'm on it. Exact time. So Jose, you're doing a great job. I'm amazed you're still awake, but you know, keep it up. You got another, what, 20 hours or something? But welcome. So what am I going to talk about? Let's talk about NKT Photonics. What is it that we do? As a company, we solely exist to provide solutions to innovators. That's our raison d'etre. That's why we are operating. That's why we are all over the world. We provide solutions for people working on early disease detection. We provide solutions for people who manufacture smartphones to enable them to calibrate and measure detectors. We work for solutions for quantum computing, quantum cryptography, quantum communications, anything to do with quantum we're working on. It's a great area. We love it. We work on solutions for people working on cancer and other types of medical research, stem cell research. We're even working with entities working on research on COVID-19. We work for solutions for renewable energy. Green options, a big thing in Europe. It's a big thing for our sister company and NKT Cables. Great place to be. We also work on solutions for people working on space exploration, etc. Anything to do with avionics is something that our products and solutions are greatly working in. Looking at one of the areas that we like, and we like a lot, and we concentrate on, is in medical solutions. We've worked on people working for a cure in cancer. One of the researchers using our products, our white light laser, won a Nobel Prize. That's a great honor. It also means if you use our lasers, you're more likely to win a Nobel Prize. So carry on. We're working on helping cure cystic fibrosis. Cystic fibrosis is a terrible disease. Average lifespan of people who are blighted with cystic fibrosis is under 40 years. We are enabling our researchers to work in vivo scanners with all kinds of resolutions, right down to cell levels. It also helps designing drugs. We work on solutions enabling safer eye surgery, whether it's in cataract, whether it's in LASIK, whether it's in other forms of eye surgery. What our products do is enable a speedy recovery, a safer type of surgery, basically improving the solutions for these researchers. So NKT Photonics, what markets do we play on? Just mentioned quite a few. If you look at our business, most of our business, 70% is industrial. That is changing. Life science and medical today is only 15% of our business, but growing at a much faster pace. The same as aerospace and defense, about 15% of our business, but growing at a much faster pace. Again, for this presentation, what I'm doing is concentrating a little bit more on the life sciences, and we'll go through a little bit more of what we do there. The products we offer in these segments are fibers and modules. I think a lot of people who know NKT Photonics know us from our fibers. We've been doing this for over 20 years. We are the premier manufacturer and producer of photonic crystal fibers in the world. We produce guide fibers, we produce gain fibers and modules for all kinds of industry. That is our core technology. That's what we built on in our growth in the last few years. We manufacture lasers, all kinds of lasers. We're very well known for our super continuum lasers, our super K lasers. Obviously for ultra-fast lasers, of which a super continuum is a version. And we're also known for our Coherus line of single frequency lasers. And on the sensing side, we are also on the system side. We provide linear heat detecting systems, DTS systems. We do power monitoring. We do strain monitoring, strain sensing. Again, systems are sold throughout the world. We operate in a global market. As you can see, probably close to 60% of our business is Europe and will continue being Europe at the moment, but we are growing in other areas. We're growing in the US and we're growing in APAC. We have over 400 employees at the moment. Our revenue in 2019 was 75 million euro. We grew 10% last year. Our headquarters are here in Denmark, in Birkerød, just north of Copenhagen. But we have offices and manufacturing facilities in Southampton in England, in Boston, Massachusetts, in Zurich in Switzerland, and we also have a facility, a couple of small facilities, one in Berlin and a larger facility in Cologne. Let's talk about one of our main lasers at the moment, which, as I mentioned, is our supercontinuum white light laser. This laser is a pulse single mode laser with the spectral coverage of a lamp. It works anywhere from 390 nanometers up to 2.4 microns, a great laser. It has a brightness many orders of magnitude above lamps and LEDs and other forms. It is a laser that can deliver the pulses through fiber, great thing to work on. It's very robust, has a long lifetime, which is in over 10K of hours. And the cost could be anywhere between 5,000 and 50, and actually up to 100,000 euro. 5,000 for the larger OEMs that we sell into, and obviously for the sort of more advanced 1Z, 2Z prices tend to be in the 50 to 100K. The applications of our supercontinuum lasers are again, mainly in cellular research. We work in microscopy, we work in flow cytometry. A lot of the researchers and entities and OEMs use our lasers for early disease detection. It works in ophthalmology for early disease detection and for both Alzheimer's and diabetes and other similar diseases. Obviously, imaging in all kinds of eye diseases can be done using a supercontinuum laser. And obviously, cancer detection is one of the big ones that we work for. Work in endoscopy, all kinds of robotic surgery, laparoscopy, surgical elimination, etc. A great tool, a great laser. So what does it do? The laser, the supercontinuum laser, enables many imaging techniques. In OCT, it works wonders in cardiovascular and gastroendoscopy, in ophthalmology, dermatology, and in ultra-high resolution and deep tissue penetration imaging. Microscopy, where we well known is in confocal. I think that's one of the first OEMs we worked with a partner like Leica. Work in STED, we're working in scanning laser ophthalmology and in wide field visible light imaging. Spectroscopy, again, many applications, spectroscopic imaging, hyperspectral imaging, and near infrared wavelengths right up to 2.4 microns, which enable all kinds of deep tissue penetration. And obviously there are other imaging applications that we also work on. So why use the laser? Why use a supercontinuum laser for medical imaging? Flexibility. It enables a vast array of imaging techniques. It's a great tool. The spectrum is pretty wide, anywhere from full visible plus near infrared. It has very high brightness, very low heat in applications, a great tool to be used. The lifetime and the total cost of ownership is great for this product. Again, competing head on with lamps. At some point, we know they will replace lamps. We're also working in vivo imaging. Again, working in fibers and everything else enables that technology to advance to a great place. So, I don't know if I'm gone too fast or too slow, Jose.
You're always perfect pace.
Oh,
perfect
there you go, there you
fascinating.
go. So finally, you know, in partnership with us, you know, what do you expect? What we offer is some of the most advanced technology, especially in white light lasers and other similar technologies. We have a great team. We have quite an advanced team all over the place. We have a great amount of integration and system knowledge out there. You know, we're out there to help you. We're out there to find those solutions. What we're looking for is all kinds of partners. We're looking for system level partners. We're looking at companies who look at our products and say, yeah, you know, I have a component that will make this product better. Obviously, that's what we're looking for. We look for that all the time. And more importantly, we're looking for application specialists and researchers in the fields where we want to operate. I think that's the partnership we want to do, because we want to make a difference out there with our products. Thank you.
Thank you very much, Fastly. Thank you for a great presentation for me. I think I told you in person many times. I think you must be tired of hearing me saying this. You are an inspiration. Because from an idea of a fiber, a very, very good idea of a fiber, you built a multinational. And not only that, you actually said, I can illuminate the spectrum, 300 nanometers to 2.1 micrometers. This is the engine. This is the engine. Put it there, index to your patient, and there you have the source for OCT, you have the source for Raman spectroscopy, for reflectance spectroscopy, for mid-infrared sensing. This is the way that we make innovation with photonics. And that for that, I am so happy. I'm so happy to have a company at NKT that is actually inspiring so many others. But one thing that I noticed from NKT in the last years is that you have been more open to collaborations, but also more open to acquisitions, more open to help other companies grow, and more open to build an ecosystem around you. Did I get that right? Are you trying to help others also grow, or maybe help others help you grow?
Absolutely, absolutely. And you know, the whole essence of NKT is partnerships. You know, you don't get anywhere by just looking inwards. We also grow by acquisitions, and we have done in the last couple of years. But we're very focused on what we're doing. You know, we're very focused on being a fiber laser company, and a fiber laser company that makes a difference. What we don't want to do is compete on a larger scale with everybody and get to sort of head to the lowest price, etc. We're looking at more innovation out there. We're looking at where the laser really makes a difference. And, you know, to be a European manufacturer, and especially a North European manufacturer, we're looking for specs, we're looking for innovation, we're looking at things that really make a change, a real sort of change that has to happen there. And again, you don't create that standing alone. You need to have an ecosystem in there. You need to have access to the best technology out there. We sponsor a lot of students. We sponsor a lot of PhDs. And again, you know, it's a bit selfish because, you know, we hire most of these guys as well. And, you know, if you walk around NKT as you have, you'll see there are many, many nationalities. You know, we're very proud to have all these nationalities in languages and everything else in the company. It's a great way to exist. It's very collaborative. It's exciting. We want people who come to work to be excited about coming to work. You know, it's creating that ecosystem. And it starts sort of growing. You know, you start watering it, you add things to it, it starts to grow in a nice way. And I think that's also, you know, to look at what EPIC are doing. That's exactly what EPIC are doing. You know, they're bringing these companies together. You know, what we don't want to be is like some of the other associations and just making money off the guys because we have a big show or something like that. And what we're really trying to do is help our members. And I think that's one of the main things that we see here in Europe. We did not have that. You know, we were always, well, ever since I've been in this industry, which has been getting close to 40 years, but we've always been the sort of, you know, the poorer cousins in the photonics industry. And, you know, it's great having an association that brings people together, that gets them to collaborate. There is so much work done in Europe. There's so much research done. There's such bright people in Europe.
For me, one of the things that impressed me the most, we are giving each other compliments. That's how we play it here. One of the things that I love the most about NKT is for many years, you were established as a supercontinuum generation laser manufacturer. People know you very well, know what you could do. And suddenly you said, want to build a nice laser? Go to Thorlas and buy NKT fiber. We sell it there. Just build your own. If you think the fiber is the secret, go there. People tell you, oh, that fiber is great. Of course it's great. It can do fiber sensing. I make a company or make part of the company doing fiber sensing. What I always have seen from NKT is helping others innovate with your learning lessons. And that's why I am such a huge fan of your technology. And now you tell me, quantum Is it really quantum the next big thing, or is just a hype? Where do you stand on this?
It's a place we really believe in. Ask me again in 5 years' time. It might be a hype, but I don't think so. I think there's a lot going in there, and I know that it's getting a lot of funding. It's getting a lot of funding in the US. The joke in the US is if you want government money, just put the word quantum in every other paragraph, and you'll get the funds. It's a big thing in China. It's a big thing in Japan. It's something that we're beginning to see what people are working on. And we're selling lasers in there. Some of the first commercial quantum lasers, quantum computers out there are using our lasers. It's great to be there. It's great to be pioneers. Will it explode and be, the next telecom? I don't know in the next 5 years, but certainly in the next 15 it will.
Well, to be honest, I'm not sure if it's a hype or not, but what I do know is because of the quantum money, we have fantastic 400-ish nanometer lasers, fantastic single photon detectors for single photon LiDAR, fantastic single photon sources, fantastic coupling on silicon photonics with no losses of a single photon. And this is why the innovation makes a difference. When money comes to photonics, and that's the message, no matter what brand you put in it, when it comes to photonics, we save lives. That's what Photonics does, and that's what NKT does. Thank you very much, Basil, for being with us. Thank you for this great presentation.
Thank you. Thank you, Jose. Keep up the good work.
Oh, it's easy. Just having fun here. And we go to the next presentation. We go to an icon on the laser industry worldwide. We go to a company I love a lot. In Ditzingen, you have Trumpf. In Europe, you have Trumpf. In the world, you have Trumpf. Berthold Schmidt, CEO of Trumpf. It's such an honor to be with you today. Thank you very much for being with us in this crazy adventure. It is 4:20 here in the Netherlands, the same time in Ditzingen. The floor is yours. I think, Dr. Smith, we still have you unmuted. Let me unmute you. Could you maybe unmute yourself? Yes.
I do. Sorry, it took me a while. First of all, congratulations, Basil, for the great presentation. I think I can only support a lot of the comments you made. And by the way, the lockdown helped you obviously a lot. You look fantastic, I must admit. So I think that congratulations to the success you have with NKT right now. So first of all, Jose, Carlos, I'd like to thank you for inviting me in to join here the tour, which I happily accepted to present something from Trumpf. I was dancing a little around what I can provide and what makes sense, but I think I'd try to give you a little an overview of the developments in the latest developments in the high power laser processing. And to do so, let's see if I can. To do so, I talk a little about the global laser market more from a historic perspective, because I think we shouldn't look at all the weekly changing information we receive right now due to the corona impact. And then I take you a little to a stroll along the road of intensity with a few examples of our development activities, always in relation with some application and of our systems. And then I think I close with some remarks here. So you see, we tend at Trumpf to look at technology more in years and decades. And I think it's important to realize that the laser technology or the laser systems market experienced a fantastic growth over the last 9 years with more than 11% CAGR year by year. And this is mainly dominated in the material systems processing market with high power laser systems or systems that relate to high powers above 4 kilowatt, which is naturally a sweet spot for Trumpf with the disc and fiber lasers to play in. I think you see also, and that puts a little a dark shadow on the market, that after this big increase we had in 2017, that there was actually a consolidation that is now going on even without the COVID impact over the last, I would really say 2 years, and you see this from various companies in their communication, that there is a slowdown a little in the market, and we really hope that with additional technologies, with additional innovations, we try to drive up the market soon after this crisis has been over, and I'm sure we overcome that in the future again. Talking a little about TRUMPF, not to the extent as Basil talked about MKT, just a few things, because I think most of it is known. It's a family business, still run very efficiently by the Leibinger-Kammerer family. We have here 2 business divisions where we consider ourselves being leader in the machine building machine tool building system and the laser system area. I think we are also a company who is continuously driving innovation in a very holistic and constant way. And also we want to stay close to our customers, which is very important because we have a very well distributed revenue all over the world. And therefore we are working out of 70 subsidiaries worldwide. So for the engineers and the scientists, I put from revenue development a little on a log scale, and the development of these of the revenue is naturally from a laser perspective, accompanied by multiple innovations we have introduced over the last decade. Starting with the first laser punching based machine in 1979, all the way to, and that had already a 500 watt laser, CO2 laser included, and then from started to develop their own multi-kilowatt laser systems with the folded cavity CO2 laser released in 1989, which is actually still interesting enough the base architecture for today's EUV light sources, where we provide the CO2 laser as it is shown here on the right side. Naturally, we also added a lot of solid state laser technology over the last decades to our portfolio, led by disc and fiber lasers naturally, but also the integrated systems like additive manufacturing contributes now to the growth in our revenue. And now let's talk a little about technology. I don't want to hold up here with too much of the introduction on TRUMPF. So therefore I take you on a stroll along the laser intensity. So starting a little with CW applications and some interesting periphery elements. I skip details on the EUV this time, also due to time constraints, and rather make a few remarks on picosecond, nanosecond, and femtosecond ultra short pulse laser. I also don't go into the depths on our ultra high power laser systems for secondary sources and other forward-looking applications, also because I think we are just limited in time today. So talking about green laser, I think that's a great opportunity also to recap on a disc laser, which for me is a fantastic laser concept. It consists out of an ytterbium thin disc element that is more or less mounted here, as you see on the right side, on a diamond heat sink. In that way, with a cooler element, we have a very inactual heat flow. So we can more or less transform low brightness pump light coming from 940 nanometer semiconductor laser bars with a very low brightness of 450 millimeter millirad around into almost nearly single mode operation on kilowatt level. And therefore, I think the disc laser is just a fantastic brightness converter with high gain saturation in the cavity, and due to the thin disc, very negligible non-linearity even at high peak powers. I'd like to stay a little with the high gain saturation because for me, as I'm now responsible for the VCSEL business here in TRUMPF, the disc laser is like a macro VCSEL. You have the outcoupling mirror has a outcoupling reflectivity of 97%. So most of the power is stored in the cavity. So on the one side, the disc laser is very insensitive to back reflection, but on the other side, you can use it here with a green laser for interfrequency doubling by nonlinear crystal. And this is here in this way, since the crystal is placed in the cavity, very efficient. So we have a conversion efficiency here of 50% into the higher harmonics, since the efficiency depends quadratically on the intensity of the that acts on the crystal. And therefore, we can achieve here with this concept, as you see on the next slide, output powers in the lab of up to 4 kilowatt. Industrial grade, we have in the market right now 2 kilowatt output power, but already working naturally on higher powers to be released. Nice thing again is it's all coupled into a 100 micron fiber if you want, with 5 millimeter milliwatt beam quality, and that allows naturally also to combine it with our other periphery elements like the scanner optics to make a very dynamic and flexible welding system out of that. Now, green lasers is naturally important, in particular when we operate and act here welding copper, which is an important material with increasing importance in the electromobility side for battery production, high power electronics, and when you act with an infrared laser with a 1 micron wavelength on that, you see the problem is that we have a very abrupt change between a heat conduction welding process and a deep penetration welding process. You don't have this with a green wavelengths due to the higher absorption in copper with green, and therefore we have a very smooth transition between those two welding regimes. And if you think about that, we apply this here, for instance, as an example on welding a copper contact just with 2.3 millimeter depths, very exact and accurate to a DCB mount. And you see when the green laser acts on that, it's very smooth, very sputter-free. This naturally in slow motion, so the whole thing is happening in something like 100 milliseconds, as you see above. So our next application is naturally combining our laser technology with periphery elements. I think it's important we are strengthening our CW laser portfolio with those complementary units. And when I talk about periphery elements, I mean beam steering elements, beam guiding elements, optics and sensor systems, all smartly integrated with our electronics sensors such as OCT for industrial welding control. And how this works, you see here, classic application is naturally the production of electric engines for e-mobility. And here it's important to weld these hairpins and together. So in the first step, when they are put into the straightener, in the first step, the hairpins are cleaned, the surface, and with a nanosecond through micro laser. And then in the second step, we take the hairpins and weld it pairwise together with a multi-kilowatt disc laser. And we use an in situ OCT control here, really to have a very exact pre and post process control to assure super high yield production with this combined process. Now, making the next step and talking about our pulse lasers and their industrial applications, it's clear that our pulse lasers, as many industrial lasers, are used in particular in the mobile and handheld market. I think today there is no mobile phone anymore produced without the use of a laser in certain areas of the production line. Here you see, just mention a few examples. We have display glass cutting, foil cutting with ultra short pulse lasers, PCB drilling, and also then as a more large area laser-based process, laser lift-off for the flexible display industry. Another important application is naturally the laser application in the field of production of batteries to power the increasing e-mobility industry. And I think here the lasers are used for drilling, cutting, welding of foils. As I said, also here today, interesting application for the mixers, also in the drying process of the battery foils, which is also a very important process. So you see in all of those, we find lasers as an important tool for application. Our ultra short pulse laser architecture is actually built very modular. So we normally start with a seed laser that defines the important characteristics of a laser, like pulse duration, shape, repetition rate, spectral shaping. And then what we do at TRUMPF in a very modular way, we add amplifier stages that can be used as a single amplifier stage, but also in combination. So we are able to combine fiber laser amplifier with inner slab amplifiers and thin disk amplifiers in whatever is required from our customers. This is then followed by beam guiding elements, nonlinear conversion elements, depending on the required wavelengths. And then naturally very important for us as well, beam steering and beam shaping, periphery elements like scanner optics and our top cleave and top belt optics that are becoming more and more important in the industry. Now, if we combine these technologies, we more or less cover the required range that is important for the industry. So fiber, just pure fiber amplifier technology goes up to an average power of around 100 watts. And if you require more, then we combine the technology or provide the USP laser based on thin disk regenerative amplifiers, or then just with a inner slab laser technology that goes up to a kilowatt in average output power. And if laser powers above this level is required, then we just add thin disk multipass amplifiers on top of it. So in that way, combining the multiple amplifier architectures, and that then provides output powers in average up to 10 kilowatt. So if you think about buying one of these systems, and just that you see already that these are not research systems. Ursula Keller is said in one of her talks that they are characterized due to knobs and buttons. These are all systems are all computer controlled naturally. The True Micro Series 6000 here is an example. Is a slab laser based system with average output powers of 200 watt wavelengths. You can pick and choose from infrared, green and UV. Pulse width is also available between 500 femtoseconds and up to even 10 nanoseconds. That's not US ultra short pulse laser anymore, but they are available based on this technology. Pulse energies up to 2 millijoule. And the nice thing is here with the pulse frequency and the rep rate, we are very flexible, and those can be even dynamically adjusted up to 3 megahertz with a slab laser concept. So if we just go now towards the end of the presentation, just allow me to give you on the combination of our PRISM Award finalists of this year, the top belt optics in combination with ultra short pulse lasers, a few examples. So it's all about special beam forming technology to weld opaque and transparent materials. And these are just a few examples, like welding a technical glass housing here to our laser light cables as a finishing and or protection, or welding even glass to metal with this technology. Also very interesting application, welding solar panels, welding flexible glass to consumer electronics parts, watch industry. So I think here we have multiple applications, and if I start counting all the applications I've seen in the TRUMPF world so far, we would sit here tomorrow. So just a closing remark to wrap up. I think for OEMs in the laser systems such as TRUMPF, we must carefully leverage our investments. That is in this phase critical and important. So we have really to think about how to yield the maximum value for our customers. And I think we do this by supporting complementary laser amplifier platforms, again, in combination with tailored periphery elements. So we cannot do everything, even as a Trump organization with revenues in the range of 1.5 billion on the laser system side. But and that's why we stay very close to our customers to address key processes with industrial grade quality. And I think we, looking forward, I think by using those and by pushing forward those amplifier building blocks in the ultra short point regime, we can easily combine those also for future applications. I think this will be a fantastic time for all of us on the research side also, as we're going to open new horizons in terms of power level and rep rates with those technologies. And with that, I'd like to thank you and end my presentation.
Thank you very much. Thank you. It was so great to have you here. Everyone gets the same question. We have here 572 members. Many of them know you and know Andreas Popp because he keeps coming to all our events and scouting technologies that later are pitched inside. So for that, I would like to acknowledge that truth in EPIC. But what can they do for you, these 572 companies, and what can Trumpf do for them?
Yeah, I think at the end, we are all, I mean, it's naturally important to drive business, but at the end, we are also interested in the technology. And I recognize EPIC as an important organization, also having multiple of our partners on all levels, so suppliers and customers in the organization. So I think why we believe we bring the greatest technology to the market, we need always challenging, curious, but also forward-oriented customers and partners that explore these new technologies. And as Basil already said, that are eager to find new applications for these type of technologies. And I think that is what EPIC can bring to the market. And you're great in combining us at this organizational level. And Trumpf will for sure continue to support the organization, because we really also, due to the direct communication we can generate through EPIC, we take a lot of value out of it.
From laser optics to specialty fiber, even quantum technologies, every new thing that I spot, I always can pitch it to Trumpf and they always follow up with them. You've been priceless for the growth of EPIC. Thank you so much. It is 4:40 Bergholm. We go to SAIS. We go to Michael Totzek, we go to SAIS, we go to the capital of optics in Europe. I'm going to say in the world, we go to Jena. Thank you very much, Michael, for being with us this beautiful afternoon, sunny here in the Netherlands. The floor and the attention of everyone goes to your fantastic optics.
So you can hear me and you see the presentation?
We can hear you, we can see you, all perfect.
So thank you very much. Jose and Carlos, it's really an honor to be in this, EPIC event, actually, that you're doing here 24 hours across the world. So I really love it very much. And thinking about what to speak about, I want to share an insight with you. That is that optics and digitalization are very closely intervened. In fact, they mutually reinforce each other. So these two technologies are really closely related. But before we start, I would like briefly to introduce to you ZEISS. So what we are an enabler. We enable our customers to cram more transistors into an IC to ensure high quality production. The bottom here by our metrology instrumentation, the top by our lithography optics. So do safe surgery by our surgical instrumentation, do reliable research by a couple of microscopes. I will speak about this. Improve vision by glasses and by ophthalmic instrumentation. And last but not least, getting outstanding images by sports optics and photo optics. And all this together, of course, has also shown up in numbers. So 36 Nobel laureates used our systems. 80% of the microchips worldwide are made with ASML lithography systems, where ZEISS optics is a central part in. 50 ZEISS cameras made it to the moon, 10 Oscar-nominated movies in until 2019, and 15 million operations worldwide per year with ZEISS surgical systems. We are a worldwide distributed camera company with about 31,000 employees, 100 locations worldwide, distributed over 50 countries. And we are acting worldwide, of course, so our markets are more or less evenly distributed here, really across the world. So another very important fact is our innovation activity. So we invest about 11% of our revenue into innovation. That means more than 700 million euros past year. And we have something like 500 patent applications per year. So we are heading for 2 patent applications per day, a little way to go there. And the result of this innovation activity, by the way, is in fact digitalization. Digitalization, you know very much. You know that in 1959, Jack Kilby showed the first integrated IC with 5 transistors. You know Gordon Moore's law, that we have an exponential growth of the number of transistors per integrated circuit. So far, he thought that it's doubling every year. Later, he corrected to 2. In fact, the true value is about 1.5, 1.6, somewhere in between. And this exponential growth over more than 50 years made now to 10 billion transistors in a high-end IC, and in fact, 2 trillion transistors in a net memory. How could this have been achieved? Well, we made the structures smaller and smaller. And this has been done also, or let's say it was very key for this, that the optical systems have become better and better. The core of the process is projection lithography. You have an image of your IC and you project it on a treated wafer. And to do this with smaller and smaller feature sizes, we have in fact 2 levers or 3 levers. We can decrease the wavelength according to the resolution limit. We can increase the numerical aperture, and we can make the process factor better and better. For us, that meant that we had to introduce a sphere optics inside it. We have to introduce mirrors even inside the optics, so to get gutter dioptric lenses. And finally, now for the later steps, we moved into the soft X-ray region to extended UV, EUV. This means that these lenses are right now in vacuum and that we can use only mirror as an optics. And by the way, referring to Bertolt Schmidt, Trumpf, of course, plays also a very integral part in EUV optics. Because they are responsible here for the illumination. In fact, to really make this plasma source here, so to make the tiny drum droplet there explode, then we have here a couple of mirrors. They are guiding the light to the reflective mask. And then we have an optical system here that guides the image then finally to the wafer. And you know, mirrors are a little bit more difficult to align in space than lenses, unfortunately, but there is no way around it. The optical elements here are basically multi-layer coatings, and the aspheric mirrors here, due to the very small wavelengths of 13.5 nanometers, means that we have to polish them. If you polish the Earth with the same accuracy, you want to get something like a Mount Everest with 1 millimeter height. And that is the overall shape accuracy. And that whole system is then put into an ASML scanner together with the Trumpf illumination. And ASML, by the way, is talking, I think, 20 minutes past 6 about their technology here. So it's really that these 3 companies together then developed EUV and put it to the market. And that, again, what I said, means that we have a very strong drive to digitalization, more and more storage space. And that makes for our instrumentation a data tsunami of imaging. What's happening there? If you have a microscopy built in the old ages of the last century, you have something like about 1 megabyte. And then you increase here to 3D with confocal microscopy. You put a slide scanner, larger fields, spinning disk, even more confocal in parallel, SPIM, selective plane imaging. The whole thing in 3D and stitched together makes it up to 12 terabyte already. So we have terabyte data that we have to process. Why? Because of super resolution. So I will speak about this. The resolution limit, of course, has been beaten for medical imaging or biomedical imaging, 3D imaging, hyperspectral imaging, and even time evolution. So consider, for instance, here a super resolution system, the ZEISS ELIRA 7 with lattice sim. Lattice sim is a super resolution method where you have an object, you illuminate it now with a structured light pattern, you move this light pattern here, you take a couple of images, and then you can reconstruct the image with a much better resolution. We can apply in the same system, or we have present in the same system, a technology called single molecule localization microscopy. That's a super resolution method that goes together here with STAT, but this is more related to the one of BZHEJIANG, photoactivation localization microscopy. If you have an object like a string here, that is your point spread function, and you make a superposition, you get an image like this. But if you are able to make the molecules here fluorescent one by one, or at least in a distance larger than the resolution limit, then you can pinpoint exactly the center of the emission. And putting all this together with this localization technique, you are able to actually get the kind of resolution here. And that is now the fact in this instrument here, where you have a wide field imaging for comparison. Here you see the SMLM image. And here you see in this 8-fold symmetry of a nuclear pore that you are able to localize single proteins here in microscopy. This is a 100 nanometer bar, so we are here with up to 10 nanometers. That was a spatial domain. Now we have the time domain, which is very interesting in evolutionary biology. So here you use, for instance, a light sheet microscopy, light sheet Z1, for instance, from Zeiss. There you illuminate your specimen from the side, and you take the fluorescent light under a rectangular angle. And that means that you have no light loss here. So you're illuminating only exact the region that is fluorescent. That means less light in the specimen. Light for living specimen is deadly, but because of this, you get rid somewhat of the phototoxicity. That means your specimen live longer, like this Drosophila embryo here, for instance, for 4 days. All this puts together makes this huge amount of data. So again, a few terabytes of data. In electron microscopy, you can take the Zeiss multisem. That means up to 91 electron beams that are working in parallel. Taking a parallel image, then it looks like this, the image, for instance, here of an integrated circuit. And all these are here single images stitched together. And that means we have a data rate of 1 gigabyte per second in this image to process. But what we are able is to acquire this whole field of view here of almost 200 times 200, something less, in 1.4 seconds at 5 nanometer pixel size. So again, we have to cope here with terabyte images. Now we have this digitalization, all the ability, of course, to take the data and to store the data. The interesting part now is, heck, what to do with the data. This is much, much too much in order to work with it, really. And now comes a strong point of digitalization in terms of machine learning. So, for instance, take the part here that you have often when you are looking onto histograms. Oh, sorry, that was, So you have an input image here, and you want to now distinguish certain features. You want to do an annotation. You want to see what are cells that are here, for instance, these core of the cells or these cells here around it. These are distinct features inside that you need to distinguish finally in the image. Now you can let people do this, but at the same time, what you can do here is to do a much more comfortable annotation. So you can do a kind of a scribble annotation that says you give the algorithm an example. You say, hey, you know, this is the one part of features I want to look into. These are the other parts, please distinguish them. And that can be done now using machine learning. So you can have a segmentation-based machine learning algorithm. And this is able now to have a segmentation in these different classes. This is running automatically, I'm very sorry. In these different classes. And you can even then do here an interactive refinement by the user when the algorithm made an error. And all this together now allows you to propagate this learned region here to the entire data set. With that, you are able to make an annotation for an entire data set. And the product behind it, it's called Zeiss Zen Intellisys. That's a machine learning product that allows you to use this annotation in a rather automated and very convenient way. Another interesting part about digitalization is that it enables really here new business models. We tried this here by providing an online platform for collaborative microscopy. This is called Appear. And there, for instance, you can really store your Intellisys model, and you can then provide this Intellisys model to other customers, to other people, so that they can work around a kind of a collaborative approach. And that, for instance, enables you to take solutions that have here been taken, for instance, for evaluation of boons, to evaluation of materials, like here, for instance, bristles. So we have Intellisys as a kind of a machine learning platform, and we have Appear to provide the solution space for the Intellisys platform. Digitalization in our markets moves even further, for instance, to the medical market. If you go to what we call a fundus imaging, this is a back of a retina, and you can take a camera and take a photo of the back of the retina. And there is now a huge trend to do this in a mobile way, for instance, in developing countries. However, the people doing this, they are not experienced there. So instead of taking an image like this, they take images like that. So what you would like to have is an algorithm that says you, oh, please forget this image, do it again. And this is done, for instance, again, with machine learning. But machine learning can help even more. Machine learning can help you here to evaluate these images, so to give recommendations to the physician, so that you're able to evaluate here your retina. This is, for instance, an OCT scan across the retina to see whether this is a healthy retina or not. Or what we can do at the same time is to have a quantification of retinal lesions. These, for instance, happen if you have diabetes, and they have to be detected very early to see whether diabetes is going here in the eye in a critical stage. But of course, these kinds of evaluation technologies at the same time can be used to check our mirrors for dirt, scratches, and anything else. So we can use it to make sure that the mirrors in the EUV system or our lenses are really working properly. And of course, we can use the optimization methods worked out here for this kind of technology. Last example, and then I'm through, is you can also use this in the consumer markets. The Zeiss VisuFit, for instance, you might find in 1 or 2 optometrist store, it takes 9 images of a head. And from these 9 images, we calculate the complete 3-dimensional image of the head. And then you can use this to make a better frame fitting, because the angle of the spectacles here is also important for the quality of the images. And of course, the centration is very important. So with machine learning algorithms, we are able to detect really the glasses here, so the boundary of the glasses, and to find the center of the eye and so on. So these are all technologies that are here now to help the people who use our instrumentation, what to do with it. And now, since I know Jose loves challenges, what in fact are the challenges here? Well, one of the major challenges is that first of all, 2 major challenges. We need a scalable annotation. Annotations can be wrong in machine learning, by the way. And when the expert makes an error, you don't want to have this expert in million examples elsewhere. And one of the biggest challenges, by the way, and that is really a topic of research in machine learning, is to make it explainable. If you want to use machine learning really for diagnostics, and you want to derive treatments out of it, you have to explain why this machine learning algorithm works. And that is something that is, to my knowledge, not yet really solved. And that is very important, also, by the way, in automotive industry and so on. So we need to understand machine learning much better. So what I wanted to explain to you is very simple. Optics and digitalization, they are so closely intervened with each other, but they are really giving the whole field a new boost. And I think there will be a lot of ideas and insight in this new boost. And with that, I thank you very much for your
Thank you so much, Michael. I thought I had the most energies in the photonics ecosystem. Now I realized I'm second in command to you. It was a really great presentation. And I had to tell you one thing. At 6:20, we have Humberto Emanuele from ASML. And we're going to talk a lot about the deep UV system that you had in one of your slides. But now, first of all, you get a question from ST Microelectronics. Eric, thank you very much for your question. What's on your mind?
Yes, we have seen your presentation and the development of extreme UV. So that's good because we have now, let's say, a tool for the next 10 years.
Exactly, it's now in the market.
Yeah, but what's next? I mean, the roadmap will not stop in 2030. So
yeah.
What are the next challenges? I mean, apart decreasing the cost of your tools.
So what is the next challenge here? It's quite clear now with EUV, we are on the road again. So the classical road in lithography means that you, from the point of view of an optician, of an optics company, we make a change of the wavelength. And when we make a change of the wavelength, then the next step is to increase the numerical aperture. So, and this is what we are very used to. We did this for DUV, we did this for 248 nanometers, we did this for 193 nanometers, and we are prepared to do this for EUV as well. So find methods to increase the numerical aperture to make it even to smaller structures. And then, of course, what is also inside is, I didn't speak about it, these are methods like super resolution imaging also in lithography that you have there that you can also use to get to even finer structures that are still used right now, as you're surely very well aware.
Thank you so much, Michael, and thank you, Eric, for a great discussion. And you will see what is happening now. For those of you who love high-power lasers, we're going to have a user presentation. There is a company in Europe, a company in the world, a company in Spain that manufactures process for making the wings of the Airbus planes. M. Torres is one of the big users of high-power lasers, and Xavier is here to tell us how the EPIC community can help M. Torres be even better than they already are. Xavier, it is 5 o'clock here in the Netherlands, also 5 o'clock in Spain. The floor and the attention of everyone exactly on time is yours.
Okay, thank you very much, Jose. I'm very glad of being here. Thank you for inviting me and M. Torres to introduce our technologies. So it's a pleasure, and let's start with it. Okay, let's see. How you see?
Xavier is an expert. He already knows how to share the screen. Everything is under control. Slide share. The floor is yours.
We will see at the end. Okay, so for those that don't know our company, we are manufacturers of heavy machinery for the production of aircraft structures, all kinds of structures in aluminum, in carbon fiber. We're talking about fuselage, wing assemble, vertical tape plane, milling, and formation with carbon fiber layers and so on. So during this presentation, I will try to show how we are using lasers, and at the same time, you will see the kind of machines we are producing and how the laser technology is helping us in the past, now, and in the future. Okay. So I will divide our processes in 3 big families. One is assembling, and another will be the layup. You will better know when you will see the images what is this technology about, and other processes where the laser is helping us to achieve quality and so on. Okay, so basically when we are talking about assembly planes, we need to be very precise in placing the different parts we are going to connect in a big environment. So in this case, for example, we are seeing a couple of wings that need to get together. So laser allow us, in this case and in many others, to really know where we are, so we can measure with different targets placed all over the facility, and really know how our wings, in this case, for example, are placed in coordinates and in orientation, so we can make a best fit and put everything together. So laser is there to tell us, to give us this information. If not, it would be impossible to move in such environments as you can see there, and really place all this on the right position. So it's a very critical to do this process. We are using in commercial aircrafts, in military. So I cannot disclose the customers, but you can imagine we're selling machines for Brazilian manufacturers. There are not too many, so I guess you can know who are we talking about. I mean, Airbus here in Europe, Boeing in the United States. That now it's quite in a crisis, but we expect them to get on the trail again and do the best as they did. In Russia also, we are assembling the different parts of the wing of the EMS-21, and for all this we always need this technology, these laser trackers that allow us to place leading edge and the covers and the spars that reinforce the whole structure. Always need lasers. That's the case of a fuselage of a commercial aircraft. And once we have all the parts in place, then we can mill or drill the different components to make them together. For those that are familiar, you should know that we use riveting all over the structure to put everything in place. We can use robots as the one you can see there, that is climbing around the fuselage and drilling and riveting. In some cases, we can drill with robots that are drilling like doors or parts of the connection parts. So this is another interesting case where we need to drill the connection between these two wings, but before we need to scan all the areas that confound the everything together. So we need to scan the inner part, the outer part of different parts, and we make a customized machining for every single part. So we know what we are going to connect. We know the shape each part has in each case. So every plane is different in that sense. And once you scan it, you can machine it, and then with a tolerance of 0.3 millimeters, what is very tight in huge structures of 3, 4, 5 meters wide. It's quite strict tolerance. So with this kind of machines, we can access. We're talking of machines with maybe sometimes 40 meters long, with the rails, like the long part, and then 3 meters. 3 meters in, I don't know how to say that in English, like, I mean, quite big structures. So to get an idea of the complexity of the assemblies we do, there can be involved 27 parts, 30 parts, and all of them need to get best fit and in good position. Without laser systems, that would be completely impossible. That's an example of the milling. I told you that we are, after scanning, we customize the milling, and as you can see, there are some areas we are touching it, some others are not being milled, so it's perfectly fit to this 0.3 millimeters. Okay, so after measuring, as you can see here, the emoticon, we're gonna move to inspection. This is a system we have developed in the last few years to, I don't know if you are used to this technology, the carbon fiber. It's very critical to keep the material safe of all kind of problems, because we are producing the material at the same time we are placing the CFRP over the mold. So nothing can be let alone. We need to know if the gaps between toes are proper, if there are some kind of debris inside the layers, because this could be a big problem to our customers, because the quality of the system from the mechanical point of view could be affected. So with a camera and a system with laser. We can scan. At the same time we are producing the part, we are qualifying it. We are checking if everything is in its place and nothing gets uncontrolled. And there are many kinds of mistakes that can be produced. So many kinds of mistakes to be avoided, not to be produced. We don't want to produce mistakes. So that's the purpose of this system. And in this case, again, we need to scan the surface with a laser and a camera and map it. So this mapping is quite complex. We need to rebuild the image. So as you can see, the laser and the camera, how it's assembled everything in our head. Very restricted space, so it's not always easy, but we got to do it. And we get images like this where we have to rebuild the gaps because normally the machine is moving quite fast, so it should be very fast photos and rebuild. So we get a continuous, and then the neuronal network that we have programmed is able to recognize all the different kinds of mistakes and classify them, and then in a database to record everything. So the part is produced together with all this information regarding the quality. So we are producing quality and checking it online. This is an example of some force mistakes. Hopefully we don't produce parts with so many faults, but this is an example how the system is able to recognize all these mistakes and classify course by course and put it in place. So then the operator right there on the very first moment when the mistake occurs, he can move to the machine and if necessary to release one of the toes or whatever is required. So no waste of time. You can make your machine to increase the productivity, because productivity is not only to put material and construct the stack, but always part of the process is to investigate and to check layer after layer that everything is all right. And if the machine can do it automatically, then you're pushing up your productivity. That's, I will not put the whole video because I don't want to focus too much on that. But for you to see how is this working right online, you see this. It's good also to see how our machines look like. What we're talking about, they are structures of 5 meters wide, 40 meters long. We are putting the material on, you can see the rollers with carbon fiber. It's pre-preg in this case, so it's epoxy matrix with fiber, reinforced matrix, reinforced carbon fiber. And then you see how it's constantly generating all this data, all this information, and so we can know what are we doing with the material. Okay, so now let's move to what Jose likes the most, the power of the lasers. Okay, so basically, depending on the material we are manufacturing, we need different sources of heat. We can from infrared to laser, depending on how much heat it demands the process. So in the past, we have used many lasers, in some cases up to 3 kilowatts lasers, because you need to add a lot of heat to your material, up to 400 Celsius. So you need a really powerful source, heat source. Regarding the infrared, when you just need 45, 50 degrees, it's good. But we are getting to a point where even this technology is getting quite old to hit a normal pre-preg, because the inertia of the infrared is limiting us the homogenization of heat. Like in some moments, depending on the speed of the machine and the inertia of the light of the infrared, we can get limited to really control the quantity of heat we are giving to each single toe. So in this case, we would love to move forward and have a system based probably in laser that can be safe, because right now the infrared, one of the good things it has is that we don't need to protect our eyes with it, and we don't need to cover the boundaries of the machine to protect third people from the radiation. So if we could a safety laser source or something like that, or some other kind that can substitute the infrared, that would be nice. And to have control of single toes. So also with a tendency that now there is existing in the world to save energy and to be ecological. So the most energy you can save and to use the energy exactly where you need and when you need, that would be very nice. So I think there is work from our side in this sense. So any kind of idea or product that the photonics community can give us, that would be very, very good for us, and for sure we would study it. So this is just an example of high power, but as I say, only when we need high power and high temperatures, with in this case fixed optics or maybe you can have scanners, or we have used both. So you can, depending on the width of your head, you conform your laser source and optics. This is one of the last machines we produce with laser. In this case, we needed a high temperature because it was thermoplastic material. Thermoplastic, it's needs high temperature also, and has a lot of thermal inertia. So you need to give heat to it. And in this case, the great thing was that there was a feedback control. So we were following the temperature with an infrared camera and closing the loop with the laser and the sensor. So we could get a very good control of the temperature we were giving to the material. That's the machine, how it's working now. The laser, as you saw, this machine is based on a robot, a KUKA robot, and so it was quite tricky to send the laser source to the tip of the robot. And now you can see the thermal images that we use to measure temperature, and then to close the loop. Okay. Okay, here I think this doesn't work. Okay, so here it ends the topic, big power sources, and I would like to move to a concept we developed in the last years. This is an idea that came from the company to help aircraft manufacturers to orientate how they could build their structures to help to make it easily manufactured. Jose, stop me when you need.
I cannot stop you because I know what you're about to show, and it's so cool. Okay. So go ahead. I know this plane in one shape. Just go. Okay. So this is we try to make a monocoque structure, and it won the JEG. The JEG is a prize from European organization that is related to the compound carbon fiber and composed materials. So we got this prize because this monocoque was built with a robot. This is the second part of the manufacture. We manufacture in rings. Then we put all these rings together, and then we cover the whole structure with carbon fiber. So it's I mean the mold is easy to assemble, and the piece produced it's very good because it has no connections, no riveting,
and it's making in one part at the end, the outer part of the fuselage. This, we are very proud of it because we can send it to this competition and won it. The King of Spain visit our factory and was inside this aircraft. Indeed, the size of it is the tall of the king, so it's one of the conditions for the design. And our idea is that this concept can be extended to not only to the aircraft manufacturing, but train manufacturing or even pipe manufacturing or whatever other concepts that could be based on that. We really seriously think that it could be applied and reduce riveting and all this connection technology more associated to aluminum. So need new materials, I think, need new concepts of assembling.
I was fascinated, of course, with this technology, and I can see that you are aiming towards bringing it beyond the aircraft. But this morning, we had a presentation from GESTAMP, and they told us one of our biggest challenges these times is to do the welding of steel with fiber, with carbon fiber. And later we have actually realized that there is a lot of challenges in actually bringing new carbon fiber laser-based assembly process. Are you dealing with these problems as well? Are you looking for new solutions for welding of new carbon fiber manufacturers?
Welding right now, I don't have in mind. I don't have in mind this, but I mean, since if you need to weld, I guess you are talking about thermoplastic materials, because if not, it's not possible to weld. But we have worked with thermoplastics, and I think this is aircraft factory industry is going to move towards that, because you don't need autoclave, so you save a lot of money, and you can, if you can get quality parts. I think it's hard to get quality parts because you need to have a very controlled process, but probably aircraft factory industry will move towards that kind of materials.
Xavier, you have a lot of challenges from the industry. Many of the high power laser companies are going to want to contact you after this. Muchas gracias. Thank you very much, Xavier, for a great presentation. Thank you.
Thank you for inviting me.
And we continue this crazy adventure non-stop. We are in the same time zone, but we go very far away. We go to a beautiful land. We go to South Africa. We go to CSIR, and we want Henchar to tell us how we can do business with South Africa and how South Africa can do business with EPIC. The floor and the attention of everyone goes to one of the most beautiful areas in this beautiful planet. The floor is yours.
Thank you, Jose. It's good to again talk to you all. So today I'm going to cover more of the South African business, and I would like to share with you a selection of the companies that we have. Okay. Okay, so I'm from the CSIR National Laser Center Pretoria, which is a national research organization. And the outline of my talk is, I'm going to spread it around laser developers, laser system developers, and then optical systems and camera developers. Now, just a disclaimer, due to our limited time, I'm only going to have a selection of companies. This is not exhaustive. I'm only going to cover R&D being commercialized. There's a lot of research being done at universities that I just don't have time for within this time slot. So I'm going to focus on the industry now. So first up with laser developers, there are quite a few in South Africa. First up is Power Systems. They produce high energy atmospheric TEA CO2 lasers at 10 micron. And also high pressure ones for shorter pulses. So this was a South African company. It used to be called SDI Lasers. They were just below us in this building. And then they were bought out by Power Systems United States, but the laser manufacturing is still in South Africa. So this you'll see across the talk is that a lot of companies, we started here, were bought out, but are still manufacturing these systems within South Africa. And we still have the capability within the country. So they use these systems for isotope separation, and then as well for paint removal on aircraft, and that's in the United States. And they are supported by the Laser Research Institute, which is a university at Stellenbosch University near Cape Town. So they do research for them, developing new types of lasers that they then commercialize. Okay, so most of you guys know Hensoldt, so which is from Airbus. So there's also a big division of Hensoldt in South Africa, so Hensoldt South Africa. And these guys, they actually produce quite a few both diode pumped, diode side pumped, and flash lamp pumped lasers for designation and ranging. So they've got a whole selection of these high energy lasers that they produce, and they integrate those within larger optical systems that they also produce here in South Africa, gimbals, and for aircraft and for the Navy, and they also produce cameras still in South Africa, and they also make their own optics within South Africa. So it's a very large facility in Pretoria that produces both lasers and optics. And we work closely together with this company. Then my own company, the National Laser Center, so we do mostly R&D in laser development, and over the last decade or more, we've developed lots of technologies, lasers, specifically 1.9 and 2 micron. So average power up to 220 watts from a slab laser at 1.9 micron, and a 2 micron over 300 millijoules of output energy. So recently we've also started to focus on high power beam shaping. This is at kilowatt level, both static and dynamic. We've also built signal frequency lasers, and some interesting gas laser systems. And to the solid state side, we built multi-wavelength high power systems. So that's in tens of watts, over 50 watts of output at 2 micron, and it's about 10 watts at 4 micron, and a few watts at 8 micron systems that we've built here. At 1 micron, we've built high energy, high PRF neodymium yield lasers. And we are also now building fiber lasers both at 1 micron and at 1.9 micron. From an application space, we focus primarily on manufacturing systems, but also now on LiDAR and defense technologies. So we work closely together with Wits University, which is in Johannesburg, and the structured light group there. And they do really fantastic basic research. So they're on the cover of the latest Optics Photonics News magazine. This is of June. There's an article on structured light there. And the laser that you see on the cover there was actually built within our labs. So that uses metamaterials within a laser cavity. And this structured light of both the shape and the polarization of the laser, that's got multiple uses in communications. And of course, for us, what we are interested in is materials processing, but also optical tweezing, which we also do here at the National Laser Center. So laser systems developments, excuse me, I'm going quite fast because I don't want to leave anybody out. Well, we are also doing laser systems manufacturing. So we've developed one of the largest selective laser sintering machines in the world. So this has got a build volume of 2 meters by 0.6 by 0.6 meters. So this monster is standing in a separate building from where I am. And this is primarily to 3D print titanium components for the aerospace industry, but we're also continuing to build smaller machines to be able to do research for a number of other metal materials. And we're continuing to develop these additive manufacturing machines, both large and small, and to develop the technology. And specifically what we try and do is we try to up the laser power significantly to increase our speed. We're also developing polymer machines using different wavelengths of laser light. So out of this, a new company was recently born called Additive Solutions. So they are producing smaller metal machines at a much lower cost point than international competitors. And we are also working closely together with them on the optical systems within these machines, and they will be available for sale pretty soon. Okay, then another company that we're currently spinning out is from a group called Laser Engineering Services. It's also within the NLC. So they use powder blown repair services where they blow the powder coaxially to a high power laser beam, and then they repair tenons and blades for our energy company in South Africa, as well as other heavy metal or heavy industries like mines. So they go on site to repair very large components. And they've also in the past repaired one of the tanks at our nuclear facility in Cape Town, where they've actually welded that tank on the outside while the facility was running. So this is now currently being spun out of the CSR as a new company. We are also working together with TRM Supplies. So they are a company that actually they've got a lot of services, but one of the big services is to produce laser cutting machines for the South African market specifically. So they design these machines, they program them, so they control the entire design of these machines. They have them manufactured overseas and then import them to the South African market. So we also some very good technologies that are within this company. Company that you probably haven't heard of yet, but might have used their products is called Lightway LiDAR. A lot of people buy their products from other companies without realizing that this company is in South Africa. So they produce these micro LiDARs that can fit on drones and on cars and everything. And they, with a really cost competitive point that they come in, and they've got a whole range of these micro LiDARs that they produce primarily for the overseas market. So they've got some excellent technologies that they're selling all across the world to very big companies. And another company we have here similar is Redline Infrastructure. So they've got a product with making on free space optics, so free space optical communications between buildings. So this is their product over here, and that has got both a transmitter and a receiver in there to get secure communications between buildings, and they continue to innovate with our partners on improving this product offering. Then more on the research side again, we've got a facility at Hartbeespoort Radio Astronomy. And actually, they've got both satellite and soon lunar laser ranging there. They've got United States ranger there, as well as a Russian satellite ranger on site. And what they're also actually doing is they've bought Lithuanian lasers, and they've been donated a large French telescope, and then now they're setting up a lunar laser ranger to be able to range to the moon. So that's also really good work that they are doing there, and that's closely linked. The same company as the Square Kilometre Array, which is a massive radio telescope that they're building across Africa, but centered in South Africa. And this telescope also obviously requires massive amounts of data transfer of the data being collected, timing between telescopes, and we also have connections to this initiative, especially for epic folks in communication. Then optical systems and cameras, there's quite a few. I'm not aware of too much research, so I'm not going to. So I'm just going to cover some of the companies there. So I've already covered Hensoldt, South Africa, but there's another completely South African company that does something similar called Tower 35. And Tower 35 produces very good thermal cameras as well as gimbals and alignment systems for the security and defense industry. And so they usually come in at a lower price point than international competitors. Then Selsan is a company that used to be South African. Selsan is actually Turkish. But the production facility is still here also for thermal cameras and optics production, and they're also on the same campus as the CSR, and they also produce optics specifically for this company's products. Then you know Saab. So Saab Grintech Defence is also in South Africa, and they mainly produce missile warning systems and defence for aircraft, and they're also based in Pretoria, and we also work with them. And lastly, no, actually, there's a few more to come. This is a company called UVerco. It's the UV and infrared company. This is a spin out from the CSIR, and this company produces cameras to be able to detect any faults on isolators on overhead power lines. So the technologies that they've got here is to overlay UV and infrared images on top of each other, and they work in the solar blind region, so you can fly a helicopter or drive next to power lines and then look at the isolators, and you can clearly see if there's UV coming from it, that there's a fault on the line. So they've got a whole generation, like multiple generations of these cameras, and I think they've got about 40 to 50% of the world market for this type of cameras. And this is a success story from the CSIR, a good spin out where we developed this camera in-house, not in the National Laser Center, but within my larger organization, and is now producing some amazing cameras for the market. Moving on to a few smaller companies. Synertronic Designs are based in Stellenbosch. So they are predominantly focused on the research market and on spectroscopy, for femtosecond spectroscopy for universities and researchers. And they've got a whole line of products from line scanners and data acquisitions and spectrometers. They also do motion control and high voltage power supplies. So they also work with power systems on high voltage power supplies for designs for their lasers. So yeah, really, so they do custom jobs, and really helpful, and a lot of capability within this small company. And then we've got Chroma Technology. So they are a specialist optical system and design company that design lenses. So they design the lenses, they have them manufactured, and they test it, and then they will send them to you and train them out and train you how to use it. So we've also worked with this company in the past, and there's also a lot of capability within this small company. And then, if I still have time, I just want to highlight the facility here. It's just below me. It's called the Photonics Prototyping Facility. It is a facility where we want to take technologies that are usually developed and then, go to die within in that gap, where we just can't be commercialized. In South Africa, we develop these technologies using government funding, or we develop these technologies for local players, and we sell one or two, and then nothing ever happens with that again. So we want to take that further within the PPF. Some of the technologies that we've developed and that our partners have developed within universities, and then take it all the way to prototype and pilot production within this high-class facility. So it's got a number of clean rooms, basically everything that you need to commercialize laser and optics technologies is in this facility. And we're looking for partners to open the markets for us wider than our small isolated market in South Africa. So this is just some of the technologies, as I've already explained previously, that we have available, that we want to commercialize through this facility. This is personally from my group, and that is my presentation.
Thank you so much. I went to visit you. Of course, I visit everyone. I went to visit you in South Africa, and I have to tell you one thing. I was amazed, not only by the amount of innovation that I saw in the ecosystem, but also by the level of resources. I actually went to see your laboratory. I saw your sintering machine. I saw also the prototyping fab. What can EPIC members do to make that link between the innovation that's happening in South Africa and this great network they have here next to me?
So what we need is that we need to connect the African photonic companies and products to European and global markets. So a lot of the products that gets here, we can scale that to much larger volumes if we can get to the markets with partnerships. And we need partnerships to strengthen and develop business cases for new and/or existing ventures. So what we can do for you is we can add value to your products. We've got a lot of technology here. So specifically manufacturers of diode lasers and crystal and optic suppliers. If you want to add value there, then we've got the technologies here that are just sitting and waiting for new markets. We can also complement your own products. For instance, we can add kilowatt beam shaping to existing high power lasers. So you can better compete with your competitors. We can also add products we can also add your products to our platform technologies, like our additive manufacturing and remote sensing.
For me, one thing that I saw for me was very clear is that you have great experience as a country, great experience in imaging instruments for a particular application field, but you built for many years a great inspection and camera systems. And because you were focusing on perhaps defense security markets, these camera systems did not reach the volume production. And now we do have here partners for you that can enable such volume production to go to other markets. And the same thing happened with the high power laser manufacturers. On this, I really want to make more connections. I want to call all the 572 members. Herchard is super nice and he's representing great technologies. We have to make a stronger collaboration. And if you had the chance, go and visit South Africa. I will never forget that amazing experience. Thank you very much. It is 5:40. I'm keeping the time. We go to the next speaker. And in EPIC, we have great people, but some of them I call them champions. What do I mean by champion? It's a person that I introduce him to, and he always follows up with the company and sees whether this is useful for a major market segment. Eric is the champion of EPIC at STMicroelectronics. He always followed up with every introduction I ever made. Eric, thank you so much for being with us this afternoon. It is 5:30 here. I hope everyone will find a way of working with STMicroelectronics because photonics is a semicon technology. The floor and the attention of everyone in the world goes to you.
Your kind introduction. Maybe I'm muted.
No, we hear you. We hear you very well.
Okay, so thanks, Jose, for the introduction. In fact, we are member of EPIC since this year, and I have always been questioned by the different partners. But what are you doing, ST, in terms of photonics, in terms of optical, etc. So I wanted today to share with you. As fast as possible, but maybe we can have a separate meetings, what we are doing in terms of photonics. So first of all, a brief introduction of ST. I guess the vast majority of you know we are a company close to $10 billion, and we have more than 45 employees over the world. With one of our forces to have 11 different manufacturing sites, I will describe later. So we are a worldwide company established in Europe and in Asia Pacific, but also in US and in different areas where we have either front-end or back-end facilities or research and development teams. In terms of manufacturing, this is a ground base of ST Micro. So we are established in France, in Italy, and in Singapore for what regards the front-end manufacturing. So for us, front-end is silicon fabrication, and back-end, what we call back-end, is packaging, is assembly of small devices into the final package. And here we are established in Europe as well, in Morocco, in Malta, but also in also in China, in Malaysia, in all the Asia Pacific. So we are a company based on innovation. Let's say we have different, patents. We have a lot of patents regarding different applications. We have filed, for example, more than 590 patents last year, and we spend more than 15%, 16% exactly of our revenues into R&D. So this is a strong asset for us, the innovation. In terms of technologies, we have founded our, company upon different specialized or differentiated technologies. One of them, maybe the most famous, is fully depleted SOI, because it has been used a lot for low power devices. But we have also several different other specialties in smart power, in vertical intelligent power, in non-volatile memories. And also we are very present in MEMS for sensors, and also for optical sensing. We are using different technology, which I will describe. So what are our assets in terms of optical and photonic systems? So as a silicon company, we started with the way to process photodiode and to make isolation between photodiodes, color filters, microlens, etc. And we master now both front side and backside elimination. We have developed techniques to have a high quantum efficiency in infrared, and we developed also deep trench isolation. But on top of being a silicon manufacturer, we have also a strong team in terms of layout, in terms of design, and we developed several generations of rolling shutter and global shutter, high dynamic range and flicker-free devices. But let's say one of our recent success is in establishing the SPAD technology. SPAD so means single photon avalanche diode, which is the base of our flight sense time of flight technology. I will be back to this. Also, since a few years, we now master what we call wafer stacking, which is quite mandatory if you want to be present in this world. You have to be able to make bonding of wafers one to another. But we have also developed a photonic IC platform. I will describe later, capable of making different sort of devices. We also produce MEMS mirror, which can be used for a system, an optical system. We use a different type of actuation, either electrostatic or electromagnetic or piezoelectric. And we have also, thanks to our, let's say, big knowledge in packaging, developed several capabilities and very good systems for very small optical packages, which can be embedded into smartphones. So the size of the device is very critical. And last but not least, ST is also very well known for microcontrollers, and we can offer to our customers also a strong team for signal processing, and also we are working hard on edge artificial intelligence. So thanks to these different assets, we are able to grow significantly in the optic and optical sensing. I will describe later on which domains. But just to size the figure, to give some numbers, so it's now more than 20 years that we are established in sensors. So either optical or MEMS or microfoam or pressure sensor, etc. And we have delivered more than 19 billions of sensors up to now in different domains, consumer, automotive, and industrial. And now we will switch to some details about the optical sensing technologies. So in fact, in ST, everything started 20 years ago when ST decided to acquire a Scottish company. And then we started to, let's say, propose to our customers RGB cameras. So at that time, the customers were Nokia, were other players like BlackBerry. And so you know that these players have been, let's say, encountering some difficulties. So by 2010, we decided to refocus our capabilities on new type of optical sensing, and we started to develop time-of-flight applications. And we were quite lucky because, in fact, this type of application were filling a gap into the different smartphone system assemblers. And we recently, end of last year, we reached more than 1 billion system of time-of-flight delivered to, I think it's more than 160 different smartphones. So this is a huge volume produced. So what are we doing in terms of products and in terms of technology? So we are proposing different technologies to make depth sensing, either using structured light or using stereo cameras. And we have developed very small pitch pixels with a global shutter approach, with high quantum efficiency in near infrared. And also we have years after years improved our time of flight technology. And so this technology is used primarily to make a single point time of flight, but I will describe later that we are now capable of making multi-zone. So in the field of view, yeah, there are different areas which you can sense and get the information about the depth you are sensing. And in terms of technology, we have now moved to a 3D stacking technology with backside illumination using our 40 nanometer CMOS technology. But this is not the only devices that we are producing. We are also very present in ambient light sensing with different type of products for sort of, this is not hyperspectral like we have seen in the presentation, but more multispectral, different channels to range between UV up to near infrared with a very good sensitivity and what is very important is the size of the final device. And this is used, for example, for auto-white balancing in the current smartphone or for to detect the flicker of the LED illumination. So in terms of silicon technology, we were, we can say, pioneers in terms of isolation between pixels. We have introduced deep trench isolation back in 2008. And this is a great improvement in terms of optical crosstalk between the different pixels. And this is now widely used, including by our competitors. But more recently, we introduced capacitive deep trench isolation, which is another type of trench isolation with a capability to, let's say, master the voltage at the boundary of the device. And this allows also the creation of in-memory in-pixel memory, which opens the door to other type of application. In terms of SPAD, so I remember it's a single photon avalanche diode. We were one of the first to, let's say, introduce in volume this technology in 0.13 micron technology. And now we are switching to stacked devices on 14 nanometer technology. So in order to improve the size of the devices and also to master the digital content of this device, which is mainly a digital type of sensor. Also, we now switch, let's say, progressively the vast majority of our technology to bonding, hybrid bonding technology So this is a great step for us because it allows to, let's say, specialize the different wafers. One wafer specialized for pixel and one other for processing. So this is a great help to make small devices. Also, I mentioned that we have some expertise in terms of miniaturized optical module. You have here an example of a very compact device. It's less than 0.5 centimeters. So inside this device, you find the SPAD, you find the ambient light sensing, you find the VCSEL, you find all the computational information that you need to make a full product. So very small and very compact. In terms of 3D sensing, we are now, let's say, looking at different applications, both for wireless application and for consumer and industrial. For what regards the front-facing, one of very, let's say, known technology is for face identification. We are among the first, among the leader in that domain, and the other application is for world-facing, for camera assist and laser autofocus. So this is quite used to, let's say, speed up the autofocus of the system or to provide a bokeh effect on the cameras. For what regards consumer, we are working mainly using our global shutter devices for augmented reality and virtual reality, for robotics, and for any kind of smart home applications. So this is an example of a recent device that we introduced, which is an extension of our single dot illumination system. Now, thanks to the recent improvement, we are able to offer an 8x8 zone system, which allows, for example, the camera assist. You can select the region that you want to have the perfect focus, and you can also, for presence detection, you can see a larger field of view and detect if the PC owner is present in front of this device or if someone else is looking at the screen. Regarding the global shutter application, so we are now entering the automotive mode because this is now a new regulation that will force every car maker to have a driver monitoring system. So we have developed specific devices, 2 resolution, either black and white or color. And we have here a global shutter plus high dynamic range, plus strong, let's say, sensitivity in the near infrared. And also, as I mentioned in my introduction, all these devices are benefiting from our expertise in terms of in terms of system integration, and we offer different packages to make a real product or to make a prototype. Then I come to our manufacturing capability. We are offering also our fabs to have access to our fabs for imaging in terms of foundry, but this is not a foundry like you can find in the South Asia, but we are more focusing on high-end premium services for our customers. And we offer these capabilities both in our 8-inch and in our 12-inch facility in Kroll. Then I switch to, because I'm late, I switch to the silicon photonics. So silicon photonics, we have developed a technology which is very versatile because in one wafer, you can run both SOI, so wavelengths in the range of 1.5 micron and over wavelengths using our silicon nitride waveguide technology. So you are able to make a different type of active or passive devices. And we are also having silicon germanium diodes into this system so that we can realize different systems or different parts of a photonic system. And this is very helpful, and we benefit from our technology using immersion lithography from our friends from ASML and ZEISS. And so we can offer very good roughness of the waveguides and very good performances. But this technology was initially devoted to datacom applications, and now we are refocusing this application to more than what we call more than datacom. So for biosensing, for LiDAR, for gyroscope, we are investigating these technologies or these future products.
And that's the message. That's the great message, because we heard so many times silicon photonics is strong as ST. Silicon photonics is not as strong as ST. That's the message. Silicon photonics is very strong at ST. I think, I mean, we only have 1 minute left, and there is 2 key messages that I want to give the people. The first one is you just gave an amazing review of photonic technologies.
It's not finished.
But your time is. Okay, 1 more minute. 1 more minute.
1 more minute. Just I would like to present our MEMS mirror activities, because it's not very well known, but it's very helpful to build a full system. And we recently announced an agreement with a LiDAR company in Canada, LiDARtech, and we will work with them together to develop a low-cost LiDAR. But the future is for fusion of images and fusions of intelligence. So we see a lot of capabilities thanks to our manufacturing machine, to our technologies, and the fusion of MEMS and optics, and also the capabilities of making local decisions.
Thank you so much, Eric. As you were saying, you gave a fantastic review of technologies that are going in volume production enough to interest the semicon industry. You made a fantastic filter there. I have a question from my friend Henry White from Biosystem. He's wondering, what quantum areas is ST working on? Is ST looking at quantum technologies, Eric?
You mean quantum dot technologies or quantum well? Or quantum,
I think we are looking more at quantum computing and quantum physics.
Yeah, quantum computing, it's part of what we are investigating, but in R&D mode, because this is the technology maybe for the very far future. So yes, we are investigating in advanced R&D. Yeah.
Thank you very much, Henry White, for joining the meeting today. And thank you very much, Eric, for a great presentation, and most important, for being the epic champion at STMicroelectronics. We continue with the program. It is 6 o'clock. I'm keeping the time. I found that as personal challenge today. And as I said this morning, there is a lot of Easter eggs that you don't know in the program. The next Easter egg is coming from Neuchâtel. At the end of the day, Christian and I have been working very hard in the last years, positioning Europe as a key place in the manufacturing of photonics-enabled systems, especially on micro-optics. And Switzerland makes the best ones. Thank you very much, Christian, for being with us today. I know you're not in the program. You are one of the Easter eggs, one of the surprises of EPIC. The floor and the attention of everyone is yours.
Thank you very much, Jose. First of all, how are you holding up?
I'm doing great. Look at me, like fully fresh. I'm doing this already for only 9 hours to go. It's going to feel short at the end.
Okay. So thank you for the introduction. So my name is Christian Bossart. I work for CSEM. CSEM is a Swiss RTO, Research and Technology organization. And I'd like to tell you a bit what we are doing at CSEM in general in photonics. But I would like to start to give you a short overview of actually who we are. So we are a private company. We provide R&D services for other companies. We are now roughly 500 collaborators, even more, turnover around 80 million euro. We have a lot of startups. It was one of our missions in the past. Many clients. Patents are very important for us, and we also participate in many different European projects, and I will mention two of those. So since we are an RTO, technologies are important for us at CSEM, and so we are structured in along 3 pillars: precision manufacturing, digitalization, and sustainable energy. And in principle, as you probably know, photonics is everywhere, obviously, but mostly at CSEM it's in the precision manufacturing. And that's what I'm concentrating on. There will be a little bit on digitalization And today there will be nothing on energy. So I would like to mention a couple of recent success stories of technology transfer, because that's our mission, to transfer technologies to industry, to make industry in Switzerland and in Europe competitive. To the left, you see a very recent startup that we created. It's Actia. That's a startup that can measure your blood pressure optically without a cuff. That means you have a normal wristband, and this wristband will measure your blood pressure over 4 hours, over 24 hours. It's very important for clinical studies. I don't know how this is you. When you go to the doctor, you get nervous, measure your blood pressure, and the blood pressure is certainly not the normal one. So this is a solution for this problem. Although it's not the main topic today, but CSEM is very strong in machine learning and AI, and we had a very successful transfer to SBB, the Swiss Federal Railway company, to online detect defects on the rails. That means there are very fast cameras that take picture, and we develop the algorithms that allow you to immediately see if there's a defect on the rails. Of course, very important for safety issues. And the third transfer I want to mention is in the area of brand protection and high security. CSEM has been active in that field for a very long time. You find our security features in the French passport and the Chinese passport. And recently we made a very successful transfer to the company Neutrik. It's a high-end video and audio connector company, and we make sure that their connectors are not copied with our optical brand protection solutions. I mentioned we have created a lot of startups, and over 44 in the last 20 years. And I'd like to mention a couple of them. Actia, I already mentioned on the left. Then 26 Laser Enterprise in Zurich. The VCSEL part comes from CSEM. This was a startup from CSEM, a spin-off actually, was then bought by Bookham, became Oclaro, and is now 26 Laser Enterprise. And also a startup that is now producing high volumes, that's Heptagon. This was a joint venture between CSEM and the Finnish company. We brought in the diffractive optics know-how. Heptagon was recently bought by the AMS group and is now making billions of units of micro-optic elements, for example, for smartphones. Now, in the following, I'd like to show you a bit what we do at CSEM, different areas. I start with components, go up to the system level. Let's start with diffractive optics. That's the heart of CSEM. Heptagon was based on that. So two developments that we are currently pursuing is on waveguides. We are quite active in augmented reality, where we provide diffractive solutions to couple images into a thin foil, then couple out the image back into the eye of the user. You see here the CSEM logo. And another interesting application are filter arrays based on diffractive optics for hyperspectral imaging, for example. That means you don't have to have different filters with different thicknesses, thousands of layers that you have to put on. We have one master with different diffractive optical elements, and in one step, we can replicate whole arrays of filters, for example, onto camera chips or to that wafer scale. This is something that we think is a big future in that for us. Going on to what Jose mentioned before, freeform micro nano optics is also something we have been doing for a very long time. You see to the left an application, the internal application for lighting, for example, for cars, where we use diffractive optical elements to project images onto the street. For example, to let a passenger know you have to stop, you cannot cross the street, or to inform somebody, I want to turn left or right. And freeform optics, that's the optics, the micro optics, where you have no circle symmetry. This was something that has been a dream for many years, but only with the advent of new origination possibilities based on 3D printing, we can now originate any structure we want based on design, and then we can go on and replicate. And this is fabulous because this is a new pilot line project in Europe that CSEM had the idea. put a lot of effort into the proposal. It came through, so it's coordinated by CSEM, and it's a pilot line for freeform micro-optics with many different partners. So we have companies that do the origination. We have companies that do the manufacturing. So we have wafer level optics, we have roll-to-plate application, and we have roll-to-roll application. And then we have a number of end users, for example, Hella for the automotive industry, and Zumtobel for the lighting. So it's a project with the aim that the pilot line will stay after 4 years and be able to serve the SMEs in Europe in the domain of freeform optics. Another topic important for us is MOEMs. So CSEM, it has its own silicon fab, and we produce or develop tunable gratings for external cavity lasers, for example, for QCLs. We can fabricate membranes for thermal emitters. We can use mirror arrays, either magnetic actuation or electrostatic actuation. So we have the MEMS front end and also the back end packaging for such MEMS structures. Packaging, nothing goes without packaging. You all know that in the end, many products, packaging is 60, 70, 80% of the final cost. So we have our own photonics packaging lab from design to prototyping, where we work on different aspects. So we have developed multi-emitter laser modules, 400 watts with 20 emitters in one package. We work on hermetic sealing. We have done hermetic packages for implants, for optoacoustic modulation for cochlear implants. We work on hermetic sealing for ESA, and we can produce any kind of complete packages for our customers. Moving up the chain, sensors. Based on what we have done, of course, we can produce sensors. I've brought two examples here. One is on the fluorescence lifetime imaging. That's very interesting for optical security applications. That's one area we're pursuing. It's of course interesting for biophotonics. We also work on single wall carbon nanotubes. Detectors were actually of fluorescence systems. I always thought, yeah, this is only for academics, but now it comes really close to the market. And particle detection, where we use UV vis absorption, scattering, all laser-induced breakdown technologies. All direct links and the product development with customers. Lasers, laser-based systems, also something that we do. We work on a project with the mission to go to space, where we develop the LiDAR system to detect debris in space. And the idea is, of course, that the whole system is able to get rid of debris in space. We work on IR spectrometry. We're just working on an H2020 project. It's called FLARE, where we use hyperspectral imaging to be able to analyze the spectrum in the IR. Something that we have been working on for a very long time are atomic clocks. You know, Switzerland is maybe the capital of the world of watches, and Neuchâtel, the headquarters of CSEM, is the capital of the watch industry in Switzerland. And we had more than 10 years the idea to make an atomic clock that in the end would fit in a watch. So we're not there yet, but we have done a lot of work in miniaturization and integration. So we have our own ASIC to steer and analyze the atomic clock. We have our own wafer scale process to hermetically seal the cells that are the heart of the atomic clock. We do optics, diffractive optics, to couple in and light in and out of the atomic clock. So we're able to provide the whole system. And based on that, we are also currently leading a quantum flagship project called Maximal. So where we further develop atomic clocks, and we develop specific quantum sensors for a variety of applications. This project, we have 8 academic partners, 2 RTOs, one of them, of course, is CSEM, and 4 SMEs as potential end users. embedded systems. So my last application, that's vision systems. And you know, vision systems is always the question is, do you need all the information? As an example here, I have these two birds. Raw data is maybe 24 megabytes. And as a human, you need all the information, and the JPEG compression is maybe 1 megabyte. But sometimes you don't need all the information. A machine only needs to know there are two birds. So how can you get this information directly out of the chip or from the camera module? That's another very important and large activity at CSEM. Vision systems. To the lower left, you see again one of the examples. You take a picture of the CSEM headquarters in Neuchâtel, where I'm currently sitting at the moment. You see the people, but at the end, maybe you only want to know the position of the people. So we develop systems that have to be simple, plug and play, have to be accurate, low power, and fulfill a variety of applications. And for example, you see here is the Spectrox system. That's still quite large. It's used for skin analysis, for example, to detect whether you are in danger of having a skin cancer. It's still quite large, needs a lot of power, so it's wired, and the battery. The model system is at the same size, but has the advantage that it can, for example, track people. Pupil, even smaller. It's still wired and battery, but it can do face detection. And the newest development, Witness, it's very small. It needs only 2 milliwatt, and it can really detect motion. For example, if somebody is moving in the room. And of course, we hope that we can go even lower, that even all the signal processing also of Witness can be done on chip. So this brings me to the end. Thank you, Jose, for the invitation. I hope that to see many of you again next year at Photonics West. You know, I'm a runner. I like the morning run on Wednesday morning, and I hope this is a picture from this year. And I hope to see many of you there next February if everything goes fine.
But you realize, Christian, how crazy we are, like running at 6 in the morning, 24 hours of photonics, doing what we can. I also would like to congratulate you because you have two hats. Also, you have the hat of Swiss Photonics as a national cluster. You are doing a fantastic job there as well. So congratulations on that. We have questions for you. The first one is coming from SEMICONDUCTORS. Greg, what's on your mind?
Thank you, Jose. Hello, Christian.
Hello.
Just a simple question, going back to the atomic clock in a watch concept. Why in a watch and not, say, in a smartphone, which with its other sensor opportunities would be perhaps the better housing?
Yeah, you know, I mean, when we started this idea, this was like 15 years ago, smartphones were not yet so popular, and we thought, okay, putting an atomic watch in a watch would really be the Swiss show the Swiss precision, Swiss miniaturization. But of course, there are other applications that we can think of. Obviously, yes.
Okay. I guess also you are in Switzerland, right? So the first thing that comes to your mind is the watches. You make fantastic watches. Regarding your fantastic filters, I have a question from Samuel Hack, Professor Hack from NCU. He's wondering about your filter technology, if it can go beyond 1 micron to cover part of the SWIR range.
It can go above 1 micron. It depends a bit, of course, on the choice of material, but we have shown that we can go above.
One of the things we had done great with CSEM was always the entry point to manufacture things for the harsh environment, especially with the space market. Whenever a technology was not being seen as robust enough for space, I always said, send it to my friends of CSEM, they can test it and they actually can do the right reliability. Yeah. Does that apply also to micro optics? Are we going to put the micro optics from SUS Micro Optics in space?
Actually, we have just finished an ESA project where we received a back-illuminated CMOS camera chip, and we had to put micro lenses on the other side to really get the high efficiency on the chip that is already packaged. I mean, it's all the wire bonds, and we had to show that the chips survive. I mean, the micro optics survive, and I think except for for one not report point, we could fill the requirements given by ESA. In the end, it's a material optimization.
Reinhard unmuted himself. He wants to comment on that. This is great.
Yeah,
this is epic.
So actually, we have micro-optics in space in the Gaia satellite. This was a strange project that was many forms. And one day, my colleague comes with a newspaper and said, you know why he's called Gaia? Because we have a Czech Hartmann in space now. And the TNO who was building the whole thing, they confirmed. So micro-optics in space is already done. And there was another project where we had micro-optics in you know, a robot on the ocean level down to repair cables. And this was 6,000 meters below in the water. And it was just a fiber connector with a rotating prism and 2 microlens arrays. And so we were down 6,000 meters and up in space. Micro-optics is everywhere.
Swiss micro-optics in Switzerland truly rocks. You are my
now
heroes.
You rock. Yeah, come
you are
on,
starting
you
a revolution. People are gonna remember these days when Reinhard, Christian, and Jose were talking about the micro-optics revolution. People are gonna remember this. Thank you very much, Christian, for a great presentation. Reinhard, thank you for being here. We continue with the program, and now we're gonna get serious. Because until now it has been a joke, now we get serious. Now we go to ASML. We go to the company who has managed to put a bit of the Netherlands in every mobile phone. And I work in the Netherlands. I know what it means to have ASML in the room. Humberto, thank you very much for having ASML as a member of EPIC. And thank you very much for the next 20 minutes in which we want to see how these EPIC members can make the greatest ASML even greater. Thank you very much, Humberto, the floor and the attention of everyone. I think we have now more followers in YouTube than ever today. The attention of everyone goes to you.
Yeah, thanks, Jose, for the introduction. And I like also to make some jokes in the next 20 minutes, not to be so serious. But yeah, indeed, so let me share presentation. Yeah. We're going to discuss about what ASML can offer, how to interact with the ecosystem.
Bottom of the screen, share. Yeah. Yes.
I will share the screen.
I'm sure Carlos has been training you really well.
Yeah. Let me know when you see it.
Perfectly.
Okay. So I would like to discuss today, introduce you to ASML if it's indeed needed. And then discuss also the connection with photonics. So the idea, my agenda is pretty simple, pretty easy. So I would like to discuss and to bring you from chips to photonics, going through the lithography. And the first statement I would like to make is that chips are everywhere. And I think everyone can agree. And it's really difficult to imagine a world without chips. So we won't have internet. We won't be here today. We won't have any advanced smartphone or devices, laptops. But also biomedical and cars won't be so advanced like today, and data center and so on. So it's a world-changing concept. And they're also very connected to the market. So if you look at the chip industry, it's really an economic catalyst. Back in 2018, 1 trillion of chips were shipped. And then if you count, there were more than 100 chips per single person in the planet. And also the sales connected to that were also steadily increasing from 10 or 15 years ago, and then got the record sale in 2018 of 470 billion approximately. And how ASML plays in this next game. So basically, we are the ones making the machines designing the machine for making those chips. Lithography, for many of you know already, that it's a critical process, critical phase, and critical system for production of chips. We had also quite good year in the last few years in a row, so we had good sales. And now we are a big company today. We have 25,000 employees worldwide. And if you look at the numbers, almost half is busy with R&D and still pushing the new technology for the next generation challenge. But how did we start? So we started really in a modest way. In 1984, we were a spin-off, small company, 31 can-do attitude people started the company. And there was some struggle. You see the picture of when we started. There was no big fancy building, but was just whatever we could find. A spin-off from Philips and SMI. And it took a decade of really struggling. But then at the end, because of the attitude, we made it. And if you look at today, this is the snapshot from the top, our campus. So the tower is basically our headquarters, and the rest of buildings are a clean room where our fabs where we produce the systems, but the majority is offices where our R&D people is designing and getting and fighting with the new challenges of technology. So all major chip makers use our technology. We also are the second biggest company in Europe for the market cap. And again, we invest a lot in R&D. We have 2 billion invested earlier on the R&D. But what also brought us here? So we have a vision, and the vision for us, it's semiconductor technology to be everywhere, to be spread everywhere. And this is not just purely sales, or even to call market consideration, but it's just helping customers, but people and technology to push and to go through. And when you think on healthcare, energy, mobility, communication, entertainment, but many others, then you see how technology can help. And we have a good confirmation nowadays. We are still coming out from a pandemic where all the communication, everything became virtual. We are also in this meeting as an example. So where technology really helps a lot. How do we locate in the industry? So basically, if you look, our main driver is basically the Moore's law. In 1965, a very clever and nice guy created an empirical law saying that number of transistors will double every year in the chip. He was smart enough to correct himself after a couple of years. He said, not every year, but every 2 years. And basically, since then, this law is still very applicable. It's our driver, and we follow constantly. But what does it mean in terms of market? So basically, Moore's law makes chips cheaper. If you look back in 2004, when the first iPad was launched in the market, the 1 GB of flash memory was costing more than $100. And in 2018 was costing less than 30 cents. So decreasing the price so dramatically made the fact that also the electronic devices can be more powerful. This is balance. So we get cheaper, and then we can put more, and the shrinking can put more powerful. And then here I have a nice slide I would like to show the comparison of a product of 35, 36 years ago and today. Same price, if you look, at that time was costing 1,500, and now the latest iPhone, or if you like Samsung, can also be exactly applicable to the latest Samsung. They were costing the same. But if you look at the 20 grams of an iPhone you have in your pocket today, and the 13 kilos of that laptop at that time, and the resolution of the screen, the computational power, there is really no comparison. Then you see how that going cheaper can bring also the market to grow and to create new products. And then, for example, if you look again at the flash memories, then you can introduce easily from the digital cameras till the solid state hard drives and laptops. Then you can see the market can grow dramatically. But this is not a coincidence. So if you look this very nice loop, so everything is connected. So wherever you start in the circle, you will get at the same place, but on the next generation of technology. For example, chip machines are capable, like the ones we are producing, to make chip to go in a smaller feature, which will trigger a chip redesign, and the chip makers will get a more powerful product, which will be embedded in a device. So the device will go to the consumers, and the consumer will see either cheaper, the same device, or better technology. And they will push further, and then the demand will boost. And for example, if I consider the smartphones, every Christmas, more or less, you get the new version of an iPhone or a Samsung phone. And that's pushed the market. And the fact that every year there is these novelties and the demands will push, for example, us to go to high resolution and to boost the chip machines to go smaller. And this is the continuous circle, which is really incredible. But this is also connected with the reality we are living now. So we are moving from mobile to ubiquitous. So if you look at that nice slide as well, so the product units for mainframe computing, personal computing, mobile computing had a really good market at that time. But if you look at the curves, they will, sooner or later they will encounter a plateau and a saturation. But where we are now with the multiple machines to multiple machines, if you think on the communication, automotive, then you need power, you need chips, you need memory, and that's where the world needs really advanced chips. And then, just an example, logic and memory. But this is not the biggest market we look at. So there are many other key trends. One is the gaming. Seems trivial, but there are under billions of market available there to really boost. And then if you look at the virtual reality technology now, it's really able to mimic what is the quality or the perception of our human eye. Automotive is also big and very photonics is very involved. By 2024, there will be double of market reaching the 600 billions. It's really big. And then if you consider the automotive, the new automotive, and the sensors and the mapping, all the reality and the environment, it's really impressive. And then just not to forget the 5G, 3G, 4G, so the infrastructure, all the data we are creating now, we are processing, needs to be transferred and needs to be used by every single consumer. And then this is also a nice graph. And then I think the very nice example when we do the 5G and the bandwidth you will have of 5G will allow you to download legally a movie in less than 4 seconds, while with the 3G you need to spend more than 1 hour or 1 day, so more than 26 hours, about the epic 24 hours tour. And last but not least, so photonics revolution. So basically the constant need of efficiency, energy efficient devices, and the adoption of photonics products, and I listed here there a few, but you have much more experience than I do. So biophotonics, robotics, information processing, measurement, defense. It's also boosting a big an emerging market, which is photonics, for which we really look at. But then how to connect again market to technology? So ASML is really pointing to the Moore's law, what we said. So the chips are doubling every 2 years, but we also look very closely to more than more. So we don't need to double in pattern of chips in a product, in a transistor chip, but we also look at diversification. So when you consider the system in a package or the system in a chip, then you can make it a chip with a special feature, with a special function. You don't need to be really small, but you can create VCSELs, for example, or CMOS. There are many that we call mature products or mature markets. And then how to get there? So we have we started with the PAS 2000. So the first product we developed in '84. That was the first product ever. So we could sell to IBM, and with that money we could invest in R&D, and we can started the chain. And nowadays with the TwinScan and the EUV that everyone I think knows from the news, we are the leading edge of technology. I added here some performance and some specification. Basically, we moved from more than 1 micron resolution and 20 waves per hour to less than 40 nanometers resolution and 270 waves per hour. You can imagine the productivity you can get with those systems. And with the EUV, the latest and greatest, we are down to 13 nanometers. We have also a good waves per hour number, and then it's really the leading edge technology. But does this apply to photonics? Because this can be scary, especially if you look at the price of those tools. So we target photonics with different products. So back in '91, we launched our breakthrough platform, which is called PAS 5500, what I like to call machine with history. So basically at that time, that system, which is still very applicable now, was very convenient for customers because it was modular, because it was able to reduce manufacturing time, so really increasing productivity. And it was so flexible in terms of configuration that you could immediately change the same target machines, the product for that system in MEMS, radio frequency, or in different application, even LED. And the most important, especially very applicable to photonics, you don't only handle silicon wafers, but also exotic substrates, which I call exotics, but they are not exotic anymore. So gallium arsenide, aluminum gallium arsenide, indium phosphide, which are really the ones looked and used in photonics, at least as far as we know. And there is a platform with many systems, and then you see also the wavelength we use and the resolution. We go from 400 to 90 nanometers. And also we are able to handle different wafer size. This makes exactly the perfect fit for photonics products. So size of the tool itself, it's not too big, it's not too small. So the weight, the wafer size capable to handle, the price, the service connected to it, the performance, and the enhancements of the package you can attach, you can buy together with the system. And in some case, the copy exact, because some customers, some foundries, they want to have exactly the same system with the same performance, and we are capable to guarantee it. And that is the perfect fit for photonics product from our experience and for what we know. And what ASML does is also not working as in a standalone mode. We are in an open innovation mode. So we are proud of our product process. We invest a lot, I already mentioned, in R&D. So we have 2 billion spent yearly. We also work a lot with suppliers. I saw today also a presentation from Zeiss. SHAMIR, I just mentioned 2, but we have tens. We have a good network of customers for which we have not only customer relationship, but partnership many times. And also what we like is also to work and to care about the ecosystem close by. And for that part, and very connected to photonics, I'm really happy to say that we are part of Brainport Eindhoven. So we are located in Eindhoven, Veldhoven, and we are part of that association. And University of Eindhoven and Smart Photonics, for example, really busy and really in the photonics market are using our tools, for example, to produce and to do the R&D. And then together again, so we are now a big company. I mentioned in the first slides, we struggled for 10 years. We were a spin-off. We started with 31 people, now with 25,000. So that's why we still like to support emerging companies or startups or scale-ups. That's why we are investing a lot in European projects. We are investing in kind of support of startups to help developing and starting and to move on their feet. We also assign quite some hours, our tech and knowledge people to those startups. And that's the way, if I already can anticipate your question, how can we work together in the EPIC 500? So we are there, so we can offer product, we can offer services, but we also like to have this kind of collaborating dialogue with any company that can be interesting and for which we can see a bright future. And last slide is just my contacts, because here we are in a nice environment, but any moment you want to reach to me and then have a virtual coffee, or you want to come to our campus, maybe not for those days, but in the near future, you're always welcome.
Thank you so much, Humberto. It's so great to have ASML in the room. Look, there is great lithography machines in Europe, and I want them to see your examples. So companies like SUS Microtech, like EVG, like Heidelberg Instruments, they need to Nanoscribe, Multiphoton. We have lots and lots. They need to learn from the success. You need to hold the flag and guide these amazing companies to the success that you have achieved. We have questions for you because you already answered the every questions. We have questions for you. The first question is from ST Microelectronics. Eric, what's on your mind?
Yes, just a question for ASML. You have now established, and it's normal, strong, let's say, leadership on these different lithography tools. How do you consider your competition? Who is making progress? And maybe some word about China. Do you think that at one point in time we will be able to let's say develop some good lithography tool for themselves?
Yeah, so it's a good question. Competition is always there. We had from the beginning. I'm happy to say that there is no competition for UV at the moment. We are the ones able and capable to run the technology. For the rest, we are working. We are fighting with the competition. I think in ST we have also some cases. So it's there, but we have on our side. Yeah, you can always debate about a price and money, but what we have on our side is the good service we offer to our customers, and that is at the end what we saw on the last experience is the winning factor. So you develop a product, you deliver, but you also care and you serve for multiple years afterwards, and that is where ASML or ASML's name is really famous for.
The second question comes from FICONTECH. Greg.
Hi, Humberto. Thank you for your talk. I'm just curious. So, photonics chips, photonics PICs, they obviously need a different node scale compared to microelectronics nowadays. Can you see from the sales of your technology, the systems you use, which are 30 years old, what is the most common node size that's used for photonic systems?
Yeah, so I think I don't know if it's still called the 14 nanometer node. It's basically the I think it's that the name is where the resolution is below 1 micron, but also above, let's say, 100 nanometers. And yeah, so I think it was called the 40 nanometer. But we tend to call more than nodes because also the definition of nodes was changing over the year in a strange way. We call mature products, mature market.
Okay, interesting.
And then you have again automotive, and then you have power devices, and then you have VCSELs, you have LEDs, micro LEDs. All those products they are really belonging to the market, and then we can be served easily with these 25+ years tools, which are still very actual.
Thank you.
The third question comes from a very, very fantastic laser diode company in France, Aerodiode. Sebastian, what's on your mind?
Yes, I just had a curiosity, a technical curiosity when I read that we are still in a more than Moore logic evolution. We are reaching now 7 nanometer resolution, maybe better. We are not far from the lattice parameter. What's the limitation? I mean, isn't it an absolute limitation here?
Yeah, this is nice, but also difficult to answer question, not because of knowledge, but also because what we are still developing in ASML. So we are getting close to the physical limit. So that is totally true. But our and the guys and our technology is still looking into what we can achieve before getting into the limit. So the more and more looking at the 6 nanometer now, so it is still more slow, but we have 5 to 10 years to look at what will be so the next challenge. And then I do agree that we are really close to the physical limit, but we are not there yet, and that's still pushing. We have we have 2 presidents. One is still pushing for the more push or more slow, and then that's where the company is heading to.
For those of you who have enjoyed this presentation, on the 3rd of July at 3 p.m. Central European Time, EPIC Online Technology Meeting on Lithography with ASML, with SUS Microtech, with AVG, with all of you. See how we can work together. Humberto, one last thing. The EUV stepper, as a fan of optical instruments, it's not an optical machine, it's a work of art. So beautiful. Thank you very much for keeping the flag up of the optics manufacturing and the optics enabling manufacturing in the world. Thank you. It was an honor having you in the room.
Yeah, thanks.
And we continue with the program. It's 6:40 and we keep the timing already for so many hours. We keep the timing. The next presentation is from a friend of mine and a top company in the security and defense and aerospace and space sector, BAE Systems. We have Henry White in the room. Henry, thank you very much for being such an epic aficionado. The floor and the attention of everyone right on time goes to you.
Hi, Jose. Yes, it's great to be here. Just share my screen if all that goes well.
It goes well. It goes perfect.
Okay. Is that working?
It is. The floor is yours.
Right. Yes. Always a pleasure to be on these epic meetings. You learn such a lot from listening to all the other people. So this is going to be top-level overview of photonics in the aerospace and defense industry and BAE Systems. So yeah, I'll go a bit about photonics, but then I'll talk on some of the main areas that we're interested in at the moment. So imaging, communications, displays, sensing, and the fact that the challenges we have from being in harsh environments. And there's almost no areas of our products that aren't affected by photonic technologies. And I see that happening even more so in the future. So before going into a bit more detail, I thought I'd just give you a bit of, cover some of the areas that I've looked at personally in the past. Been looking in the photonics area for many years with optical neural networks back in the day when they were a thing before the electronic computers could really do what they do at the moment. But there's so many different areas that are important in so many different application areas. And, you know, from my experience, it goes from cycling to submarines and sort of all things in between. But the main area that sort of has been part of my career is enabling photonics to work in harsh environments. So just a brief overview of BAE Systems, as you're probably well aware. But yeah, we are a global company. And I was just thinking, we've got more than 40 countries. We've got people in. We could perhaps learn from you and do our own 24-hour around the world event, but I'm not offering to do that myself if anybody from the company is listening here. But yeah, there's a lot of different parts of the company in the US, in Australia, in Saudi Arabia, and as I say, all those other countries as well. And the way the company operates is different in all those different places as well. But so you'll get a main field for BA Systems in the UK. So photonics, are we a photonics company? Well, in some cases, yes, we make photonic devices, but really we're a user of photonic devices. We look at some of the products and some of the environments that we cover at the moment. So we look at the solar high altitude long endurance, a HALE platform at the top right there. You know, that's solar powered, so you've got the photonics in there, and the solar cells imported that are so vital. The efficiency of those devices is critical for the performance of the operations that those type of platforms can cover. Never mind what sensors and communication systems you want to put on them to start off with. Having the efficiency of the solar cells is vital there. The fast jet area of the air sector part of BA Systems, it's incredible what technology is going into these devices, and we work with a lot of our supplier partners to provide that technology onto these platforms, and I'll say a bit more about that. But that you've got, you know, high temperatures, you've got high vibrations, you've got high accelerations. And the packaging and the integration of the technologies and getting that right for photonics is vital for the exploitation. Coming down to land, you see the Falcon communication systems there. So communications by photonics and RF systems is vital in all these systems, and it is joining up all the different assets around the environment that people are operating in. Then obviously when you're going to sea, you've got a lot of different challenges there from the environment. You're actually going for much longer missions where you've got to have things as reliable as possible. You might have a little more space, you might not have such accelerations, but you might also have large areas which, because you've accommodated for the maximum number of people you might have, at times you'll have areas that are sealed off and not being occupied. They've got to be monitored, so the sensing applications for those is really important. And then when you go underwater, you've got the challenges there of actually, again, long endurance, high reliability systems needed. And actually, you do want to do things through the water. So the challenges of imaging and communicating through water are really where technology can really make a difference. And on the left there, this is just making the point that we do a lot in the cybersecurity area as well. And the integrity, and I say the robustness, the protection of all these areas is vital. So there's a huge development of cybersecurity and how photonics can play a part in that. So going through some of the areas, imaging, all those different platform areas we need to image. You need to be aware of what's around you. What am I looking at? What's coming towards me quickly? How am I going to process that data? How are you going to combine different sensors together to understand the environment you're in? Now, what you want to detect with, let's say, if you look at those black body spectrum curves there, the different temperature of something that's out there will give it, you want to operate at a different wavelength. So we do need a whole range of sensors from the UV to the long wave infrared. And then you've also got to take into account, are there active systems you want to transmit and detect as well and image those? But also, what are you imaging through? Are you trying to get through clouds? Are you trying to get through smoke? Are you trying to get through dust? Or are we underwater and need to know what turbulence and the transmission through water? And okay, that looks a nice blue water there, but a lot of the coastal waters are very much not that bright blue. And on the integration of these imaging systems, as I say, is vital. On the picture of the typhoon there, on the top right there, you can just see the Pirates as sensor systems provided to BA Systems by Leonardo with Thales and Technobit. Integrating these systems onto the platforms is vital. So this, you've got an infrared detection system which is designed for specific tasks. But as I say, those imaging techniques apply to all the different platforms. It will be on the ships that were being built as well. You can see the size of the aircraft carriers here. Communications in this is vital as well. So, okay, we need to communicate between different platforms. We'll have fiber communication, blown fiber systems on ships, protective fiber systems on aircraft. but also there's you're in very shielded environments in some of these, so using Li-Fi links sort of, within platforms is quite viable as well. And between platforms, covert optical links is also important. Because we're in a really connected environment. I mean, this is a schematic of the Tempest aircraft being developed at the moment and talks about some of the capabilities that are going to be incorporated into that. All these will have an element of photonics in there, but just on this diagram, I just want to focus in on the connected and cooperative aspects of it. It's not an aircraft on its own, it's a system, and it's communicating and sharing data and collecting data and understanding the environment from all these different assets, both from the land, the sea, the satellites, the high altitude platforms, and other things as well. So those secure communications from fast moving platforms through challenging environments, incorporating those and seeing through things we can't see at the moment is really important. Then, so you've collected data, you've communicated, you need to display it. So a number of different areas that we work on here. The Q-Warrior system at the top there, helmet-mounted clip-on display, is incredible guided optics incorporated into that to produce an uninterrupted display onto the soldier's view. And again, that type of technology is being applied now to the Striker 2 helmet. I mean, amazing color displays on these health critical components, but also very much a multifunctional operating device as well. On the left there, you've got the Light HUD advanced head-up display element, and then that leads us a bit to where are we going in this. You know, there's AR and VR developments that people have talked about. That technology has got incredible potential as long as it's being used in the right way, and there's not too many misleading diagrams that this one might be as well in terms of what you can see at what time. But it does go back, if I flick back to this virtual cockpit area here, that's where you might get away from the type of displays we've got in the head-up, the Hawk here, and you might be able to have much more controllable information displayed and adapted for the circumstances. Sensing, sort of a bit of a side here. So apart from imaging, there's all sorts of other sensing that photonics plays a part with. And I've also been lucky enough, I'm the engineering lead for our UK sport partnership. So BA Systems is the official engineering partner to UK sport. So I love my cycling, but that's definitely not me on the bikes here. But this is an area where photonic sensing we've applied, where we've taken technology that we've been looking at for some of our platforms and said, well, actually, this can make a difference to sporting arenas as well. So again, this is a couple of cycling examples where some optical measurement systems have been used to help the athletes train for the elite sports. But again, that sensing environment, as I say, you're measuring the movement of platforms, but you're measuring the platforms themselves. So optical fiber structural sensing is really an important future integration aspect. And as I said, going back to that original of our harsh environment, it is the integration of these technologies that is really key for us. And with that, things we've looked at in the past, so I said the robustness, the maintenance, and the lifetime costs of the technologies. Been involved many years ago with some testing of new fiber systems where we had some rigs where we really sort of abused the fiber systems to make sure that they're not going to fall over just when they went out of spec, because that's quite important. And you can see at the bottom left there, you know, brake dust, being able to clean and maintain optical devices for communications and imaging systems as well. So you get some nice fringe pictures as well, but it's really important that what's installed is fully tested and qualified. But these lifetime costs are getting more and more important. So I've missed a few things. There's a lot of other areas where we do use photonics. So we use computing, that's going more and more to be relevant. And there's lots of other applications I could have talked about as well. So it is everywhere, and it will be in a lot of other other industries as well. But in the defence area, it's important that it really provides that capability, that the platforms, this discriminating capability that they're needed. And it's only going to increase in the future. And with that, there is a need for more people who understand photonics, who both can understand the intricacies of it, but also how it's different when they're actually using it from other technologies that it might be replacing. And for a company like ourselves, as I say, a global company, we partner for a lot of areas. We have long-term capability partners, but we need to have that access to world-class technology. It's no good us expecting to find everything just down the road. So that's one of the reasons for the global footprint. And that's one of the reasons why I'm going to probably have to stay up late to catch up on all these presentations to see what else is out there I'm not aware of. But it is also important that we end up with a reliable supplier base. It's no good having the best technology if it's going to either not exist in a few years' time or be built up and have export control restrictions put onto it. The future is some, we can come up with some wacky concepts and some fantastic ideas about how platforms might change in the future. And they're always going to, I think, make it harder to integrate technology onto them. But there's some, I think the way photonics is going to enhance areas such as the quantum technologies is quite exciting. How much can we see around corners, see through the currently invisible, see through those murky waters, see through those clouds. The cyber encryption, can we generate the quantum computing photonic enabled cyber encryption technologies that aren't going to be crackable? The brain controlled interfaces, that's quite scary as well as exciting. And also the navigation, the reliance on the navigation from away from GNSS systems is going to be very important, as well as, just as I said, platforms that can really understand and sense themselves, so sense-aware platforms. So lots of exciting technologies and lots of exciting exploitations. So thank you.
Thank you very much, Henry. It is so great to have you in EPIC, and we have so many things to discuss, but the most important is the EPIC question. I have here all the companies in optics, in lasers, detectors, equipment. What can they do for you, and what can you do for them?
As I say, I'm well aware of a lot of them, because there's a lot of the companies that we are talking to as well. But I think the key thing for us is for people to be aware of that integration challenge, that when we're trying to put them onto high acceleration elements where, and I think maybe one thing to actually point out then is often we don't have enough space. So there's all these great technologies. We can either put technology A or technology B where we actually want A and B. So things that are multifunctional, things where you say, well, actually, I can combine what my company is doing with what this other company is doing to get a more integrated multifunctional system that then we can properly exploit. I think anything that can be developed in those areas can make a big difference.
At this point, I would like to remind everyone in the YouTube channel and in the Zoom channel that I love connecting people. So if you want to get in touch with any of the participants today or with any of the companies, a name drop, just let me know. Send me an email, jose.pozo@epic-asoc.com, and I will connect you because I love doing that. We have a question in the room for you, Henry. It's from Greg from FICONTECH.
Hi, Henry. Thank you for your talk.
Hi, Greg.
So if you go to Photonics West, for example, then you see that NASA has a booth at the event, and they have a department that brings their IP to mainstream industry. Does BA Systems have a similar department?
We probably have a similar design, whether we probably haven't done it on the scale of NASA there. We generate a lot of IP in the company, and a lot of it we might be exploiting straight away. Some of it we might potentially be exploiting in the future, and some of it we might decide, well, actually, the way things are going, we're not personally going to exploit it. So then we do look to find out where other companies might actually make use of it, and whether we can hand it over to them and make sure it's going to be of use.
What is
So
the process then?
we do try to do that. Sorry?
What is the process then for finding out what's available?
Yeah, it's probably a bit ad hoc at the moment, and that's something I'll probably raise internally as to whether we can do that on a more public arena, because what it tends to be is we decide, oh, it could be of use for these companies, we'll go and approach them, we'll wait for them to come and approach us. It's good comments.
Thank you.
Henry, for many years we've been talking and I introduced you to many companies. One thing you never told me is this technology is not mature enough for BAE systems. You never told me that. And if you and me are talking and we don't mention the word quantum technologies, people will feel that it's not really Henry and Jose talking. BAE System has been one of the industrial flag holders in the quantum technology in the UK and Europe. What do you see as the low-hanging fruit in the defense sector from the quantum world?
I think I'm always amazed how fast the quantum computing's advancing, but I'm still don't think that's going to be the first thing that's going to mature. I think the timing systems, I think there really is step changes on those that can be exploited in the near future. And again, getting robust enough and compatible with our platforms is our current challenge, and to understand that. But I think we are really looking at orders of magnitude changes in mobility, and understanding how we exploit that along with others is fascinating.
For the atomic clocks part, is there an application, a key problem that you need to solve today from BAE Systems? I think we got you frozen. The question was not that difficult and they blocked the network. Henry, I know the answer and I know you've been talking a lot about free space communication and I hope that we can address that. Yes.
There's many really, to be honest, and I probably can't go into details. Am I back?
Yes, you're back.
Maybe the link's playing up. Yes, so we are following up in a number of different timing areas, but I probably wouldn't go into details here at the moment. But I think the other thing is that imaging using some of these SPAD technologies is really fascinating.
Henry, thank you so much. You are an epic champion as well, and I'm looking forward to introduce you to even more companies. I have scouted some very cool ones. Thank you very much. And it is 7 o'clock. I'm keeping the time like a rock star today. I'm so happy with this. We go to Portugal. We go to, I was going to say HBM fiber sensing, but I'm going to say Hottinger, Brühl, and Kjaer. We go to Hottinger, Brühl, and Kjaer, and we go to my friend Luis Ferreira, who is making a big difference in the field of fiber sensing. Thank you, Luis, for being with us this beautiful evening now, 7 p.m. The floor and the attention of everyone goes to you.
Thank you, Jose. And good evening for the guys with the same time zone as we do, because I think it's good night, good afternoon, good morning, everything, right? So congratulations, first of all, for this incredible initiative. You are amazing. So you and Carlos and all the team, Jose, you are absolutely amazing. This is a great initiative, and I think that this increases the awareness about photonics, and that's the important thing. So thank you so much. And thank you also for having me here. Thank you. So I'm going to share my screen now. Hopefully it goes well.
I'm sure Carlos has trained you very, very well. He's proud of that. He's telling me, oh, he knows how to do it.
Okay, so can you see it?
Yes, crystal clear. The floor is
Great.
yours.
So my name is Luis Ferreira, and I am managing the optical business at HBK, which is essentially concentrated, the optical business, at HBM Fiber Sensing in Portugal. So I'm going to talk a little bit about the company, then switch to the technology, some target markets, a little bit about the products, and try to focus more on the customer applications, what the customers do with our products. And just to finalize, to say what is our commitment as a company. So in terms of company, maybe some of you are not so familiar with the name HBK. Well, it results from the merger of two companies with, I would say, a long history in test and measurement. So from one side, Brüel and Jair, well known as a global leader for sound and vibration in test and measurement with a very long history there. And also HBM, technology and market leader for testing and analysis. So the companies merged in the beginning of 2019 to create this HBK company with around 3,000 employees, reaching close to $500 million in terms of sales, and with a global presence in the world, quite visible in this map. And a very small spot you can see there in Portugal, which is fiber sensing. So where, as I said, we concentrate or focus all the activity in optical sensing. So the company Fiber Sensing was created in 2004. It was a spin-off from a research institute. It was acquired in 2014 by HBM at the time. So now it's part of HBK. It has been growing around 18% in average per year. We are around 50 completely dedicated to optical sensing. And we recently opened here in Porto innovation center where we also do other activities for the not even HBK group, but also the Spectris group, which owns HBK. So essentially in the areas of e-commerce and marketing, but also software development. But our focus here is the optical business. So here in Porto, we produce and develop everything that is special projects. We have our supply chain and production, and we also do here the business development and the sales support. So a little bit about our history. So we, like I said, were founded in 2004. We became OEM supplier of Siemens very early in 2007, something that happens still today. We won a very important ITER project, which was very important in our growth. We recently had one again, a new one already as part of HBK. HBK was also working on some optical products before acquiring us. So our work was to integrate everything and have a complete solution based on optical technology for test and measurement. So, and what is the technology that we use? It's, I would say, quite well known now, despite all the developments that it experienced over the last years. Fiber gratings are, I would say, already established technology in sensing. There are lots of advantages associated with this technology for sensing. So, of course, the signal stability, the insensitivity to losses, the fact that it's very easy to identify each sensor, multiplexing, multifunctionality. We can have a absolute measurement because we are measuring wavelength, not intensity or any other thing. The immunity to MI and RFI, like any other optical sensor. The fact that it's electrically isolated. Good resistance to humidity and to be used in harsh environments like high pressure, extreme temperature, high or low. Of course, suited to long distances. Simplifies sensing networks by minimizing the number of cables. It's clearly cost effective for medium-large projects. So even when competing with standard technologies, electric technologies. And of course, makes it simpler by reducing the number of connections that you need to do when you are installing on site. The technology makes the sensors reach very high fatigue limits. It can withstand high strain simultaneously and can be, in many cases, easily embedded in composite or glass fiber reinforced polymers. At this point, I also would like to refer that all our sensors are manufactured in-house using femtosecond FPGAs that are written in low band loss fiber coated with Ormosair, which is a high performance coating and fully compatible with single mode telecom fibers operating in the third window. So we call this our new light technology, and we use it for addressing markets such as structural health monitoring. So some examples are short or long-term monitoring of bridges, tunnels, high buildings, pipeline monitoring for structural integrity, and something very important where we are doing lots of work recently is onshore and offshore monitoring of flare towers and particularly monopiles. In terms of energy, conditioning, monitoring, maintenance, operation of power generators, hotspot measurements on power transformers, temperature measurements for battery testing. In the wind market, so blade conditioning monitoring, offshore and onshore monitoring and testing of foundation and structure of the wind tower, integration in systems for individual pitch control. We don't do that, but the customers use our systems to do that. Fatigue and durability testing. Transportation, so pantograph monitoring and testing, overhead line pantograph interaction control, and for vehicle validation and verification. Of course, R&D, lots of applications here. So embedding strain sensors in composite materials, measuring strain and temperature in cryogenic applications, aerospace testing of multiple components. In industry, multi-point temperature measurements for process control, load measurements for container handling, strain embedded monitoring in flexible pipes. I may have some examples for some of these cases. In terms of products, we use the FPGAs that I mentioned, our new light technology, to manufacture different types of sensors. So strain sensors in different formats to be installed in different situations. Temperature sensors also in different formats, always with two fibers so that you can combine them in arrays. Displacement sensors, tilt sensors, and accelerometers. So all of these you can combine with other, and for example, in the case of accelerometers, make it bi or tri-axial depending on your application. Also, like I said, we have arrays of FPGAs that can be simple, just with Ormosair coating, or we also supply peak-coated fiber reg ratings, so that the customers can configure distances and cable lengths, whether they are combining FPGAs or more complex sensors. So you can make very complex arrays of sensors, combining different types of sensors and also different types of cables and distances in order to suit your application and ease the installation. In terms of interrogators, we have sweeping laser technology that we have developed, and we have different types of interrogators. So for different applications, portable, industrial, and I would like to say that later this year we will be releasing a measurement unit that is great for, I would say, hybrid measurements, meaning applications where you are combining both types of technologies, electrical and optical, and you want to have everything synchronized in the same software platform. So you can use this module and combine it with other modules from the Quantum family, which is a universal distributable modular data acquisition system. So applications. One of the biggest projects we have been involved has been the rehabilitation of the Hercílio Bridge in Brazil. So it was closed since the 90s for safety reasons, and they have decided to rehabilitate it and reopen it. So they have to replace the main structural elements. And for that, we have installed a complete hybrid system, meaning optical and electrical, but only the optical were we have used 300 optical sensors, so weldable strain and temperature. I can tell you that they were all installed in 1 month in this structure. We have used 3 8-channel interrogators synchronized with the electrical data acquisition systems. And the system was used during the rehabilitation, but it's still there after the rehabilitation is finalized. Another application, monitoring of power generators. So here we use 16 sensors, 8 in the exciter end and 8 in the turbine end for monitoring vibration. Essentially, the customer, which is Siemens in this case, wants to monitor the secondary harmonics when the power generator is operating. In this case, we provide a complete solution from the interrogator down to the sensors that are inside the generator, including the feed-throughs. Wind, just an example. We have many examples. This is just one. So this was a project in Spain where I would say that the wind turbine was maybe over-instrumented because they were doing some tests and some analysis of the structure. So we have installed 2 interrogators in this wind turbine, 48 strain sensors and temperature sensors. These were installed in the midsection of the blades, and that was done on ground, and then on the root also, and that was performed already after the installation or the mounting of the blades in place. So here you can see a detail of the position of the sensors. Another interesting application, this started in a project with the OBB, with our colleagues in Austria. So this was a research project for vehicle infrastructure interaction between the pantograph and the catenary. The nice thing is that this system that you see here was operating during 2 years, 24/7. And on a standard locomotive operating up to 230 kilometers under harsh conditions. From the project, it resulted a complete solution that we now offer to monitor overhead line contact force in pantographs, consisting of 1 interrogator that is installed at a low voltage environment in the train, and 4 fiber sensors for force and 4 fiber sensors for acceleration, which are all installed at high voltage environment, and we also provide all the accessories for this solution. In terms of R&D, I know my time is going. We will be delivering for ITER 160 sensors and thermal compensation sensors for operating at 100 degrees, and data acquisition equipment, and the test and qualification of these sensors brings everything that we don't want to hear. So high radiation up to 10 megagray, high vacuum down to 10 to minus 3 Pascal, and high temperature, 200 degrees C long term. Another example, instrumentation of twist locks for spreaders. So in order to turn a spreader into a load, distribution of loads. So this is something we have been delivering to a company, Conductix, for a long time. And final one, Jose, we have also developed peak FBG sensing arrays that NOV uses for their riser embedded monitoring system. So essentially, with this technology, they instrument the tensile armor, and they can directly monitor the wire strain and detect the tensile wire break. So this increases safety, reduces downtime, and brings optimization of the product lifetime. So just to finalize, what is our commitment? So we have specialized and dedicated teams. We have flexibility for developing and producing dedicated systems. so either OEM or scalable businesses. We have a wide portfolio of high quality products. We are also able to engineer and deliver complete solutions. I believe we have a large production capacity for optical sensors. I know most of our competitors. We have a worldwide sales and service support, so either HBK direct or local partners. We can do customer training, and I believe we have excellent consulting for large projects. So if you have interest in any of these applications, you can always come to me after this, because I would love to get in touch with you for this or any other applications you may have.
Thank you so much, Luis. It was fantastic to have you here. And on the 16th, 17th of September, all of you who want to visit HBK in Porto, we had the epic meeting on fiber sensors hosted by Luis Ferreira. He's going to take us to a very nice place for dinner and a glass of wine.
Thank you very much for bringing that, Jose. Yes, you are all invited for that event about optical sensing here in Porto. So I will be your host, and you are, of course, all very welcome.
We have a couple of questions for you. The first one is coming from Henry from Biosystem. Henry, what's on your mind?
Hi, yeah, interesting presentation. I was just wondering if you've looked at the issues of attaching fiber Bragg sensors onto aircraft, not just embedded into the carbon fiber materials, but surface mounted, and the issues about maintaining that.
Yeah, we currently are not on any in-flight application, I would say. We are only on test, so essentially on ground in the lab. Nevertheless, you are right, when embedding sensors in composite materials, there are lots of challenges. We have been involved in a number of projects, and I definitely know what you are talking about. So all the difficulties that you can find. We have had success and also some failures, of course, but I think that we now have a know-how that allows us to, at least in most standard composite parts, to integrate our sensor successfully, I would say.
One thing that always surprised me from the field of fiber sensors is that everyone is making their own interrogators. Do you think there is some need of standardization here, so we just have the same kind of solution? Or do you think it's okay that you have, on one hand, you had the micron optics, on the other hand, you had the Technovis, you had the HBK?
I think that's a very good question, Jose. And the point is that I think we need standardization on both sides, on sensors and on interrogators. I think that in both cases, there are steps being done in Europe and also in US in that direction. Definitely, at least it should be possible that the sensors manufactured by all companies could be interrogated by the interrogators produced by all the other companies and vice versa.
You know what is the best part? Is that all the sensor manufacturers, the fiber sensor manufacturers that are members of EPIC, you are super nice people, and we are all going to have a couple of glasses of wine in Porto. It was a great time to start maybe a kickoff activity on standardization. Luis, once again, thank you very, very much. You've been
Thank you
fantastic.
so much. Thank you for having me, and once again, congratulations for this fantastic event.
We are totally crazy. We are going all around the world in 24 hours, and now we go to Iran. Let me practice my Farsi. Salam, Hamid. Hetori, thank you very much for joining us all the way from Iran to talk to us about laser-based material processing. The floor and the attention of everyone goes to Persia, goes to Iran, goes to Hamid, goes to Asia Laser. The floor is yours. I think we still have you muted. Can you unmute yourself? Yes. Now it is.
Okay. Hello, and in Persian, I have to say salam to you, and I am so happy to attend to this 24-hour tour for all around the world. First of all, I have to say thank you to my very, very good friend, Mr. Carlos Lee, for following this international, very, very important, this wide range conference in this condition. And first of all, after that, I have to introduce a little myself. I graduated in a university, ZHEJIANG from Iran, in Tehran in 96, and we start to manufacturing the 2D laser cutting machine in 98. And after that, I established a company, Asia Laser, in 2004. And in 2015, we start to manufacturing one robotic laser cutting machine for home appliance company for production home appliance parts and cutting stainless steel. And we prepare and invite some participate from Iran and from China and from Europe, many person to some conference in Tehran in 2015 and 2017. And I am member of optics department regarding the government of Iran Laser and Photonic Committee. And I have some training about laser in Lambda Physics company and in Euro Laser company in Germany and in FANUC and Amada in Japan. After this very small interview about myself and about our company, why I attend to this conference about I want to introduce to you and all of your guests a little about the situation of market and situation of laser material processing in Iran. Because regarding some politics, maybe some person didn't have this information about what's in Iran about the condition of laser material processing. Therefore, I want to start this a little maybe the difference with your other presentation about the technical or about some technology. I want to a little open to you the situation of laser material processing market and what's happening in Iran, especially for any kind of material processing. Again, I have to say to you, I am from Iran, I am from Persia, I am from a country of light and country of color, as you can see inside this very, very nice and very, very colorful picture about some very old and historical plants and home inside Iran. And I am from a country, some scientists like Mr. Ali Jawan, inventor of helium neon laser, and some other person that start many things about optics theory. As you know, the laser material processing in the world is a main base of laser application in other many kind of application, and the main parts of this kind of application, I can say after communication with laser, is laser material processing. Therefore, is many important parts in photonics and in laser side. Therefore, with this interview, I want to talk more about the position and the wide of laser material processing in Iran, and this chance for us for say to you which kind of laser active in our market and which application we use here. The application of laser, like all around the world, but especially in Iran, is automotive sector, into automotive industry. And sorry, this takes a little different. This is medical application and automotive application and petrol of and energy application in Iran, and also is electric and electronic box, elevator, and home appliance, and also bus manufacturing. This is some of the most application of laser material processing. And in next page, I can say to you the most important of them is about laser cutting. And you can see most of application that is normal in application of laser is cutting, welding, and laser cleaning, and laser additive manufacturing, and some of them. The most application of laser in our country about laser cutting and 2D or 3D cutting. And let me talk a little about the history of the laser in Iran. In 92, first 3D laser cutting come to Iran for cutting automotive parts in automotive industry, and first 2D laser in 95 come to Iran for cutting generator in electric industry. And the first fiber laser 2 or 3 days after start this market in Europe and also in Turkey, because near to us in 2012. And about the quantity of laser and now working in Iran, especially in laser cutting, is around the 1,000 laser metal cutting now working in Iran, and with a power of more than 500 watt, and something around 20,000 laser non-metal cutting working in Iran, and around 20 or a little more than 20 3D cutting, most of them in sector of automotive. About the kind of laser working in Iran, we can say to you CO2 high power laser from 500 to 15,000 watt, fast axial flow laser, and a slab laser with excitation of DC or RF excited, and so to seal the laser from 60 watt to 400 watt, glass tube laser or metal tube laser now working here, and NDAG laser with pulse or CW laser for many kind of cutting, welding, and another purpose working, and fiber laser from around some 500 watt and up to 6,000 watt, and some disc laser and excimer laser for research and development, and especially in material processing for cutting and drilling, and femtosecond laser for some special purpose we have in our market and use here. With this ability of machinery in here, we have this chance, of course, after Turkey, we have this chance for go and do service for our neighbor all around our country in Middle East, and like Iraq, like Arabistan, like the Arabic country, and also in north of us in Azerbaijan and Turkmenistan. And I introduce and a little talking about some company and some activity of them here. About laser material or activity can divide to many kind of parts. Some organization like research and development inside research and development company, R&D company, and also in university. But I want to more focus about some private company working about this as a manufacturing of machine or as a user of machinery for laser material processing service. This is our first R&D working and start to do some things. This is one part for kitchen sink, and this is our first test robotic laser cutting. You can see here we start this with I think is sound is not good, no need to continue with this. This is in our workshop, we start about this, and all the design of this machinery inside Iran, our team worked about that. And this is my some other friends inside Iran. This is Noura company, is the manufacturing of laser additive manufacturing with SLM technology. They use a fiber laser 300 up to 500 watt for this application, and this is a nice product of them for 3D printing machine. And my other friend, this is company Novin Andish Industry, that under name of a brand of Boyer, prepare very with a very huge invest, start to manufacturing of this kind of CO2 sealed off tube laser. This is main usage in advertisement sector for cutting non-metal. They start in 2020 for preparation this product to our market, and most of them wants to export to another country. And this is another person, another team. This is just some sample of product and working inside our country. Parto Sanad ZHEJIANG is one company that's with high quality product this and export some of this to other country, this kind of laser machinery. This is another company, Faran Nuran, for working and manufacturing of laser metal cutting. And some of company in here have a small business and workshop for working and service. This company is with some of laser from Switzerland about the cutting, and they have a good service for automotive and some other company and production. This ARPA laser company with many machinery from Trum, from Germany, and they have a very powerful R&D working in sheet metal manufacturing. And some other purpose that we have a lot of usage in our market is a welding, especially in jewelry and in some very high technology and very small parts and very sensitive parts for welding. And this is another kind of service inside Iran for, again, additive manufacturing. This is a fellows from Kusha about this kind of very special product. And also we talk about this product very special and with for low quantity is very good and very effective for market about the time and about the price. Also, I have to say some things about annual events. Every year we have some events about laser, like exhibition, like a conference, and about many things about laser material processing with additive manufacturing or rapid prototype or something like this. And we invite you to participate to this via some social media. And this is 2 years ago invitation and some speakers and them. And this last conference about laser with 2,500%, 250%, and most person from Europe and some person from China participate to them, and some exhibition, and especially this machine manufacturing inside Iran for automotive parts, big parts, and this is a medical laser exhibition. And this at near to end, I want to say the industry is alive. This about this worldwide problem about coronavirus, and all person with laser working. Thank you very much.
Thank you very, very, very much. I'm going to try again. Mamnoon, thank you very much for a great presentation. I had to say one thing before we had the discussion, which is for the YouTubers, the people in the YouTube channel. Of course, YouTube doesn't allow us to stream 24 hours. So check the chat in the YouTube channel. We are going to switch to another channel in YouTube. And if you are lost with this, just go to Epic Photonics and it's the first link. And then you can continue watching this amazing and completely crazy show. Hamid, I have here 572 companies who want to do business with Iran. How we can make it happen? What kind of challenges or problems or room for collaboration do you see with the companies in Epic?
At this position, main problem is sanction and embargo from US direct to Iran and about money transfer. But if any person wants to work with Iran, a little hard, but can work, no problem. I am some relation with many company from, for example, in Eurolaser from Germany, in Hamburg, and we have, for example, all of our laser cutting machinery inside automotive sector come from Prima, from Italy. And also we have a lot of machinery from Switzerland, from Bystronic. And therefore, we have this relation with them regarding sanction very, very hard. I have to say this a little hard. We have to wait for what's happened, what will wants to do Mr. Trump.
Thank you. I want to ask you something different because I have been traveling around the world and I meet very, very good Iranian scientists everywhere in the world in photonics. You go any university and there is somebody from Iran who has a PhD at that university and now he's a professor. How is the education in photonics inside Iran? Is there a clear roadmap for training people into being educated in photonics?
Before this kind of problem, political problem happens, a lot of instrument and in a lot of laboratory start to buy and prepare some tools for this. Therefore, we don't have any problem about tools for training, but and we have a lot of scientists come back to Iran. Regarding training laser, we are in very, very good position.
Fantastic.
And I want to say something. You talk Farsi very, very good.
Thank you very, very much. Of course, I have a lot of friends in every part of the world.